Hello, everyone. This is Nick. I'm a director of events of Geekle, and we have Ed here with us, the CEO of Geekle, who has some words for the intro, but it seems he has some connection issues. Ed, can you say something? We are waiting for you to connect. Ed, can you hear me? Hey, hey, Ed. It seems that his connection is not working for some reason. Oh, he's reconnecting. So, hi everyone. I wasn't ready to be the first person on stage today, but I already introduced myself. I'm a director of events of Geekle. I located in Ukraine, Kiev. I'm out of Kiev at the moment, so I'm pretty self-placed. And this event is going. This event is live. We weren't planning to cancel it at all. We're doing as much as we could. All the speakers are ready. All the like all the program, the whole 3 days of this event is basically ready, and the moderators are also waiting. And like 5 minutes from now, we are waiting for the first speaker. Also, I recommend you to watch this from our platform. We have like a big message about the whole situation that that we have at the moment, and the Geekle stands, because Geekle is like the Geekle project. All our events, it was created by Ukrainians. It started in Ukraine, and we're still planning to continue doing that, even if we're holding out somewhere. Um, I'm going to, yeah. So I guess our CEO had some connection issues, but I still hope he will be able to join later, to during the next break, probably, to give his speech, because yeah, it's pretty important to hear what our CEO can say. Oh, Ed is here. Ed, is your connection working? Can you maybe signal me? Oh, yeah, sorry folks, this was like hope is uh yeah, hope is everything okay for everyone where you are. So, Ed, we have still some time before the first speaker. Can you signal me if you're ready to join the stage and say hi to everyone? Uh, let me try. Hey, Ed, you hear me? No? Nope. Still no. Like, Ed is actually like he's not in Ukraine at the moment. Oh, and
Hi
I
there.
guess
I'm not
my connection is also good.
sure if you can hear me and see me. Nick,
Yeah, we can see you, but
can
I
you?
hope, yeah, we can hear you. We can see you finally.
Well, guys, I'm not on the proper internet now. Can you see and hear me?
And unfortunately, you are lagging. Well, you are lagging. So, yeah, you froze. Uh, so I guess,
Some
Ed, I guess the best.
words. Where you from and
Yeah, Ed, you're lagging. So I guess we should, like, you should definitely find better connection for the next maybe break after the next block, and to talk with our audience. Um, but like, I'm going to, I guess, because I have 3 minutes left for the
excuse me.
intro.
I have switched to another Wi-Fi. Can you hear me now?
Yeah, I can hear you. I can hear you now. Finally, yeah, Ed, you have 3 minutes. The stage is yours. Oh, whoops. Yes, so sorry, guys. We were really not ready to all the situation. But I'm glad we are connecting. I'm seeing numbers of people connecting, getting ready. Because yeah, we were planning to start in 2 minutes with the first talk. We just wanted to have this intro. Sorry, we weren't able to do it properly. Because yeah, I guess what's left for me to do is maybe say hi to our first moderator today. So the first moderator of the session is Otavio. Hi, Otavio. Oh, actually,
Hello, Nick. Hello, Ed.
Ed, is it working for you? Can you give us some final words before we
Hi,
start the
hi,
first
hi,
session?
everyone. Yeah, hi
Yeah,
everyone. I finally found a spot where the Wi-Fi connection is not that poor. I hope you can hear me now. Can you?
finally, finally, yeah. You have not much time, so I leave this stage to you. Sorry, Otavio. Let's give Ed some couple more minutes.
Yeah. Okay. Anyway, I'll start and in a minute or two. Um, just wanted to say, people, you can't even imagine how happy we are to see each other, even on the internet now, because we're far from each other. We're hiding in basements. We escaped from some of us are escaped from country, because yes, actually Geekle is Ukrainian project for Ukrainians. And actually Geekle was born during the pandemic, when well, no offline conferences was possible, and then we just started Geekle. Okay, it's time to announce that Global Architecture Summit by Geekle is finally, and we never expected to see it again, but we're live. Thanks God. I mean, literally live, because we're in Ukraine, and I'm in Romania now, but all others, or most of our guys, are in Ukraine now, and everyone who has internet still working on Geekle community, on Geekle conferences, so to deliver our mission to do that. Can I ask to join Paul? Paul, hello. How
Hi.
are you, man? Where are you now?
I'm freezing cold. I'm freezing
Freezing
cold.
cold. Freezing
Yeah.
cold. You are in Mukachevo, as far as I know, and it's
Yeah.
quite safe there.
It's quite safe, yeah, but the we have some problems with internet and with electricity and with heating, so it's like there are certain groups that basically try to damage the infrastructure in the city, and basically the city just has no heating right now, so it's pretty tense. It's pretty tense. Fortunately, uh, no shilling, no bombs. It's not as bad like in Kharkiv or Kiev, but so many people, and so basically we're sleeping like 5 people in one room, 2-story beds. Um, yeah.
Yeah, okay, man, hold on there. Actually, the more, like, the closest person to the very hot spot is Nick, actually, because he is around Kiev, and around his village is now sometimes bombing, even Russians' rockets. Anyway, people, thanks for joining us. Just write in chat where you from, where you watching us from. We hope you are much more safer than we, but we have the bunch of content for software developers who was working for almost 6 months to deliver, and right now we have lots of speakers with us are ready to deliver the content. And I thought, once we have a war, we probably should postpone this event. And then I thought, okay, why? If we have everything ready, you guys are waiting for this content. If everything is packed, actually, why don't we just deliver? And
Oops, Ed is lagging
Yeah, so
again.
I guess I can continue instead of Ed. So basically, we've made a decision to continue with the event, and we believe that this could be for a better cause, for a greater cause, for the people who are who are suffering. And I think it will be safe to announce that uh, we have made the decision that all the proceeds from the March events, from everything uh, that we have, uh, we will have as proceeds in March. We will donate it to those who are refugees, to those who are peaceful people, to those who are struggling from this war, from this unprovoked war that Russia is started against Ukraine. And we believe that with the help of all the Ukrainian people, with the help of international society, with the help of our community, our Geekle community, development community, we believe that uh, we will be okay. We believe that we will see greater and better days, and we believe that we will have many, many more new conferences. We believe that we will have new offline conferences, and we believe that in nearest future we will host an offline event somewhere in Kiev, and I believe that we will be super glad to have you when we rebuild the city, when we restore everything, and we believe that we will come up even stronger and even more stronger and greater, and we will have some cool new projects for every one of us. And
Yeah,
yeah,
absolutely. Absolutely. Okay, here is my statement. People, during March, every dollar we get, we will pay it to foundations, to refugees. We will do it for charity, everything. That's my statement. Everything. So that's the way how you can support today Ukraine. Buy any ticket you want. We of course we will deliver all conferences because we're online. Some of our people are abroad, and we will do that for sure. But so buy as much tickets as your heart show you or tell you, and we will deliver all this money to charity, to foundations, to refugees, and it will be transparent. I will show all income we have, and will show all outcome where we paid those money, and you will see how you impact with the Ukraine and all, and you support this situation. uh, uh, about 20 people we have overall in Geekle team, and now uh, 15 of them are not in their houses. But Geekle still supports still those who have salaries. Still, we still pay salaries. We still support our team. So no worries about that. We survive, and we will keep going. Anyway, thank you very much for being here today. Thanks for supporting for those who are open. And yeah, let's move to the content because the war is, yeah, is going, but the world is not stopped, and technology is rolling, and we have bunch of news of what we have and what's new, and some interesting stuff. So Nick, what's the agenda now? Now the
Well, we have,
stage
yeah,
is yours.
we have the first speaker waiting, the first moderator waiting, and we have 50 speakers ahead of during 3 days. So
Oh
let's
my
not wait.
God,
Let's not.
50 speakers. Yeah. What about Xenia? Is she online right now? The community
I
manager
think
who
her
gathered
connection
this.
is not as good. Actually, it's not connection is not as good, and we're already late. We're really late, so let's not
So we
keep
need.
them waiting. So let's just
Yeah,
leave the stage to the
Xenia, we
moderators.
are with you there. Like, hold on, and thank you for being with us and make this happen. Yeah, let's do it. Let's invite moderator and
oh,
speaker, and let's
let's
do it.
roll.
People love you.
Yeah. Good luck, everyone.
Oh, hey go. Hello, everyone. Hello, Ed. Thank you, everybody. We are glad to be here again. So, everything that you donate, we'll give to Ukraine Foundation. So, please help this delicate situation. But let's start the agenda. Today, we will talk about more scaling SIS integration with cloud. And with me, we'll have Asif. Hopefully, I say your name correctly. Asif Nan, a cloud solution architect at Microsoft.
That's right.
Hello, hello.
Hi everyone. Hi Tavia. How are you?
Glad to be here. So, did I say your name correctly?
Yeah,
Asif?
absolutely. Cannot be any better.
Oh, I'm glad to be here. So, please, the stage is yours.
Yeah,
Share your screen,
yeah.
and we'll
I'll
be
share
here.
my screen. Yeah, just quick question. Because we have already passed 8 minutes, so should I complete within next 22 minutes, or should I cover it in the next 30 minutes?
Uh,
We can be late. We can be late. No
Okay.
worries. We'll
Okay.
catch up.
No
We'll
problem.
take time from the break.
Yep. No problem.
yes.
I'll share my screen. If you can just confirm, you can see it.
Okay, let's see. I have too many options here. Here you go.
Okay. Perfect. That's great. All right, everyone, thanks a lot for joining. And firstly, we all know the situation, what's there. Yeah, the war situation. So yeah, obviously, all my best wishes to everyone who is under the situation, and hopefully everything ends soon. So coming back to the agenda today, we will be talking about scaling system integration with the cloud. Um, so the idea behind this topic is more about basically bringing in some sort of enlightenment and level of basically understanding of what exactly the integration ecosystem looks like. And then also integration has been since the inception of software development. Whenever we created the second system, like in the very inception, that was the time when we started to think about that there need to be an integration between the first and the second system. So it's a very inception concept. It's not something new, but the only thing which has been changing and evolving is more about how we can stretch and scale the integration capabilities and capacities. And with the cloud, things have changed obviously dramatically. So just to give a brief overview about myself, I'm Asif. I'm a cloud solution architect at Microsoft, and I basically live day in, day out around the cloud space. My background has been pretty much very intense in the integration space, and I basically love learning as well as educating anything around integration. So uh, as far as first thing, I think so the question which arises is what exactly is integration? And again, integration might be different for a different point of view, and obviously we can consider different use cases about integration, but I'll try to make it as layman possible. So looking at the scenario, let's say you are an individual, you are doing let's say very excellent job, and you are a superhero in your own space. But as a silos, you whatever you do is just limited to yourself, and you are not creating a real impact. And that's where the community comes up. So when you start to integrate with the community, that's where you create some value, and your actions and activities makes more content out of the efforts which you are putting in. So that's integration. What you're seeing on the screen is a lot of different gadgets and different components which includes like your meters, which includes shockers, and these are all mechanical gears and stuff like that. In their own silos, they are pretty good, they are very important, but obviously they don't make a literal value to an end consumer or a wider audience or a wider customer base. And that's where when you start to put them all together, or when you start to literally integrate them, that's where you start to create things like automobiles, like airplanes, like your boats and ships and stuff like that. So integration is again there. Now coming to our core concept about the software side. So you might be having a lot of different systems, which might be, let's say, your integration systems, which might be something like your regular enterprise system, things like your AI systems, things like your reporting system, analytics system, and all that stuff. And they would be perfectly fine in their own silos. But obviously, will they make a lot of value if they are running in their own silos? No. As an end consumer, you need to have those sort of integration. And that's where when you start to put them all together, you can build more literal solution which are valuable to the end consumer and wider audience. So integration is definitely what makes everything more valuable compared to their individual existence. And that's why integration is very important to be considered as a first class citizen in the software ecosystem. So having said that, since we have already like this is the the fundamentals around what I feel how integration should be think about and thought about, because you can't consider integration to be something secondary. It's core to your entire software development, whether you are building simple applications for end B2C consumers, direct like business to consumer, or you're building a business to business systems, or let's say you are building enterprise system. In either of those situations, integration is the core to your existence. Now, coming out obviously all these jargons and stuff which I did talk about, that's all good, but literally like why should you care about integration? And that's a very fundamental question. As a newbie, or maybe even if you have been in the industry, you would start to question like why exactly should I be consider like integration as a first class citizen, or maybe as something primary to the entire software ecosystem, and why exactly should I put effort to learn about it? And that's where I would like to show some things around. So these are some of the presentations. These are some of the cutouts which I have got from the web, and this is more about like Microsoft bought organization called ClearSoft, and because it had a very outstanding low code, no code uh, business process monitoring management system. So it was obviously organizations like Microsoft do like consider when they put those investment. Now, on top of it, if you look at this is the quote from the brand from the CEO of Chain.io, Brian Click. Then we can also see Census raised 60 million, so a lot of dollars are flowing in this space. Citrix did had a tie-up with TIBCO on their iPaaS, which is integration platform as a service. We can see Dell, which is another big player in the software industry, has a 4 billion deal with Boomi, on Boomi, which is one of their product. SnapLogic, 165 million. So yeah, it's not like something which is secondary consideration. It's primary component in the industry. A lot of large big players from SAP to Microsoft to Google to MuleSoft and Dell, everyone is investing on it. And obviously you should start to think about, if you have not already, what exactly are the challenges which can be sorted out with integration, and what are the most decent and elegant ways to utilize this technology or the ideology. So coming into a fundamental around integration. So as I said, since the second system was built in the inception, we started to think about integrating it with the first system. And I've just taken a very simple and basic use case of what an integration looks like in a prehistoric era or in a conventional world. And I can tell you, even I've seen in the current world scenario, a lot of organizations, even large enterprises, running integration these in the similar fashion. So technically, if you look at the screen, you can see there are four different components, or four different systems. We have system A, system B, system C, and system D. Now, like literally, if we want to translate this, let's say this might be an enterprise. They have four different large systems. So one of the system might be their HR system. Second is, let's say, system B is their payroll system. System C is, let's say, their sales system, and system D might be their, let's say, inventory system. Now, as you know, HR system, payroll system, their inventory system, and their sales system, all these are definitely interdependent, because as an HR system, you need the detail of your or the salary details of your employees, which will be in the payroll system B. And as a payroll system, you would need details of your sales from your system C in order to build, let's say, whatever credits which you want to add to your specific employees, because they did a good sale or a bad sale, or they were able to achieve the target or not. Based on that, incentives are decided. So system C information would be needed by system B. So in all those cases, what you do is there are different integrations which are created between A to B and B to C and C to D and D to E. So these are very straightforward. Ideally, anyone who understands software would think about creating something like this. And this is what we call as a line of sight integration. So each system is directly talking to the second system, which it is relying on or dependent on to enrich some data and needs that data to process whatever activity that system wants to do. Now, this is fine. There's nothing wrong in this, but eventually in due course of time, what happens is your system gets complicated and your system requirements increase. So let's say your sales data is needed by your payroll system or HR system, and then your inventory system needs your sales data as well, and stuff like that. And that's where all these different point-to-point integration increases. So this basically leads to something called as a spaghetti effect. The reason why I'm saying spaghetti, and it's a very common integration terminology, because now we have created a spaghetti where everything is talking to everything, and eventually it will be really hard to even understand what particular integration is built for what purpose. I know there are different commentary around that space where we say that, yeah, we do document about every integration or whatever point line of sight integration we build, we have a detailed understanding, but how long are you able to maintain that that particular documentation? So it basically leads to a unknown scenario, and even it has a lot of dependency on the people who create it. So that again leads to a lot of chaos when they leave. So it's a sort of a spaghetti that there is a lot of data redundancy, because data in A is also shared to B, and then B is also keeping a copy of it. No single source of truth, which is the core to any like decent and clean system or clean environment, enterprise environment. Because if you have data sitting at multiple places, you will never know which particular data is your source of truth or the latest and the greatest data. So again, no single source of truth. And again, there is a limited scalability also, because let's say tomorrow you come up with a new requirement for a data exchange between B to C. You have to basically modify that B to C, and then you see that, yeah, you get a better performance. So now you have to go into each of these line of sight integration and improve them. So all those challenges are there, and that's why it's not a very good design to have line of sight integration. So what exactly can be a good solution to that? Conventional, that the last one which design which we saw was a conventional design. Now if we want to optimize it, that's where we start to think about the MDM based, master data management based integration platform design. So in this, what we have is we have a single source of truth which is sitting in our master data management databases, and then rest of the systems which are like A, B, C, D, exactly to our previous use case, they interact with the master data. And if they create some data, each of those system A, B, C, D, when they create the data, they publish it to the master data management. And when they want to retrieve some data, whether it is published by them or by some other system, they basically contact the master data management and extract the data. So there are different avenues which are designed or which are considered in this design, and this design is also called as a mediation layer design. So mediation layer is because this layer in the middle is basically becoming it's now acting as a mediator to rest of the systems. Now the systems are not talking to each other, they are talking to this one unified layer, and the data is also managed at the same layer. And then in order to cater different type of consumers, we basically enrich this layer with different type of endpoints or different type of capabilities, service capabilities. So as you can see over here, I have covered the bare minimal like mediation layer servicing capabilities. Things like this layer provides an API endpoint based model where you can extract the data from the MDM. There is a service layer, which is the regular web service model if you're coming from a historic background. And if you are not something on the, like if you're not dealing on the HTTP level thing, then you might HTTP or TCP, and you need something like a full load or batch processing. That's where you have that batch capability as well. So the benefit about this design is that you have a single source of truth. The simple ingress egress endpoints are there. So at the end of the day, being a consumer, whether I am system A, system B, system C, or system D, I have a unified endpoint. I basically make a request on that endpoint, and I then get back the relevant payload which I'm after. Easy to manage, and BAU, the business as usual processes are much easy to implement on such design, because now I have to manage only one unified mediation layer integration platform instead of all the line of sight integration historically, which I was managing in a conventional design. And simple, and obviously because it's unified and single simplified in a unified model, we basically can enable and enrich it with a lot of monitoring and alerting as well. So that brings in a lot of cleanse environment in respect to proactive model of knowing the issues or extracting or getting the details of any issue which has come up, because now we can monitor the entire mediation layer by a lot of different telemetry monitoring systems. And then at the end of the day, if any issue is reported, then we can get into that monitoring system and extract the information pretty decently. So that's where the lot of value comes out. And if you design the system well enough, then you can have all your information, which is like any sort of request response between coming from the system to the mediation layer, would be aligned with a relevant sort of payload model, which would have relevant IDs, caller IDs, and stuff like that, so that when you go into the log and you are validating or researching any issue or doing a forensic of any issue reported, then you can basically identify that the issue was created because system C made a call and that call failed because of X, Y, and Z reasons. So all this is pretty good, but the interesting bit is um, like the scaling part. So this is all good. When we have 4 systems, we know our scaling requirement, and all those 4 systems may be doing maybe whatever 50,000, 100,000 requests per day or whatever. So we can design that scale upfront. But let's say if you are in a use case where you don't even know what the scale could be, so then in that case, whatever design you go with, let's say if you're going with this optimal design, you need to have that scaling capability both at the master data management level as well as your servicing layer, which is your API or services, which should have that scaling option. So firstly, let's understand what exactly is scaling. So scaling is basically a concept which has been pretty used in a recent time since the cloud came into the picture, because now the first thing which cloud commits is that it gives you the unlimited scaling power. So in this scenario, what in this particular slide, what you're seeing is it's more about the different scaling types. So we have 3 fundamental scaling types. One is the vertical scaling, horizontal scaling, and the last is a breadth and depth scaling, which is an integration of both vertical and horizontal scaling. So in the vertical scaling, what happens is you have system, you have consumers, they are requesting the system is performing all fine. Now new set of consumers come in, and then your system gets overloaded. So what you do is you go and increase the capacity by increasing the memory, increasing the hard disk, increasing the storage, and all that stuff. Now eventually you get to know that more customers are onboarding, and that's where your the upscale system is still not performing. So then you go and upscale it further, and that's where you get your things served. Now the thing is that there is a limit to the number of like memory or storage which you can add to these sort of vertical scaling model. So the pros is that obviously its application is compatible, and obviously any legacy application can be brought in. It's simple. It has been the legacy model of architecting and the modern architecture both would be able to survive with this model. Licensing is much easier because you are not increasing your number of servers. You are just increasing the capacity of the server, so same operating system or whatever security components you might be using. On the con side, obviously there is so much where of what you can add as a memory or as a storage. So there is a limit to that. There is a risk to downtime. If the server fails, then you are just destroying the entire user base, which might be coming from different sources. So all that are different challenges. So that's where the next type of scaling comes, horizontal scaling. So in the horizontal scaling, you have different type of end users who again ask requesting to a particular server. The server basically gets start to see new requests coming from a different new set of users, and that's where it says, okay, I'll create a new instance of it, and then further the user base increases, and then what the environment does, it creates another instance. So pros about this is obviously it's a much more scalable, easy to upgrade. If you want to upgrade specific areas of your particular infrastructure, you can go and do and scale on that. You are not impacting everything. It also support linear application amplification, because you are scaling, and that scale can go to any limit depending on your provider or the infrastructure which you have set up. So you can have 1 VM, 2 VM, or if you are in the cloud, you can create hundreds and thousands of VM as well. So the scaling is unlimited in some sense. Now the less cost on the licensing side is also there. On the con side, the challenge is it basically it's a complex architecture to manage. If you are building an application or you are using an application, it is a sort of a distributed application model. Obviously, the monitoring also becomes a little bit complicated because the architecture is more horizontal scale. So you have to monitor not only one environment, but multiple, not only one instance, but multiple instances. So all that is a little bit overhead. Now coming to our third design, which is the breadth and depth design. So in the breadth and depth, as I said, it's an integration of vertical and horizontal scaling. So let's say your user base is contacting the server similar to existing. New user base comes in. You can make a decision of whether you want to do a horizontal scale by adding more servers, or you want to do a vertical scale by adding another capacity into the existing server. So let's say we did add additional capacity. Further, the user base was not satisfied, so you added or did a horizontal scale and added another server. Now the further user base came in, and then you added another server. So now this is more on a decisional side, that whether if the user capacity or user consumption is increasing, you can go vertical as well as horizontal, and you can optimize the cost as well. So pros are more about the licensing and can be optimized if you go vertical scale. If you go horizontal, then obviously the licensing will be required for each instance which you create. It The good part is it can be used to support like even the legacy software, so you can continue doing your depth scaling instead of breadth, and then that is very similar to your vertical scaling model. Cons is obviously it's extensive to manage, because now we are a mix and match of horizontal and vertical, and obviously the monitoring becomes a bit more complicated because the same challenges as the horizontal scaling comes into the picture over here as well. So next is more about, let's take a very simplified challenge on the scaling side, and how we can translate those scaling concept into a simple world. Let's say we are dealing with a housing requirement for 500 families or individuals. So I basically like the model which I basically think about in such use cases, whether it's horizontal, vertical, or any sort of scale, is either you can have a monolith sort of design for scaling, or you can have a micro design for scaling. I call it mono design or micro design. So let's say we have a requirement for 500 users, and then what we do is we basically say, okay, let's create a particular building which will basically be able to serve at least 500 users, and for 500 household users, and then they can basically reside in that building. And that's very straightforward. You create a building and then people live in that. Now on the flip side, if you look at the micro design, what we would do is, instead of creating one large huge building and waiting till the building is completed to hand over to those 500 people, we basically create houses, small houses, and then as and when the house completes, we provide that house to one of the families out of those 500. So firstly, it's more agile in respect to the implementation. So as the houses are getting built, they are getting handovers instead of that entire building being created first and then people getting the handover. On the flip side, also it is much more nimble. So if let's say one of our like household family says we want a different color, or we want a different ceiling height, that can be modified in this micro use case. But if it look at the mono, it obviously has a fixed coloring of the building, fixed ceiling height, fixed floor area, and everything. Now, the bigger challenge comes up when, let's say, the housing particular business went into a boom, and then instead of 500, now we have 5,000 families who want house. So if you go back into the mono design, it's impractical now, because now we have gone 10x from what we earlier had, from 500 to 5,000. So the only option is you create 10 buildings like that, and that's obviously not a very practical model, because that would take a very huge amount of time, as well as you would need all the resources and everything. Now coming back to our micro design, which is more nimble, what you can do is you can still continue building those small houses and continue to deliver those houses to each of those families as and when the house completes. So the scaling, when it is done in a micro design, makes it more simpler, more easy. And when we are doing a mono design, obviously things are more challenging to execute. So now, taking that mono and micro design in a real world scenario, let's say we are talking about an integration use case, and let's say we have we have some files which are of 10 gigs, and then those 10 gig files are basically processed by a processing layer. So if I quickly show you, so what we have is, let's say we have this particular file set of files which are in our SFTP location, and then this is basically our integration layer. So it might be something like BizTalk, Oracle, or MuleSoft, or something like that. And that layer is processing those files, that 10 gig files, and then at the end it goes to a normalized, semi-normalized, or NoSQL databases. So all that is pretty fine. Now, let's say those files get increased. So instead of 10 gig, now they go to 100 gig. So what we do is we do the same like vertical scale, increase the size of our processing servers, the integration servers, and then they are able to work it out. Now, the interesting bit is, let's say the file grows from 500 to 100 to 500, and that's where the capacity limit is reached, and now you cannot do much. So either you have to like leave those additional workloads which are coming in the form of data, or you might have to experience system failure now and then. So that's more on the mono model. Now coming into the micro model, so let's say the same structure, 10 gigs file, instead of having one big processing layer, what we have done is we have broken it down. So instead of passing that 10 gig file in one place, what we do is we use these small nibble processing layer, which might be services or something like that, and they basically break that big 10 gig file into a lot of different messages, and those messages are then passed on to our processing layer, which might be small processing capability, something like a job, a cron job, or something like a daemon job, in a container model, in a conventional model, whatever you want to go with. If you're dealing with cloud, it's highly recommended use some sort of container platform or container orchestration platform, and that basically leads the data into your persistence layer, which might be your NoSQL sort of thing. Now, in this use case, let's say the data grew, and now what we have is we have, instead of 10, we have 100 gigs. So what you can see over here is nothing has changed over here. We are doing the same scaling, but what we have now is we have this container or the nibble layer more stretched. So we have much more processing capabilities. And then in the last segment, what we have is, let's say that grew to 500 gigs. So when we had this 500 gigs, that's where we added more capacity. So this capacity being in the cloud can be stretched to whatever limit, and then that's the power of the cloud. So instead of failing, basically what you have is you have a lot of free scale and unlimited scale. And the thing is that the scaling is possible is because now we are breaking that one big thing into a lot of small messages, and those messages are each individually processed by our processing capability, which can be anything from a container to daemon or anything like that. So this is a very elegant way of breaking down your bigger problem and working it out. And I think so it's now practiced in a lot of segment in the industry as well. If you look at the big data segment, or things like Hadoop and stuff, they follow the same model. So they break that big problem into small chunks, and then they basically process those individual chunks and then recompile the entire request into an outcome, and that is served to the customer. So this is a very good model if you want to go forward with use the micro design. So Nibble makes it more powerful. Now, since we were talking about this particular segment of messaging, it's very important to even touch the eventing and messaging capability as well, which is very important and very core to this entire integration space. So let's say I'm trying to like just portray a simple use case over here, where we are planning to use, instead of just simple messaging, we can use a eventing model and messaging model, which make the integration much more decent and elegant, and it's much more scalable as well. So on the left side, we have a producer capability or producer layer, and then we have a consumer on the right. Now the producer can be anything. It can be data sources, it can be your telemetries, logs, it can be your IoT devices and all that stuff. So that's your data source. Now Then the next one is we have a processing layer where the data which is created by the producer is basically processed for internal persistence. So it can be API, it can be container model, it can be native services or daemon services. The third is the storage layer where we have maybe ephemeral or maybe permanent storage, which can be NoSQL, SQL, or maybe some sort of cube and structure, which is warehousing design. And then the last layer in the producer side is we have a eventing and messaging layer. And then the last segment is the consumer, which will be consuming it. So let's see how the design flows. So as you can see, what we have is we have set of files, data which is created, which is then passed to the processing layer. Once the data is received, or the data produced by the data sources are received by the processing layer, that processing layer translated into a data storage care sort of model, and then it sends that data saves that data into the storage layer. Now, once the data is stored in the storage layer, the next is where we have that data extracted out, and it goes into the eventing and the messaging layer. So once the data is received by the eventing and messaging layer, which can be a pull model, it basically translates that data into which was like initially a SQL or a NoSQL sort of data into two major components. One would be a message, another would be an event. So it firstly creates a message which would be persisted in a particular pipe, and then it creates a particular event associated to the message. Now, it's important to understand that the message are the full or a thick payload, which would be very much aligned to your data itself. But event is something which has to be very crisp, and it has to be the lean model. So it should have only the IDs or identity of your message, not the full message itself, because I've seen a lot of customers or a lot of people I've worked with, they start to use event as a message itself, and they make it very thick, and the purpose is lost. So your event should have only the correlation IDs or very specific IDs with which you can go back and like get the full message, and it should not have the full message itself. So let's say the data is created, and then it created two different data sets with one red and another message of the green type, and then two events are created. Now the story comes into the consumer side. Because it's an event, the eventing model works where instead of the consumer pulling the message from the provider, the consumer is notified that a particular message is available for them to be processed. And the way how it is done is these lightweight events are basically published to the consumer. Now, the way how you publish is there are different models, but one of the very common practices is that you provide a particular let's say endpoint on the consumer side. So the endpoint is where your event is published, and basically once the event is received by the consumer, now the discretion is of the consumer whether it wants to process or not. So you can take the event, you can just hold it in your ephemeral storage or whatever, and then you can decide whether you want to do it now, next day, next month, whatever. So the decoupling is pretty intense, because now the producer is not asking the consumer to take the message and process it, or take the like payload and process it. It's all consumer's discretion. Now the consumer would then give a thumbs up that, yeah, I'm ready, I want the full payload, and then the consumer would then pull the full payload of message from the producer eventing system. And that's where the payloads come into the picture, and comes into the consumer side, and it's all happy. So the same goes for the second message. The message is acknowledged by the consumer, ready to process. The message is then received by the consumer, and then consumer is all done. So there are a lot of benefits about this, because it's highly scalable. Again, there is a true decoupling, because now the producer is not expecting the consumer to process the messages in real time or the data published in real time. And then if the consumer is capable, it can do a real-time processing. It's not capable, running on a legacy on-prem model, can make a decision when it wants to process, and do it on its own speed, instead of doing it on the speed of the producer. So very helpful, possible to, yeah, you can do a lot of basically tracking as well. If you have issues, you can do a forensic, because this entire events are persisted at the producer side, and then you can rerun that entire event sequence in the same fashion and get to the data state which you want. So it's very useful in a case of where you have to go back in time and rerun the entire process from inception till date. You can do that with the eventing system. You have a single source of truth because the messages and the events are all persisted on the producer side, which is the owner of the data, and the consumer can basically anytime wipe their entire system and then just go back to the producer and ask for all the events, and then rerun all the events to get the data into the exact real-time state. So it's very useful to follow these integration practices. Now, these are some of the big players in the integration space where we have Boomi. So Boomi, Dell Boomi, Boomi is a basically product from Dell, and they are basically very popular in the MDM space and the API space for data management. So and the other one is MuleSoft. MuleSoft is more popular these days because they work on API-based integration model. So they work on connectors, and then you create a connector, and then that connector will be helpful in connecting to the APIs. So again, good to know about MuleSoft, Dell Boomi, MuleSoft. And the thing is that MuleSoft is more aligned to Java platforms. So if you are aligned to that, it will be more helpful. WSO2 is a very popular, another very recent one, which is working on a total API unification model. So if you have a lot of data sources, WSO2 can be that unified platform which would integrate all those data sources. TIBCO has been for a very long time. It's an IBM product. It's used for enterprise ETL, extraction, transformation, and loading. Very popular, again, used. Now, my personal favorites are mostly the cloud-based. All these other ones have a version of cloud, but again, not a native cloud product. So whether you're using Azure or AWS, there are integration services and platforms available in both the ecosystem. Things like logic apps and function apps in Azure space, and things like Lambda and your step functions in AWS, and there are wide other services which are available. These are cloud native services born and created in the cloud, so they have a lot of scaling capabilities. Highly recommend to basically go through those services, and obviously have a look on these big integration players, because they have a very unified and good practices guide as well available with them, which would help you if you are planning to build some sort of integration platforms. So yeah, so that was pretty much it from my side, and I think so. I've tried to not justify a lot of different integration use cases considering the amount of time we have, but yeah, this can be a good starting point for anyone who wants to deep dive into the integration space. So thanks a lot for watching, and thank you very much.
Whoa, that was great presentation. So everybody, please let us know if you have further question. Mostly was about Asif. Are you here? Not sure.
Yeah, can you hear me?
I can
Hello?
hear, but I'm not able to see you.
Yeah, I don't know. I'm trying to turn on the video camera, but it's just not letting me, because once I shared, now it's not letting me to show my camera. Something
Okay,
interesting.
but
Let me try it again.
we're
Um,
still able to hear you. So if anybody has questions, please let us know. Okay, I saw a lot of thank you. Yes, indeed, it was a great presentation.
yeah, no worries.
Uh,
I'll be still there. I think so. We have a Q&A session in the end. So yeah, if you have questions, I'm more than happy to address them at that time, or if you want to post it on the chat, I'm more than happy to answer them.
nice. We just received one question about the slide link. So if you're able
Hmm.
to share the links to us.
Yeah, yeah, absolutely. I'll be doing that.
Okay. Thank you, Asif. It was a
No
great
worries.
presentation.
Thank you.
And let's move on to the next one. So right now, I guess we don't have time to break. We're going to talk about design a mobile app login platform that scale for hundreds. And for sure, I'm not able to talk about this huge complexity. So I'm here with Shunzi Young. Uh, he is engineer manager of United Kingdom. So with us right now, let me share. Uh, Hopefully, I say your name correctly. So today is I use tough day to pronunciation name. So
No, that's perfect. Thanks for introducing. But just by the way,
okay.
I'm an engineering manager in Google and not being capable to manage the United Kingdom. So
Oh, okay. Sorry for that. So
no.
anyway, that's a huge company. So Google is, everybody knows Google as no United Kingdom. But anyway, so let is your show. Please share your screen.
All right. So
And let me see.
sorry, give me 1 second.
Don't worry. Yeah, that's the issue to do everything alive, right? So
Yeah.
sometimes you forget some words. But anyway, please, if you come here, if you're right here, please let us know where you're from and if you have any questions. So even he's not started yet, so have any curiosity, how does Google works, especially about the architecture mode, okay? But anyway, we're able to see
Can you say now?
share screen, yes. So the stage is yours, and go ahead.
Okay, awesome. Thanks everyone. But yeah, just before I get started, I just really want to give a call out and thanks to the organizers. And since most of them are in Ukraine, and I can't imagine what they are being through, and you have my huge appreciation in putting all this together. And so thanks, and hope you stay strong. So, okay, let me pick up my energy a little bit. So my topic is about design a mobile app logging platform that scales for hundreds of engineers. But before I get started, a bit of my self-introduction. My name is Shuzhi Huang, and I'm a software engineer manager in Google, and currently in Google Search App team, which helps people search, discover interesting topics, or carry out some assistant tasks such as setting an alarm, that type of things. And in Google, I'm mostly working on logging, experimentation, performance, and testing on mobile apps. In addition, I'm seeing myself with the passion to empower product velocity, allowing teams in big companies to move faster and more effectively. I'm also having some efforts in this area as well. So first of all, this is just a disclaimer and also kind of a preview of what to expect from this talk. It's not going to be an implementation playbook, so I'm not going to talk about specific details because context matters and you know more about your specific context. And also, we might have various internal infras that won't apply to the broader industry, so there really is not much point talking about them. But instead, I'll be talking about the abstract lessons and principles. I think they are pretty actionable, even if you are not working in the mobile world. And it should be an interesting story working through the decision-making journey, which takes into a consideration of techniques, teams, products, and culture. But also, before I get started, and first of all, I just want to make tribute to the team and many excellent partners. The talk, this is not anywhere close to a personal or even a one-team experience. It's a mix of my observation for experience that I directly or indirectly involved that came out from many great minds. Okie dokie. I think we can finally get into the topic. So, throughout this talk, I want you to put yourself in the shoes of the login owner for an app throughout the talk and take a moment to think about what would you do. So if you kind of own the logging problem space for your app. All right, logging. So what's hard about it? We know how to do it, so just log it. Right. Until at the point that we are releasing to the production, you might not want to turn on debug logs in production because it might be sensitive. It impacts the binary size. It could be spammy to users, etc. So you might just want to turn them off. And is that a problem if you do nothing else and just turn off your debug logs? Actually, doing nothing more is not too bad a choice. Things like Play Store offer some minimums that might be more than sufficient to start with, such as the daily active users, crash rates, or application not response rate. And you could rely on dogfooding and QA testing to mitigate the risk. It might be a pretty reasonable choice to start with, actually. So all is well, your app can start ramping up. And more or less, I call this kind of the stage 1, so the default stage that you don't do nothing else, just rely on what is provided as the default options. So that's to say, with this, and your app is rolling out, and the app continues to grow, gains more and more users, becoming more complicated in its features. And I think it probably won't be too long before you realize the default observability provided by, for example, the Play Store is not sufficient. And you might want to know more fine-grained details rather than just focusing on the app as a whole, such as how many times do users use one feature versus another in your app, how many clicks on one icon, how long is the task being carried out, how reliable is your connection to the server, and so on. And you need to collect those more fine-grained details yourselves. You might need an in-house solution for it as well. So for example, to be able to integrate with your existing experimentation frameworks and compatible with existing processing pipelines or other considerations such as privacy, security, costs, or performance. Right. So for an in-house solution, ultimately, you need to send those more fine-grained logs to the server somehow. The chance is that you already need to talk to your server one way or the other for business reasons, such as asking the server to serve the data to your app responding to user interactions. And instead of opening up a new endpoint, why not start simple by extending a business service a bit to also serve as a logging endpoint? You could do that by buffering into existing requests, such as in HTTP request CGI params or headers to the server. Or you could send a dedicated request to the server purely for logging and tell the server which feature is triggered, how does it end, under which network condition, how long does it last, etc., etc. So that will work, right? So in the hindsight, I call this kind of the second stage. So we don't do anything extra for logging, but just open up a small extension to the existing server, the backend APIs, and that could serve for our logging purposes so that we could have an in-house solution for logging. Okay, but this approach adds up to performance overhead, which is crucial to mobile users. For example, a separate HTTP request wakes up the radio and accelerates the battery drain. Having more payloads into the request increases the chance of packet loss and downgrades the business reliability. And processing something extra between the request and the result increases the user perceived latency as well. So, and last one, it complicates business system and injects unnecessary dependency. So overall, having an extended business service might work for some limited case, but if you are seeing to have more and more use cases like this for a better long-term solution, we need a better design. And I think a better design normally starts with a single responsibility. So in most cases, your logs don't need the same SLOs as your business service. It doesn't need to be as strictly low latency as your business logic, so that we could buffer them and compress them, being more thoughtful to users' bandwidth and battery. Logging usually can tolerate more data loss. It decouples from this solution decouples from a business logic so that we could configure its own threading or retrying mechanism without impacting the user experience. And you could even offer more flexibility by allowing configuring when to upload the logs to the server, such as when the app is not in user critical paths or in Wi-Fi conditions. And then as for the format of the logs, we can make everything as an event, and you derive what you want to observe from those events on the server side. By doing so, so for example, like you need them for monitoring, alerting, and that or product analysis. You just derive them from the events that sent from the client side. And by doing so, it gives us the flexibility and extensibility to meet the different data needs, whether it's to compress usage metrics, to monitor latency, to alert on a reliability threshold, to debug an issue such as finding correlations between events and outages, or to carry out some random sequence product analysis. So overall, this approach offers better performance and decouples the business logic. It separates the logs from their usage, which offers great flexibility. And the concept is simple to pick up for developers as well. So what they need to do is just log everything as an event. It's a pretty decent solution so far. So, okay, so in hindsight, I call this kind of roughly stage 3, where we have a single responsibility of logging service. And then we are treating everything as events, and it's simple for developers to just log all the things as event, right? So all is well, and the app is growing more. So not just on the users, but engineering teams as well. It's becoming more and more complicated with many, many contributing teams that likely one doesn't know the existence of the other. It becomes almost impossible for anyone to stay ahead of what's happening in the code base. Because change is coming from literally everywhere. So it feels like that the work in maintaining kind of the logging system for the app is no longer to keep a street in order, but to keep a city in order. And that scale brings a new set of challenges. First of all, it shakes our core principle that everything is just an event. Everything is an event. It's such a simple and appealing concept that quickly sticks. But then event indeed becomes everything. An event could be an error, a view, a low-level method call, a request, a feature trigger, and so on. It's like a mess of cables or the spaghettis and whichever you like to put it, that no one understands and no one dares or cares to touch. The first threat this situation brings is unmaintainable cost. Logging is pervasive, empowering many fundamental parts of the system, such as the primary observability of the system, and has very high stakes. So we have to get it right. The chaos of the events is a waste to users' bandwidth. And with the high population, it's unbearable to the server's processing power as well. Not just a matter of being more costly. With the growth, you'll collapse on its own weight and the app will lose all the observability, and that will be a very severe result. Secondly, you are losing insight to your app. You no longer understand it. If you want to compare feature A with feature B, you likely won't be able to do it, and if they are owned by two separate teams, since they might be using completely different syntax due to different interpretations on event. So for example, one might be using kind of a network condition, a network triggering as feature A, and feature B might be kind of an icon clicked or that type of things, and that you wouldn't know from an outside view. So you'll be comparing apples to oranges. And the problem doesn't stop there. The ability to compare metrics from individual events for monitoring and alerting has a lot of flexibility, but it comes with cost. First of all, asking people to configure or even hardcode their metrics and dashboard based on events increases their cognitive load. So there are more work to do for them. Second, it introduces a lot of dashboard silos, and that could be problematic. One example is that if the app has an outage, there will be tons of dashboards that belong to dozens of teams for the people who is on call to look at. Third, deriving insights from events in the server is more challenging than it sounds. Server doesn't have all the context on the client that are needed for your metrics. To accomplish that, you will need to send all the context to the server, which is a waste on users' bandwidth and server processing power, and could increase the privacy risk as well. To tackle those problems, we came up with a bunch of frameworks and libraries. In hindsight, I think most of them focuses one or both of these two categories. The first category is to focus on dedicated usage, such as dedicated libraries for latency or reliability tracking. A dedicated purpose means better visibility to offer a standard dashboard for each of those libraries to reduce the cognitive load of setting up your own. And the information could be pre-computed in the client side without exposing further information unnecessarily to the server. So easing the problems of cognitive load, which we mentioned before, to the server, and the server post-processing limitations like we mentioned above, so the problem 2 and problem 3. And the second category is to be more efficient in transporting and storage, such as to aggregate, batch, sample, and the logs, and easing the problem of high logging costs that we mentioned above as the problem 1. Right. However, it turns out that those approaches are more of creating problems than solving problems. We thought it would be crystal clear, like the playground runway, that depending on what you need, you choose the right path. But we soon realized the paths started collapsing into each other. The way we break down the problem space invites conflict. They are not mutually exclusive. For example, for a timer, you need a pair of start and end at least. But if you've already got the start and end, you've already known the reliability status of whatever is going on. So why double logging? We don't want double logging, which wastes the resources for everyone. It's a natural step to extend timer to cover reliability tracking and vice versa. So we ended up with many libraries who could do similar but different thing. So many trade-offs need to be made before a developer can start logging. Okay. So as a result, our feature developers are overwhelmed. They just want to log, but now they need to go through a lot of considerations before they can settle down one way or the other. Same thing can be achieved by different tools, results in very inconsistent approaches. A worldly path is needed for them. Not just for feature developers, the logging team is thin stretched with this fragmentation, since it's unclear how they fit together, how those different libraries or frameworks fit together. Arguably, the more energy we put into optimizing those solutions, the more we invite them to collapse into each other, and the more of fragmentation and complexity we'll be creating. Exactly like a cat trying to make a sense of VM balls. The more she plays with it, the worse the situation becomes. So, okay, lots of great engineering intelligence go into the place, but they are more fixing the symptoms. It solves or more of soothes some of the performance issue, but at the cost of velocity and cognitive load. I like to make the quote from the book Software Architect Elevator, that an architect's role is to avoid people exercising their intelligence unnecessarily, and this apparently isn't the case. Reducing fragmentation and making the whole logging ecosystem reasonable is really needed here. We need to regain the control. And there are two major choices here. One is to strengthen the control by having a team to get keeping all the logs. But besides we don't like it, it's just not feasible at this scale. Introduces John bottleneck. We went with a different route, targeting to flesh out a beta logging landscape that allows ideas to evolve in a coordinated way towards a more reasonable vision. And we started by forming a platform team. So let me sidetrack for a moment to clarify what platform team means to me. I think the best definition to me is the one illustrated in the book Team Topologies. And I believe the key phrase here is to empower value delivering teams by offering internal products to reduce their cognitive load in delivering values. So I think the key word here is to empower, and with the approach of offering internal products. So what does the team do in this context? I think there are two primary objectives. First one, empower the teams. Second one, maintain a healthy platform. So these two goals constrain each other, but they also go side by side. For example, a healthy platform is another aspect of empowerment that allows teams that don't need to worry about breaking others or being broken by others. Right. So, okay, first of all, to empower, we started by taking one step back to reflect on what are the problems we are solving here. I think one great merit of everything as event offers is that it focuses on facts rather than usages such as latency, reliability, or count. Usages could be endless. By observing the past events combined with some understanding of the system, we think there are primarily three layers of the app facts that people are interested in. The first one is the UI layer, so what users observe, things like the icons, the views that presented to the users. And the second layer is the business layer, so how users behave. So the user stories, like the user flows, the decision making that drives user experience. And the third layer is the system layer, which is how much is the cost. So things like the implementation details, the main low-level method calls, the background task triggers, that sort of things, and all the system health, such as the memory or the battery consumption, and also attributed to different components. The three layer offers a landscape that solution can evolve, complementing each other without stepping into each other. For the logging team, what they need to do is to polish each of the layer solution instead of chasing the endless libraries that mentioned earlier. So each layer has its own purpose and constraints that people can design accordingly. For example, in UI layer, it hides the views so that you might want to build your solution native to how the views are presented by the operating system. And for business layer, it's better to offer a declarative language so that different features from different teams can share similar syntax that is understandable by all. And for system layer, we might want them to be built in automatically, such as plugged into some low-level implementation libraries and being very performance sensitive by having approaches like aggregation, sampling, or buffering. Okay. And for other developers, like feature developers who just want to do logging, whether they need to do logging or just want to see the insights, they just need to ask themselves what layer of answers they are looking for. Then seek for the one or two options in that layer. So it becomes very clear and simple for them as well. Another aspect when it comes to empowering, I think, is the culture. Since we are seeing the platform team as to provide internal products, so the product ideologies apply here. Things like engaging with customers. By customers, I mean other feature teams who rely on the logging services, and valuing customer feedback, build, measure, and learn for our products, having the customer support, measuring for customer adoption, achieving product excellence. All sorts of these things apply here, and we can just use them to build our team culture and our engagement community and with our customers. Okay, so enough for the empowerment. Now it comes to the second important aspect of the platform team: maintain a healthy logging platform. So you can't just always empower and do whatever customer wanted to do. You also need to take into consideration of the big picture and make sure that all the things fit together and the overall system is running healthy. So with this scale, I think a fundamental requirement is accountability. The data needs to be owned. People should own their data as how they own their services or their features. Their data is part of their product, probably one of the most important part of their product. It's common nowadays that people maintain their own test suite, but it's surprising that log responsibility is sometimes like an afterthought, and it really shouldn't. So we tackle this by assigning owners to the logs, and that offers the fundamental step for all the following actions. The second approach is to align the language by offering a common set of syntax for each of the layer and make it declarative, well-serviced, more human-readable, so that different teams still doing their own logging, but their logs are interoperable. So it means that people from other teams can understand what it means, and also kind of the automations and tools can work together, and then sourcing from different sources coming out from different teams. So, okay, so with the ownership and the accountability and the declarative configuration, we are able to maintain a better logging quality with automation. For example, extending the syntax that I mentioned in step 2 before to imply log quality so that we could service name, build the tracking dashboard, check for log expiration. With the accountability, we can take automatic approach such as to downsample if the owner doesn't take action when the relevant logs are not meeting the quality bar for a while. And with the shared declarative configuration, we increase the adoption to more features or products without coupling them further. In fact, even to decouple them more. So it's not that all the logs that are in one place that matters, it's that they speak the same language that matters. For example, we make share the binary that could be bootstrapped into different instances or pipelines with configurations customized to particular features. Okay. So that's all I have to say as kind of the highlights for when it comes to empower and maintain a healthy platform. So how was the result overall? I think it's an all-winning situation. So from stream-aligned teams, which is a team topology term, or we can call it from feature team's perspective, they have a 3-layer well-lit path, so it's very simple for them, and they have many built-in dashboards because that we shrink the standards into the 3 layers and then build complete solutions for them. So no one stands in their way, no approval needed, and but of course they need to treat data as part of their product and maintain or retire their own logs accordingly, so have the data responsibility. And from a holistic product teams or an analyst team perspective, due to the shared syntax and semantics, they can understand the full picture, even cross teams. And from logging platform perspective, just need to provide 3-layer surveys. So polish the surveys for each of the layer without chasing endless libraries, and which leads to fragmentation and no purpose at all as well. And also, they don't do the operation for others, but the platform is healthy or even more healthy. Okay, so that's basically kind of the whole journey of the talk, but here's a recap. In this talk, we run through a journey of arranging the logging system for an app together with the app growing. So we started from nothing, just rely on the Play Store, App Store. Then we realized it was not sufficient as the app grows. Then we made it an extension to the existing business service. It's quick to start with by introducing a bunch of performance and complexity issues. Okay, then we settle down on a dedicated logging service that optimizes for mobile and logging, with the principle that everything is an event. Then, with the app grows further, the flexibility becomes unmaintainable. Next, there are various organic solutions evolved, but they were only addressing the symptoms, and not before long, it became hard to tell whether they solve more problems or introduce more problems. And last, I introduced how we did the more systematic design to flesh out the overall logging landscape with a platform mindset that significantly improved the system and created a situation that benefits everyone. And since we are in an architect summit, I wanted to retrospect one step further for architect's role. Looking back, I think step 2 and 4 are more of organic evolvement. There are many great engineering designs, but they don't look at the system as a whole and design for the system holistically. I wouldn't call them an architecting practice, at least from the perspective of owning an app's logging domain, but more of the organic iterations on the existing architecture. Steps 3 and 5, I think, are typical architecting practices here. They assess the whole system and define a system layout intentionally, which provides context for organic ideas to evolve and thrive in harmony. So preventing people from exercising intelligence unnecessarily and providing context that new ideas can thrive in harmony. That is part of my understanding of what an architect should be doing. But At last, I want to say logging is such a huge domain with endless challenges. The talk only covers one aspect of it. Going deeper, DevOps are in the DevOps and the details. There are many things to talk about. And going broader, there are many other topics as well, such as privacy, pipeline access control, API design, etc. So that's all for my talk, and hope you enjoy this journey. And thanks for listening. And again, huge thanks for the organizers and who put this together.
Oh, that's a huge pleasure to us, Shuzhi. It was a great presentation. Thank you. Sorry about
Thanks.
the small mistake about your company. Engineer manager at Google. And again, thank you and see you soon in the QA time. Unfortunately, right now we are a little bit behind. So we're gonna invite our next speaker. So thank you. And our next speaker will talk about GraphQL, chain for the best. And we'll be here with Anastasia Lysenko. Hopefully I say your name correctly. So right now she is CTO at 30 Chart. Hello, Anastasia.
Hello. Yep, it was some bit of correctness. Anastasia Lysenko, yes, it's me. Hello to all. I'm glad to be here. Unfortunately, now it's not so good for me because I'm a refugee at war in Ukraine. I'm from Ukraine. Hello to all from Ukraine. Please support us because it's a shock for us and it's very terrible actually to be here.
We wish all the best. You just remember that Kiko will offer the home off to Ukrainian Foundation. So Kiko will try to help as best as they can. So we're gonna do right. So we're gonna put together to return to war to the peace again. Hopefully as soon as possible.
Yeah, we hope for that so much. Because I'm actually with my 5-year-old son, and right now one more child is growing up in my tomb, so it's very hard for me actually because I'm pregnant and it's very terrible. So besides of that, I have been a software developer for more than 12 years for now. So
Wow.
today I'd like to share real life code and schema examples, how one can successfully integrate GraphQL as presentation layer and how to optimize the results. So you can use this presentation layer with any architecture that you want to use with. For example, I'm using it with DDD and Onion type of architecture. At the moment, it's hardly unlikely to meet a web developer who doesn't know or doesn't hear or think about GraphQL. And it's understandable, actually, because more and more developers choose to begin or continue to use it in their projects due to various advantages, such as single endpoint, extendable hierarchy, strict types, flexibility, among others. So for now, I want to share my screen. Please
Okay.
wait a second.
It is one here. Okay. No. Could you share screen again?
It's working?
Okay, okay. Right now I see.
Okay, great.
So thank you, Anastasia. The show is yours.
Despite the well-known fact that we are living and developing in the Stack Overflow and Medium era, each of us is constantly stuck with cannot be Googled type of task or question once in a while. Usually it happens when you want or should to create something big, to try a new approach. In those cases, you need as much information as one can get. The documentation always comes in handy in those cases, and once one begins with a deep dive in it. So this step is totally where you got covered with any type of information from the official site or any other currently existing sites with theory. But theory is cheap, right? You're not going to get paid for it. So on this step that includes taking off pink glasses and turning theory into a practice, you're totally limited by project language or your framework or some type of code that you are using right now. Today, I'd like to present a solution for using GraphQL with any type of server-side language, actually, because I'm using it with PHP and Go right now, but you can use it with any server-side language you want, because these schemas are abstract, so it will not be hard for you. You're not going to hear detailed explanation of GraphQL documentation or ports for PHP, Java, Go for GraphQL, so it can be easily adapted to any other server-side language. What you will definitely get in detail is an example of a GraphQL integration into a project, like one you can see on your screen, GraphQL Resolver. More to it, I'm going to describe how you can solve the most common issues that you're most likely to get into and the most working ways to optimize queries. GraphQL. Firstly, you should choose a GraphQL port that you will be working with. To fulfill that purpose, one can simply open the official GraphQL site and look for a language section in it. I have been actively using the first library in the PHP section and in Go section from Webonics for about 4 years for now, and don't have any major issues with it. They have a bit of specific error handler as for me, but it can be solved with a custom error handler that you can have. Meanwhile, for already working GraphQL API is in any language, you will need design and develop a resolver for queries, process schemas for these queries, and presenters to present the result for these queries. Secondly, choose between pagination options and implement the chosen option. I will get to it later. Create result handler and error handler. Who said it would be easy? We should create error handler too, yes. Create the endpoint where you can send your API queries and send a query, actually. It's not that hard, right? Let's review each step in detail. Well, let's assume you have a GraphQL request parameters and know what response it should return in its body. So now you should resolve this specific request into a specific response. The main tasks of any resolver are query a request and return a response. That's why it has only 4 methods. The first one is query. Here you can wrap parent vendor query method with necessary refining to resolve params. Here. The next one is create request. You can find it here on the screen. In this method, we can shape the request that we have got from the endpoint by adding query variables, so parameters, and query body as separate data attributes. So they should be separate for our convenience in code. The third one is create response. This is a perfect method for initializing assemblers for the use cases, DDD, or any other application service, for example, if you're using this one. But besides of it, we additionally have to integrate the middleware layer. For example, application validation check, authorization check, data access check, etc., and initialize use case with this data from this middleware layer. In general, we need to assemble query data into use case and return a response from it. I call it in my architecture as a use case assembler. I made also speak on this Worldwide Architecture Summit version 1 in August, so you can find it for DDD and Onion architecture as if you want to do it. And the last method is an abstract method, a response that needs to be implemented in each specific resolver. So, for example, create wishlist resolver. So you want to create wish lists. We keep it simple so anyone could understand the examples. That's why it's create wish list, for example. So you integrate this method resolve separately in each resolver for each purpose that you need to fulfill. Well, to get a better understanding, we can get a look into specific query examples. So, in our case, it's on screen, you have an entity wish list. Here, you can see a wish list. I keep text representation for better understanding in examples and not use any other parameters. And you need to create an object for wish list. So creation query may look exactly like you see on your screens for GraphQL. I mean, each query contains fields of two types: type of query and arguments for it. The type tells us that we are going to get a wishlist interface, you can see it here, and structured data in a response as a result. And the second field of type is arguments, this one, where you expectedly have a set of your input variables in this query. You can always get a good look into different input variables types that are existing in GraphQL on the official GraphQL site, linked here, or if you're using PHP or Go, it's Webonics. You can find also a link here. Wishlist schema may look like that one. Any schema should have an interface here and object that implements this interface. So you can see wishlist interface and wishlist object. The various output GraphQL types are always there on the official site. You can see on my previous screen that I'm, or this screen, that I'm using some of it. For example, string, non-null, list of is for list of variables, and so on. There are many of it you can find on official site or create yours. I covered it in the next slides. If GraphQL adapts talking about pagination, there are always a war. The infinite war between two clans. The first one is a cursor clan, and the second one is a offset. In truth, as usual with almost all word sites, they have not so many differences in schema. The main difference will be looking up at persistent storage. So here you can see cursor, and it's looking up at persistent storage with start cursor, end cursor, and the page next and previous expectedly. And the offset, it's pretty simple. You have first, offset, and total for looking up at persistent storage. I will not cover the types of pagination because it's not in GraphQL topic, but you can always looking up for it by Google cursor and offset pagination as well. Meanwhile, there is light at the end of the tunnel. If you roll dice and choose a pagination site, you should, for the chosen one, create a page info schema class, or name it as you want. Sure. It looks exactly, as you can see, like wishlist schema that you saw before. And here you understand that method render that you saw earlier is not going to help us anymore, just because it fits that it fits only one data record and doesn't have pagination in it at all. Not so much conveniently, yes. So that's a moment when you understand that you are gonna need two types of response presenters. First type for one node here, and another one that fits the collection of nodes for any of pagination queries. So here you can see that presenter, collection presenter, it not very has not much differences with one node presenter, so it's pretty easy to implement it. Naturally, our front-end developers nicely ask, or your API query users nicely ask, so nicely demand always valid schema and fine structure handled errors, preferably with error codes in case of something if something goes wrong. As you can notice from the render method in the previous screens, there is always a method get result fields in each of the render methods. I can go back and you can see it. Here. And here. And here. This method, as one can suppose from the method name, returns the schema of general result fields. So for any query, you should get one structured query result fields. And the query result is going to have this schema, any query result. In case of any errors, it will consist an errors, this one, set of fields, and you work with responses accordingly with it. So you can easily handle the errors, or your API users, front-end developers, or any of them can predict the result in case of errors too. The result handling schema may look something like you see on screen. Here, we should take a break from the code and get back to basics. As many of you may know, all object types in GraphQL solid schema should be unique. So only one object type for all of your GraphQL schemas, because they combining as one schema. This is a crucial moment to remember when you're adding the new schema structures. I'll explain this for an example. Hypothetically, you have web users and moderators, and for any reason, you need different schemas for them. Web users and moderators are both users, so your first thoughts will be, admins or any users that you should create. Your first thoughts will be, I can create two different schema types, name both of them as user, create user type, and use it in different resolvers accordingly with type. So to prevent code duplicates. But it's not possible because GraphQL schema is one big solid schema composed from all API schemas at the end. But what about result schema or page info schema, you might ask? Both of them are going to be used in many queries, in each query. Exactly. That's why you should add some kind of unique identifier for every query resulting in schema, for every page info or result schema in your queries. We are doing it via prefix. You can see it here and here. So it will be in example with create wishlist. It will be create wishlist type object type or create wishlist type result schema, and so on. So any of your schema, create user type result schema, create book type result schema, and so on. I think you'll get it. So it's name with prefix always, fields surely without, fields as you saw it earlier, result in schema is succeeded, code, error code, or simply the code, response code, and errors field. Also, as I explained earlier, we definitely need to return an error message and its code in case of any errors. So whoever gets a response can notice if something went wrong and may handle errors accordingly with these codes. I think it's perfectly understandable. That's how we provide the maximum possible error handling strategy and do not leave any of unpredictable for the API users cases as a result. Your API users will thank you for that. It's without a question. It's worth to mention that GraphQL schema errors like wrong type of absence or required field absence or of this field that you write in your query, define in your query, are going to be catched and returned by the vendor library that you're using in your site server language. So you can add your own exception for those types of errors. It definitely helps you or your users to get human readable exception traces. That's for you as developer, and for any of your users, you can always return those messages as you want to return. We have 2 points left from our Conquer GraphQL plan. It's make an endpoint and send a query. To make an endpoint, it's a specific task. I'll explain you how you can possibly do it with our case. Our endpoint, you can see here. It's only one method, actually. We do it with PSR 7 and PSR 15 for the more previous generation queries. So there are result and response. Keep it simple, and I think it's perfectly covered by vendor library in any server-side language. For testing queries or any purposes that you want to test your query or your API users, we're using Insomnia and Postman. And I can recommend both of them. Actually, all presentation links are clickable and will be in slides. If you can simply Google it. Congratulations, you can do a full circle of GraphQL query. Let's look again at the diagram where all elements are now clean and clear. So your request as a query with a context and arguments as data, application logic, your you can do whatever you want, and those middleware layers and those application services that I talked about it earlier, they are here. Schema decorator that you saw, consisting of node object schema, result with error object schema, and page info object schema. All of them you saw earlier on slides. So after combination of query schema and operations in schema decorator, you separately return query schema object as for query response and data as actually for response and data. And in resolver, you can combine it and return as a response. All of necessary code fragments you saw earlier for any of these steps. So it's a query with all of the schema, with resolver for any of your queries, and this resolver returns a response in each case. People say that web projects can be small and big, simple, complicated. But as for me, in my honest opinion, I prefer to identify projects as those ones that have good technical requirements and the opposite ones. Anyway, there will always be a moment in your project life when a simple solution is not enough anymore, independently on project size or type. It's always good news if your framework, library, code structure provides a ready solution for those cases, but in real life, it's rather the opposite, as for me. And very often, then we wanted to be all of us have some not planned code and structure solutions. I'm going to share some ways that can help you to avoid those wrong ways that we were stuck with these 4 years that I am working with GraphQL, and to solve some widespread tasks without reinventing the wheels. Above all said, it will be no good to leave you without pledge optimization advice. So I'm going to describe the most important options that you should not forget about, especially in the case of big data projects. It's optimization. Firstly, let's talk about a simple but almost never use case. If you're using GraphQL, it's a law. Actually, it's a law. One should always query with necessary data only. Forget about REST with all or any other, just on RPC, for example, with all fields in it. Forget about it. GraphQL has no place to let it be here for the future fields. You don't need this particular field in this particular query, then delete it. Simply remove. Get rid of all fields that you are not using. It's one of the most powerful GraphQL possibilities. You can request the same schema in any number of queries in different ways. You only need an entity ID, for example, a name in some queries, or a full pack of fields in another. Add fields wisely in query from your API user. So you define in a resolver and a schema, full query schema, I mean, but in actual query, where you want to query only ID and name, then query only ID and name. If you want to query some other fields, for example, type name and do not need any other, then delete it, remove from this query. Query only those fields that you need in this particular query. For example, this example, good to query wishlist items here in this wishlist schema in this particular query. Just because you're going to need only the name or ID to display in the cart or whatever, or profile lists, you should use only those that you need right now. Secondly, please design your schemas with caution. Trust me, you're not going to be happy to deal with recursions in schema recursion. For example, if in this code example in screen that you see, we add wishlist object to items. Sorry, in this example, wishlist object with items. It would be a recursion. Here, if after currency, for example, we add another wishlist. It would be a recursive schema because wishlist also has items inside. Indeed, we can hope that API users are not going to ask for a recursive schema, guided by the first piece of advice. But it's much better to prevent such queries at all. How you can do it? It's simple. The best solution here is to create separate schemas for both type of queries. The first one is for book with authors, for example, like this. Inside this author, and the second one is without authors and should be used in an author schema. So we have, we have a book separately, and the skeleton or notebook, simple note for book without any authors in it. Also, almost all GraphQL vendors limit the query depth in its settings by default. So please do not change it, because there will be a nightmare to deal with such recursive queries. Babonix is not an exception, so you'll always have a backup plan here, but it's better to not do it at all. I bet those of you who use ORM, any kind of ORM, know about the N+1 problem. This issue happens when the data access framework executes an additional SQL statements to fetch the same data that could have been retrieved when executing the primary SQL query. Or any other language in this ORM, I mean query language. The larger the value of n, the more queries will be returned, will be executed, and the larger the performance impact. GraphQL also had this issue because it has a resolver per field, not for the full query. But we can resolve this issue on both levels, GraphQL level and ORM. Let's see an example, as always. As you can see, it seems here that wishlist query should run as many queries as you have wishlists. At first look, you can see edges, page info, first offset, and that's all. But each wishlist, as you can see here, has its own subset of elements. So it grows accordingly with performance impact, and number of selects grows accordingly with the number of elements in each used schema. I wrote it here. The resulting amount is going to be multiplying the amount of queries, this one, to the amount of elements, this one. Therefore, M multiplying n queries. You're not going to need that, right? Actually, on the GraphQL side, it can be solved by using the data loader concept that had been designed by Facebook. There was one for PHP, but there are more for JavaScript, for Java, and for Go separately. So you can use it. The main issue with this solution is the lack of widely used PHP solution. So I cannot use it for my production projects because of the risk. But you can use it with your solutions. We are going to try data loaded PHP, but at the moment it's in earlier stages of integration, so I can't recommend it yet, as I described now. The possibility of using batches and caches looks promising, but on the ORM side, we are resolving this n+1 problem. We are using Doctrine as ORM, or you can use Hibernate for Java or any other ORM that gives us a full world of related entities, not directly loading options, such as lazy load or even extra lazy load. So in this case, n+1 problem is solved if you organize your relations between entities in the best practices way. And always remember about...
Anastasia, sorry to interrupt you. Just to give you 2 minutes before we finish.
You can read about it more on documentation. Thirdly, one should not forget about caching at any time. As one knows, there is no HTTP caching in GraphQL. This is a controversial topic, of course, so I should describe only a few points in a nutshell. If you're using authorization header that it's likely to be used for authorization in your queries, then you can't use a HTTP caching anyway. But you can always use application cache, front-end framework cache, or just do not send queries if you're not, if you know that there's nothing new here. For example, we have a gateway version on Go that balances queries slowly. As you can see here, you always can use NoSQL and do not have n+1 problem at all. See, we have made it together. This was a real code live example, detailed explanation, and I'm thank you for your patience and participation. You have a great day. Please be in peace. Hope that you have learned some practical or theoretical things that come in handy to those of you who want to use GraphQL with server-side language, or to those who are already using it. If you have questions, you can find me at LinkedIn or Facebook. I write articles in dev too as well. Keep your code clean and yourself safe and sound, and be in peace. Stand with the grain. Thank you.
Okay, that was a great presentation. Thank you. We're gonna have a QA soon, and unfortunately, we are almost on the time. So thank you. See you soon, Anastasia.
Thank you.
And let's go to the next speaker, Slavik Niemeyer. Hopefully, I say your name correctly. Who is principal
Almost.
engineer at Microsoft? Almost.
Yeah.
Yes, this morning is hard to me to pronounce all the different names. Sorry.
No worries. It is Slavic namer.
Okay. So right now we're gonna talk about big data analytics and Azure Data Explorer.
Yeah.
That sounds an amazing topic. So let's share your screen right now, and the stage is yours.
Thank you. So first of all, I'd like to start by saying that an unrelated note to this presentation is that I was born in Ukraine, in Kharkov, one of the cities that is heavily bombed now. Lots of the Russians are bombing civilian targets, and that's really sad. And I just wanted to say that I hope the war ends soon, and that just stay informed of what's happening. Okay, so let me just switch to my presentation. Good. So hello, everyone. My name is Slavic Neighbor, and I'm a principal software engineering manager at Microsoft. I work for a product named Kusto, or Azure Data Explorer, which is a big data analytics platform. Today, I want to talk to you about big data. Many people talk about big data. They think they know what big data is, but this is actually not really the case in most of the times. So in today's presentation, I want to really tell you what big data is, show you a few examples on when it's used in real life by real companies, and also show you a live demo, which I hope you will really like. So let's start. So today, I guess you used your cell phone quite a lot to do stuff, and you probably used your computer, right? Not just to connect to this session, but also for other stuff like work. And you probably made some phone calls and read the news, or I don't know what you did, maybe did some online purchases. In any case, all of these, everything that is here in color, everything generated traces or logs or telemetry somewhere in the service. So every single operation that you do, you leave a digital shadow somewhere. These logs are stored somewhere and are analyzed for different things, which I will show you in a minute. And for a single person, it's easily several megabytes in a single day. Now multiply this by hundreds of millions of people, that's quite a lot of data. Plus, there are tons of personal IoT devices like smart TVs, smart watches, and industrial IoT devices like connected factories. They all generate tons of telemetry as well. So you can see that there's a lot of data, and it just keeps growing and growing and growing. And data by itself is really boring. You can't do anything interesting with just looking at the data. What you really want is to be able to get insights from the data. What I mean by insights is to get really good business optimization solution, find problems in services, find affected users, see what you can improve, see where your service doesn't work well, see when the problem started. If you have to recall some component, you will know how to reach these customers. All these logs, this telemetry, also known as telemetry, that is generated, helps businesses get better decisions. And that's actually the key to digital transformation that you probably heard about quite a lot. Let's look at a simple security example. Today, when you log to your computer, maybe you typed the wrong password. This generated a single log saying that there was a failed login. In Windows, it's event ID 4625 on this timestamp and your computer name and your account name. And suppose you typed a few seconds afterwards the wrong password again. And then you type the correct password, which generated a 4624 event, which means a successful login. So that looks good, right? Now imagine a security product that receives login events from hundreds of millions of computers every day, detects this. 100 plus failed login events, followed by successful login for the same computer, same account name, same IP address. Now this doesn't look good. It definitely means that this is a malicious IP address from which somebody tried brute force to guess the password, and he indeed succeeded. That's not good. And what this security product should do is, first of all, alert the user that his computer was hacked, and also it should log the communication from and to the malicious IP address. So I hope this gives you a small idea of what big data can do. As I said, security services receive events from hundreds of millions of machines every single day, and not only login events. It was just one small example. Big data is defined by big V's. Some people say it's 3 V's, some people say it's 4, some people say it's 5. I chose 4. First of all, it's volume. It's literally millions of hundreds of events per second, and I'm not exaggerating. Secondly, it's velocity. You don't just want to receive a lot of information, you also want to be able to process it in almost real time. Variety. If previously, in the past, data was quite simple, it was strings, numbers, booleans, dates, then now it's much more complex. It can be semi-structured data, like JSONs, and it can be GPS coordinates, so that you could locate points in time to the same square or small region. So variety is another pillar of big data. And the last one is value. As I said, data by itself is useless. What you really want to be able to do is get value from the data. Security was just one aspect, one type of product that uses big data, but big data is just everywhere. Let me show you one example of one of our customers that agreed to share the data. The customer's name is Taboola. It's a company that displays personalized recommended content. Imagine you browse to some website and you read an article, and then you see at the bottom of the page, you might also like to read, or you might also be interested at a few links. These links are, if they're generated by Taboola, are personalized for you based on your usage, based on what you like, what they know about you. And the idea is that once you get to these advertisement ads, they will be rendered very fast, because if they are not rendered fast enough, you'll just continue scrolling or close the page. So the whole idea is that they want to display personalized ads for you, and they want to render them really fast. Now, every time that such an ad is generated, it's rendered on the client side, it sends telemetry, it sends a log to Taboola's service, saying how much time it took to render the ad. Taboola gets money from clicks on these ads. So if there is a delay in rendering, the company will lose money. So why do they ask for all this telemetry? Why do they send all this telemetry? Because if there is a problem, first of all, they want to be able to detect it easily and in almost real time. Also, they want to know where the problem is. Is it region specific? Maybe the problem is in Europe, or maybe in a specific country, or even in a specific region in the country because of some service provider, ISP. Or maybe it's browser specific. Maybe the problem is only happening in a specific browser, but not in others. Or maybe the problem is specific to some website, but not to others. The whole point is that they do not know the questions in advance. They really want to have all the data, as much data as possible, and then be able to query it really fast in real time in order to detect problems, triage them, and solve them. As you can see, they ingest 600,000 records per table per second, 37 billion records per table across dozens of tables. As I said, Taboola is one of our customers, and they agreed to share the data. Now, before I show you a few other examples in other areas, let me do a quick demo. I'm going to show you an actual data set from a product. The data set is from 2015. It's quite old, just in order not to expose any security data. I'm going to show you how I query the data, what insights I can get from it, and how fast it works. Let's dive into the demo. For the demo, I'm going to run the queries using Kusto Explorer, which is a client for our product, as I said, named Kusto. And the query language is KQL, Kusto Query Language. First of all, let me show you how much data we have in this demo data set. As you can see, there are 4 tables here, about 30 terabytes of data, most of them in 2 tables here. You can see that the data is compressed. For example, the traces are compressed 10 times, and the metrics are compressed between 15 and 35 times. So that's pretty good compression. Let's see how many records we have and how many days they span. In this table, where we have the traces, we have 41 billion records that span 41 days. That's quite a lot. But let's see how many records we actually have in this table per day. It's supposed to be about 1 billion. And this is exactly what we see. Some days have about 1 billion, some days have slightly less. But that's roughly pretty much the same. Now, every trace that we have, every log, has a column named level. The level actually says if this is an informational trace or a warning trace or an error trace. 1 means critical, 2 means error, etc. Let's look at data from a specific date, just one day, and count how many events we have per level. We're going to process 800 million records and split them into 5 records. As you can see, this only took a couple of seconds, and we can see that in the service there was about 2.5 million error traces. This is not good. Let's deep dive and understand where the errors are coming from. But before that, let me show you what the errors look like. So I'm going to take arbitrary 10 records that have trace level 2 on that same date. As you can see, there's a timestamp and a role. This service, the logs of which I'm showing you, has about 5 or 6 roles. So we have the role here for every log. And we also have some other things here. For example, we have the component name, which is called directory. And we have the actual trace, the actual text. As you can see, the text can be short and the text can be long. Now, let's find out which roles we should focus on, because we have more than 2 million records, error records, but it's really hard to focus on, to know where to focus. So let's look at the role type count of errors per role type in 10win, where every point will represent 10 minutes. We're looking at this chart, and we can see that there is one role out of the 5 that you see on the right-hand side that has by far the biggest amount of errors, about 10, 15, or even 20,000 error traces per 10 minutes. So we should focus on this component, on this SPI role. So I'm going to add a filter on top of the error traces. I'm going to filter on role that has SPI role in it. And I'm going to use the auto-cluster machine learning algorithm, which is going to look for similarity in traces and find clusters. What I hope to find is which component in SPI role has most errors. This will take a few seconds. And this completed quite fast and told us that over 1 million records, which is 55% of the error records in this SPI role, had the following fields. Now, these do not look interesting at all. They're quite similar in other ones. But they see that 55% of the error traces have activity type that equals to SPWL, which is interesting. Let's deep dive into what happens in this activity type. What I'm going to do is look at the trace type. And for every type of trace, I'm going to count how many events we have and take an arbitrary error message. This returned really fast, as you can see here, just a second, 1.5 seconds. And now we know that we have 6 different types of errors in this SPI role where activity type is SPWL, and we can see what errors we should focus on first. So you see, just in a matter of a few minutes, I took a service which generated 2.5 million errors, and I found exactly which errors I should focus on in order to make the biggest improvement in the service. Now let's look at it from a different angle. Let's look which users are the most frustrated ones. By frustrated, I mean when they ran some operations on the service, there were most errors for them. So again, I'm looking at data from that table, from that date, sorry, and I'm looking for a trace that has the user ID, which I parse here using this parse where operator. And I join it again with the traces, only with the error traces, and I count how many errors we have per user ID. And I take the top 10. This will take a while, almost 2 seconds. And we can see that there are several users which got quite a high amount of errors, and the rest got fewer. So we should probably reach out to these customers and say, listen, first of all, we're sorry, we're going to give you some refund, or I don't know what. At least we parsed quite many logs here and counted errors, and that's really, really fast. Now, let's look at the most frustrated user and see the error distribution. So let me put the user token here and see how many different errors, how many different exceptions he had. This specific user had 13 different amount of exceptions. Now you can see that there are 2 which are the prevalent ones. You can see that we see it's mostly them. Let's focus on the first one, on the database does not exist exception. How do we do that? I'll take the client activity ID. It's just an arbitrary client activity ID that produced this exception. And let me look at it. I'm going now to look at data from here, which is many tens of billions of records, and look for this client activity ID and project only some of the columns. As you can see, we have about 1,800 records here, which we got really fast. And now we can see exactly what happened as part of this operation that led to the exception. So if I scroll down a little bit, I see that there is an exception, which said database does not found exception, and I can try and understand what exactly happened here. Now, my guess is that database not found exception is a bad thing. It shouldn't really be thrown. What probably happened is that the user typed a wrong database name. We tried to connect, the service tried to connect to it, and it got this exception because the database does not exist, because there was a typo in the database name. Instead, what the product should do is it should tell the customer, just give me a second, I'm going to check if this database really exists. And if it doesn't, produce an error to the customer saying, listen, you provided the wrong name, please provide another one. So that's just one thing. So as you can see here, we got so much information from all these traces and did it very quickly. That's the whole point of big data. Let me give you another example. Let's look at another table, which is also very big. It contains 36K time series from which is 35 billion records over 47 days. Let me show you some 10 arbitrary records. You can see that we have metrics from different counters here. For example, the processor time and the number of some memory fabric collections. I don't know. And we have the number here, and we know the row, and we know the timestamp. Now let's find the 3 machines with the highest CPU over a day. What I'm doing here is I'm looking at the max CPU by role instance, and I take the top 3, and I render a time chart. Okay. As you can see, we looked at data from a month and a half, and we saw that the problem started here, at this point in time, and then here, and then here. Now we have to investigate look at deployment times. What exactly happened on this date and what happened on this date? But this analyzed tens of thousands of time series and provided answers very fast. And we can look at different jump shapes across all roles. You can see that it gives us interesting points to look at as well. This is pretty interesting. We look at data from a couple of tables, which is huge, and we managed to get insights from it very fast, very easily, very efficiently, and make better business decisions, improve the health of the service, etc. By the way, this demo set it might look big to you, but it's actually pretty small for us. For example, our service collects data from all Kusto clusters in the world, and we get many millions of records per second, about 1 petabyte of data every single day. Now let me go back to the demo. Sorry, to the presentation. Just a second. Okay. Daimler is a large company that manufactures Mercedes trucks in the US. There are hundreds of thousands of Daimler trucks in the US, and they all send tons of telemetry about every gear shift, about every brake, about everything. And they provide an app to fleet managers that tell them when there is when there is some problem with some component, and Daimler is able, using big data, using our product, they're able to analyze all these tons of telemetry to detect problems, notify the fleet managers, and if, for example, there is a problem with the brakes, they can detect all the trucks that are relevant, and they also know the GPS location for each one, so that they can direct the truck to the nearest service center. And all Daimler factories also send tons of telemetry, which helps them improve the processes. Another example is Bosch. Bosch create management systems for smart buildings that include sensors, controls, and the management app. For example, if you have your company has huge buildings, they can equip them with Bosch sensors for temperature, humidity, presence, etc., and air conditioning controls and light controls, etc. And Bosch can detect, because all these sensors send data and all these controls send data to their platform, they can detect problems with air conditioning. For example, somebody switched on the air conditioning, but the temperature does not change over time. They can send a technician without anyone complaining that the air conditioning doesn't work. They just detect it automatically. Now, another problem they can detect is if there are two adjacent rooms, one next to each other, in one they put the heating and in one they put cooling, switch on the cooling. So that doesn't make any sense. They can warn somebody in the room or even switch off some of the air conditions, because it just doesn't make sense to heat one room and to cool another one. And they can detect, for example, meeting rooms where the presence detector sensor says there's nobody there, but the air conditioning is switched on. They can just switch on the air conditioning. Last example that I want to mention is Bühler. It's a company that produces most of the pasta and chocolate in the world. And they also use Kusto for big data analytics to improve processes in their factories. Now, Maybe you got an impression that big data is only for the biggies, but it's not. Big data can also be used for startups that start with small. They can start with small amounts of data and then grow big very fast. And it can also be used for personal use. For example, I know a guy who connected all his smart gadgets in the home to Kusto, and he built a nice dashboard saying how much electricity he uses when and how to save water, etc. So that's really cool. You can stream credit card transactions to Kusto to analyze where you can save money. And other guy whom I know, he likes doing ski. So he has gadgets that report his GPS coordinates and speed and everything. And he looks at his ski trails on the map. So it's pretty cool. And you can get as creative as you want. And if you want to give it a try, you can use Kusto for free for at least a year. We provide a year for free with some limitations, but it's probably good for most customers. Feel free to give it a try. And if you have any questions, you're most welcome to send me a note via email or via LinkedIn, and I'll be happy to assist. I hope that you found this session interesting, that you now really know what big data is, what use cases it solves, and find it fun to play with. Thank you.
Oh, thank you. That was a good presentation. So right now we have 80 minutes to Q&A, and unfortunately you need to have a break. Don't have a break to go to the next presentation. So everybody, if you have any question to do to the last speakers, there's a time. So let me bring the another speak. Let me see if there's somebody else here. So
unfortunately, I need to drop. So if you have any questions, guys, please feel to send me an email to slavicnamer@microsoft.com or contact me via LinkedIn. I'll be happy to help. Bye. Have a good day and stay safe.
okay. Thank you, Slavik. So if you are around, Asif, Shunzi, or Anastasia, please let it. Okay, here you go. You're here. Let me see if there is somebody else. No. You don't have more. So everybody, please raise your questions right now. That's a nice opportunity to do your question about the sessions, about architecture, anyway. So please put your question right now. Indeed, also you don't have, I have one question to you, Asif. Uh, what do you think or what do you believe is the biggest challenge to become an architect in nowadays? So you're mute.
Can you hear me now?
Yes, I do.
Sorry, the headset was closed. Yeah, so what I was saying was becoming an architect has been like dramatically changed compared to like I've been like in the industry for 16, 17 years. And when I started, architect used to be a total different ball game. I think now it has been, I've seen kids from college just pass out, just first job, and they start as a cloud architect. Uh, so like being an architect, it's not only about the technical aspects because that is just one part of the story. I think it's more about understanding. So fundamentally, firstly, you should have clarity in conversation with the customer and how you should be entertaining the customer. So that is the core of being an architect. You should be having that listener's attitude instead of trying to solutionizing everything. So like listening to the customer and trying to firstly analyze the problem statement before you spit out any sort of solution. So that's one of the core aspects I feel being a solution architect you should have. And then on top of it, see, being technical is definitely the core. You have to understand the tech stack, whatever you're trying to be an expert with and trying to architect your solutions. So whether it's cloud or whether it's other models of software development, whatever you follow, so you need to at least know the it's a very generalist role because you need to know as much as possible. It's not like a specialized role, which is like where you be a product manager or a software engineer or senior software engineer. You align to a specific tool or a particular technology or platform. As a solution architect, you are more generalized and you have to have understanding of wide range of services available in the bucket, because then only you will be able to put those Legos together and you can come up with a level 200 or something solution for the customer.
Oh, that's nice. So unfortunately you mute, Asif. Maybe if you leave and return, maybe your microphone might return. I don't
Can
know.
you hear me? No?
Say again?
Can you hear me?
Yes, now I can. So go ahead.
So did you hear anything I said?
I could hear you, Asif.
Oh, maybe it
uh,
was my.
okay.
Anyway,
No, if you want, I can reiterate. That's not a problem.
That might be even more challenging.
Yeah.
okay. Match engineer solution architect role has no clear boundaries. So, how to deal with scenarios demanding broader knowledge?
So, I'm more than happy to answer if you want to go, Shuzhi. Yeah, I
Yes,
don't have
yes,
any
please.
issues.
I don't know. Please go ahead.
Okay, no problem. So, see, firstly, as I said, the being a solution architect is a very generalist role. So, if we talk about level 400 or 600 understanding of everything, I don't think so that's possible being a solution architect. So the thing is that, like, considering the question which has been asked um, by mech engineer, sorry, I don't see your name, but it's more about scenario demanding broader knowledge. So if it is something which you're not aware of, there's no shortcut to that. Obviously you will have to scale up whatever needs. And I have felt like in my experience it's more about collaboration, which makes things much quicker, because you can go and read 200 different blogs and whatnot, but will that give you the relevant outcome? It's most of the time I have seen it doesn't comes up that well just by doing your own research. So collaborating with people and like knowing a good chunk of people in that space will definitely help you in solving the problem much quicker and coming up with more quantifiable outcomes and more rational solutions. So yeah, having a good people and team around you will be the core to be a solution architect. You can't win all the battles and all the queries which you get from the customer by yourself.
Should he? Sorry, I'm terrible with names today. Sorry, I'm so embarrassed to me.
No worries at all. It's Shuzhi, but my pronunciation is not authentic either. So with my kind of strong southern accent. So it's fine. Yeah. So yeah, I would say I'm not a solution architect myself. But I think in when it comes to an architect role, and probably there are lots of similarities here. And I would say 100% with agree with what Asif has been talking about. And also, kind of another thing that probably was noticing is that it's kind of not a 2D view. So when it comes to you to architect or look into a solution for a problem, it's not a 2D view that you kind of think about the different systems, different solutions, and solve things. And it's not even a 3D view. By 3D, I mean you might need to take into consideration of kind of the team cultures, the org chart, and different motivations from different people, that type of things. I think it's even a 4D view. So you also need to take the time into consideration. So you're not designing for the current status. You are designing for like a year from now, 2 years from now. So how would that evolve? And that is another kind of thing that you need to take into consideration as well. Oh, is it just me, or I can't hear you?
No, Otavia, I think you're on mute.
I guess it's a revenge time. So right now nobody's able to hear me. But let's go to the next question. So Asif, what are the factors to consider to define microservice granularities and boundaries? Any best practice formula? When do we need to consider user integration platform versus in-house development? Oh, that's a
Okay,
good one.
that's a fully loaded question. Okay, so I think the first part is factors to consider to define Microsoft granularity and boundaries. I think even before you get into defining your microservice granularity or boundaries, I think it would be like, again, this is all my personal opinion, and there's no right and wrong in this space. So it's more about, you need to firstly ask the question whether you need a microservice or not, because although from all the buzz which has been around the microservice in past 5 to 7 years I've seen, there are a lot of steep curves in respect to the entirety of that implementation, from learning to like orchestration layer to whatever orchestration models you are using to monitoring, and then managing your BAU processes aligned to it. So that all are really hard problem statements which you don't feel when you're doing hello world problem, when you're building a hello world solution. So you need to think about those things. Now let's say even if you get to a point where you think that their microservice is the best possible solution for you, it depends whether you want to go with what sort of model, whether you want to align with a domain driven design model, or you want to build a schema level design model for your microservices. So there are different practices and models which are used, and again, it is very subjective with respect to your business case and requirements. Let's say if you are building a microservices model and you have a very defined scaling requirement for your use case, then you have to align your microservices accordingly, so that you can have that scaling done in a very optimized way instead of pick and choose scaling models. So all that are pretty like intense component which you have to think at. But to answer this part of the question on a very high level, either you go with a domain design model, or you can build a schema design model for your microservices architecture. And again, these are only two of the like models which I am sharing. But if you go and see, I think so people have written 200 different designs, and you can go with any of that. So yeah, it all depends on how you want to proceed with it. You want to add something, Shuzhi?
No, I think you covered
Okay.
all the point. Yeah.
Okay, perfect. Any best practice formula? I think that again, best practice is the practice where you align your solution to the business problem, not to making it more glitter and beautiful. So if you are aligning your problem statement and the solution, if you're aligning your solution to the problem statement and making things more aligned to the business value proposition, and that would be the best possible formula for your best design. When do we need to consider using integration platform versus in-house development? See, I think this is a very good question with respect to most of the developer background. So I come from a developer background, and most of the time you will have a lot of itch when you try to go for an integration or any sort of solution for like taking off the shelf sort of products, and you will feel, I can do something better than this. That all is very itchy, and you always have those like things in your butterflies in the tummy that, yeah, I can do better, and stuff like that. That's all good, but the thing is that you have to think about writing everything from scratch does comes up with a lot of overall overhead, which is not only about the build but test, and then also making it mature enough to be like shared with wider customer base and all that stuff. if you look at like integration platforms which are coming from market leading product providers, whether it's from Dell Boomi or let's say whether it's from Azure or AWS or whatever it is, these products are pretty much very intensely tested, and there is a lot of customer use cases and customer user base who is already using these platforms. So you don't have to bother about the testability and the performance and things. They are already giving you those benchmarkings. So depending on your use case, I would always recommend to go with something like a provider-based solution, whether you are building a software or building an integration platform, either of those cases. And then you should start to solve your business problems using those platforms instead of investing your time building the platform itself. So that would be ideal use case. And I think with the current world, the cost of using these off-the-shelf products or off-the-shelf services from the cloud providers is much more cheap and than the amount of time you would invest in building from scratch. So yeah, my recommendation is use some platform and then build your business solution on top of it.
Yeah, just want to
Okay.
plus one to that. So yeah, so I think probably, and one thing to build on top of that, one thing probably to think about is that you probably don't want to lock on your options from beginning. So you want to defer the meaningful kind of decision making that you have to make to the future. So you only make the most important decision. So if you are just starting up for a new business, then probably the business model and then trying out your new idea is the most critical decision making that you need to make here. So you probably want to focus on that. So relying on some sort of the cloud integrations and relying on what is existing there to provide that, those other things that could help you focus on what is the most important decision making for you to make in the moment. So yeah, super plus one to that as well.
Okay, we are almost time. Let's fire the last question, and then unfortunately need to go. Since architectural rule is very broad, do you think things like product budget and test strategies are in the architecture bucket?
It's a very subjective role, so it's very hard to say this is in and this is out. Depending on your organization, so I can tell you in my previous organization when I was at PricewaterhouseCoopers, that was a total different ball game as a solution architect. Yeah, from budgeting to even resourcing to even hiring, I think I was involved in everything. Now, moving on and like fast forward today, I have a very focused sort of role where I am mostly engaged with customers from service oriented use cases where they, if the customer is using any of those cloud services I'm engaged with, then obviously anything 360 around that service is my problem statement to look at and think about and help the customer with. But yeah, it's no more a delivery cycle for me. So yes, solution architect is a very broad role uh, definition, and again, it will depend on the organization and the particular environment and the team you're working with, who will define like what sort of activities you will be doing. But on a general note, as I said in the very beginning, solution architect is a generalist role. So if you are getting into that role, don't try to compact or maybe lock yourself with a specific mindset that I would be doing this and not that. It's more like drinking from the fire hose. I'll be very truthful. So you have to be basically, you have to have a couple of things. Firstly, good listener. Secondly, you should have that courage of accepting the fact and speaking it out that you don't know. There's always, like, if you are truthful in front of your audience, it's not a problem. And the third thing is then you have to go back and obviously educate yourself on things which you don't know. So these are the three fundamental rules of being successful in the role.
Yeah, plus one to that. And I think for kind of, I like the phrases from the so Gregor's book on the software architect elevator. So architect lives in the first derivative. So you want to move the system from point A to point B, and you take whatever it takes to that. So I think one of the role that involves in an architect's role is that you create the context. You don't do all the designs or the implementations yourself, but you have the setup for the landscape, the context, so that people have the right incentives and also kind of the right environment for their new ideas and solutions to evolve as well in harmony that towards your direction that you desire. So in that sense, I think it's really kind of don't lock on the mindset that you have to do the technical design and only, or you have only do kind of the top level, like join the boxes and the arrows, that type of things. So it's very much kind of all the dimensions, and it very much depending on the context. So in some cases, probably you might need to pitch more. In some companies, you probably need to stay more involved in crafting the incentivification model for engineers, that type of things. So it's very much that you are responsible for transiting the system, a general purpose like system, and from point A to point B, and take whatever it takes to move the system there.
Okay, unfortunately we are over the time, so thank you both to stay here in the Q time section. So let's move to the next host. So are you here?
Yes, hello everyone.
Thank you guys. So I'll give you the stage to you. So see you
Thank
around.
you. Good to have you. Good
Bye.
job. Bye. So, hello everyone. Here we start the second section of the first day of the Worldwide Software Architecture Summit. My name is Bathia. I'm principal software engineer working at Red Hat. I work from London, and I will be your host for the next few hours. And it's kind of amazing we can still connect to each other on the first day of this conference, despite difficult times, and we can learn something about best practices from our work and hobbies. So without overdue, let's start. And our first presenter, his name is Bojan, and sounds like he's AI ML expert that helps companies to transfer their experimental projects to full-scale functional production. And he'll talk about infrastructure as a code. Very, very interesting subject recently. So yeah, let me bring Bojan into the scene and let's go.
Hello, everybody. My name is Bojan, and you can see in background, that's my little assistant. It's a unicorn. He had a very rough night, so he's sleeping. Okay. What I'll be talking today is infrastructure as a code. But a little bit about me first. One sec. I've been doing Python for over a decade now. I have my own company where I do a bunch of development and also management. Not recommended to mix all those stuff up, but it is what it is. I also love unicorns quite a lot, and you can always connect with me on LinkedIn. I'm more than welcome to help people with Python, machine learning, AI, architecture questions. I love mentoring people, so reach out to me. We can grab a virtual coffee and just talk about stuff. Okay, main thing I wanna set it from the beginning is that this talk, I will not be going too much into technical details. I won't be covering how to use Terraform, what cloud provider is the best one, how to handle security in details. My goal is to provide you with an overview of what is infrastructure as a service, how it can help you, and how it can make things better for you. And also some of the downfalls that you need to be aware of. So it's a very chill presentation, focused towards beginners or people who are new to this concept. And let's start. I already covered all of this. So benefits, disadvantages, I'll even recommend some tools that you can use and a bunch of other stuff. Now, in the olden days, when we were doing development on servers and we didn't have cloud and all that craziness, you had data centers. So if you wanted to get a new server, you would have to call up data center, or in best cases, you would have you could use their website to make an order for that. Then you have to wait a few days, and then you have your web server to which you can deploy your code. Now, code deployment was very, very interesting because you also had to have a person doing the management of that server. Lots of time you had your database on the same server, multiple application, because we are paying for this server, we're going to use the maximum of it, and it was very, very messy. I do not envy the admins from those days. But now, with infrastructure as a service, we can do all that in one click. But before I start with infrastructure as a service, I'll tell you a little bit about cloud providers. They have very nice consoles. You can just log into a website, click a button, and you have a website running in a few seconds. And that goes for almost any service. You don't have to worry about anything. And there are pre-baked machine learning images, Docker containers, everything that you can imagine about. You're just one click away, and you can focus on your code. Now, the reason why I'm saying here that infrastructure as a service is hard or it's not easy is because alternative to infrastructure as a service is to do that manually. And I love doing things manually when it takes me 1 or 2 clicks. So what I would usually do in the past is just log in and add a new server. And that worked perfectly fine. Now, if you're like me, when it goes for 2 or more weeks, you're going to completely forget what you did the previous week. So when I set up a Bastion host, I would pretty much forget, okay, in which account it was set up, how do I access it, and stuff like that. Also, with modern application, you're going to have a multi-tier setup in your application. So you have one subnet that is exposed to the public. Behind it is the application code that you cannot access from the public internet. And even below that is the database layer of the code. So there's a bit of complexity. You can click it and set it up quite easily with some setup. Now, what is going to happen is you're probably all sharing the same AWS account. And another developer is going to come along, or in my case, I'll probably do something in the middle of the night, and I'm going to add another machine because I suddenly need access to the database, so I'm going to build the Bastion host. Now, for those of you who don't know, Bastion is basically a way to bypass the security. You create a nice little machine with a Linux on it. You say, only my IP can connect to this machine, and this machine has access to public internet. But since only your IP can connect to it, you can use that machine, and then using that machine, create a connection to database and stuff like that. I love doing that. But they also forget lots of time to shut them down. Now, I already mentioned this. Now, one of the main benefits of infrastructure as a code is infrastructure consistency, because as soon as you start going from MVP, you're going to encounter something that people call production and the staging and development environment. Basically, people don't want to test stuff in front of their users. You can do that, but you're not going to have users for a very long time. So you're going to have to set up the same environment that you have your production for your staging, where your Q&A team can do testing, make sure everything is not broken, and then you deploy the code to your production. And this is very hard if you do it manually, because bugs are crazy. You might suddenly use a different version of Linux, forget to install packages. You might create a different network setup. and all that stuff. So it's not very easy to copy paste the code and make sure they are consistent. With infrastructure as a code, you get one nice little file, define how your production should look like, and you just say apply this to my staging account. It's super nice and super easy way to make sure everything is the same. Now, configuration drift is something that happens all the time. As I mentioned, usually I'm the main party that's responsible for creating drift, because like I have my nice little configuration of infrastructure as a code, and then I'm gonna do, okay, I don't really need to start up Terraform for this. I can just change a couple of things in the cloud, and I'll remember to move that into my Terraform in the morning. I almost never do that. So you end up with a situation where you have nicely defined infrastructure and then a bunch of undocumented changes. Using exclusive infrastructure as a code and versioning that, you can take a look at the configuration and always know what resources you're using and prevent drifting. And I love to call them ghost resources, because nobody knows about them and they pop up on your cloud bill. And as somebody who has seen a bunch of cloud bills, it's very hard to discover, do we need this machine or do we not need this service? It takes a while. So with infrastructure as a service, your team can very easily monitor stuff and see what's actually in use. And we have a risk reduction. This is quite interesting because usually when you're building your application, they are super secure and everything is nicely formatted. And over the time, things will degrade, because if I set up a Bastion host for myself, probably another team member will require it. And if my IP address changes, I'm just going to add another one. And somebody's going to add another machine. So at one point, you're going to have multiple resources that are doing the same stuff, that are going to cost you more money, and they are potential attack vectors. When you have everything in one place, easily seen in a configuration file, it's very hard to do that. Now, everybody knows that cloud is cheap, and almost everybody has heard horror stories for AWS bills. And that happens for multiple reasons. You turn on the service and you forget to shut it down. Also, I don't know if you ever try to see what resources you're using in cloud, but for AWS, it's not as easy as, oh, I'm just going to click all these services, because in AWS, there are about gazillion different services that you might not be aware of using it. Here, when you have one configuration file in your infrastructure service stuff, you can very easily see what resources are in use. And when you get a huge bill, you can identify what's causing you that, and just remove it from the stuff. It's much easier to communicate and see, do we actually need this GPU instance? Now, there is a very good saying from Conway. Any organization that designs a system will produce a design whose structure is a copy of organizational communication structure. That basically means that in larger organizations, you're going to have multiple teams, and communication between them is going to be hard. And each of them is going to set up some resources, and they're not going to communicate that clearly to another team. So they're also going to set up a bunch of resources, and at one point, you're going to end up with team using lots of resources, and when they abandoned research and development on that project, start another one, nobody is going to know which resources belong to which team, With infrastructure as a service, you can very easily tie concrete infrastructure to a project. And then once that project is shut down or it's on the hold for the time being, you can easily just delete all those resources and then recreate them with one click. Now, there are multiple types of infrastructure as a service. One that people love to start with is imperative. That's basically full Thanos mode. You do everything yourself. And you take a look at it. You can create a bash script that's going to call AWS configuration line interface and just execute all the commands. This may sound very nice at first because you don't have to learn Terraform, you don't have to learn all the complicated tools, you're just using a command line and everything is working nicely. However, one thing that's almost always going to happen is things are going to crash. And when they do, you're going to have to add error handling mechanism. What if the database you're trying to provision already exists? What if some resource is currently unavailable? And from the codes I have seen, and looking at those bash scripts, it's very close to the madness. So I love using declarative infrastructure as a service. That's very easily defined, and you can have it say, I want to have one database, and these are the specs for it. I want to have one cluster of containers. I want to have one repository, and here are the security groups that I want. And your tool is going to make sure you have those resources. And if you make an update, it's not going to destroy everything and rebuild it. It's just going to add the stuff you added. Also, when you delete stuff, you don't have to delete whole stack, rebuild it again. You're just deleting one part of the configuration. And debugging this stuff is much easier, and whole code looks much cleaner. What you lose here is that you're working at a high level of abstraction. You don't control every little detail, but for me, that's a very good benefit because I make a bunch of mistakes. And the less you give me a space for making those mistakes, more productive I'm going to be. Now, from tools, you have wide range of stuff you can use. You have Terraform, that is super popular. And good stuff with Terraform is once you learn it, you can use it in multiple clouds, be it your Google Cloud, AWS, Azure, or something else. They have plugins for pretty much everything. There's also Pulumi that allows you to do some advanced stuff and has a nice interface for other programming languages. It's a bit more advanced than Terraform, but also quite user-friendly. Also, you have cloud-specific tools. In AWS, which is where I primarily work, you have CDK and CloudFormation. Now, those are very nice tools to use, but in my experience, rollbacks and stuff like that leave something to be desired. I do prefer using Terraform, even though I'm working on the single cloud infrastructure. Yeah, and that's pretty much the overview of the whole thing for now. Things to be aware of. This is code, and unlike the code that you run, your main consequence is going to be hardware. It's going to start charging you money. And that is super scary when you're starting, mainly because you can do a one-line error and suddenly get and provision a CPU instance. So when working with these tools, especially in your learning stuff, my main recommendation is to set up billing alarms. I love doing that so I don't get billed thousands of dollars. Also, with complex projects, you're going to end up with a multiple configurations file, and those can be pretty scary. But in my opinion, it's far less scary than doing all this manually. Using configuration files also reduces the need for documentation, because you want to use a single source of truth. You don't want to have your documentation describing architecture and then have a completely different architecture in configuration files. I've seen this happen lots of time, and for me, once I look at the documentation, I'm going to assume that's up to date, and I'm not going to look twice. So ideally, your documentation should describe architecture at a high level, but the concrete stuff should be left to your configuration files. That way you avoid a bunch of mistakes. Also, version control. That's something we didn't have earlier. Now, if something goes wrong, you can very easily do a rollback. For example, you're testing a new feature. You want to switch to using SQS instead of Redis or ZeroMQ or something else. You can test it, see if it works. If it doesn't work, you just roll back to previous version. And having ability to do this quite easily in a safe manner is invaluable. I think that pretty much covers everything. I was much faster than I expected. Now, do we have any questions? Or
Thank you, Bojan. I think what we'll do, we'll essentially wait. We kind of gather some questions that people ask on the comments, and we will essentially have the dedicated Q&A section. So thank you for now, and let's bring another speaker. It's okay. We have some flexibility in time. So thank you very much for your talk, Bojan.
Yeah, thank you so much.
Okay, and let's keep it going. So our next speaker is Arnab, and sounds like he's a very experienced person. I'm amazed how many roles he had in the past. He has been a consultant, solution architect, product manager, application developer, and founder. So I'm pretty impressed, and he will talk about data formats. And since software is the world, and software is all about data, really, I'm super excited to learn more in this space. So yeah, let's turn to Arnab for the talk called Data Interchange Formats Past, Present, and Future.
Good morning, good afternoon, and good evening to all, based on from wherever you have joined. My name is Arnab Choudhuri, and I was today going to be speaking on data interchange formats. But when I spoke with my friends about this and told them that I would be speaking, somehow they got the feeling that I would be speaking on electronic data interchange, or EDI. EDI incidentally has been there since 60s and is a form of electronic communication between shipment supply chains and has its own standards in communication as well as messaging. Now, though most of you would know what I'll be speaking on, as you would have seen the excerpt, I'll still change data interchange formats to data exchange formats. Now, this should be a little more clear for people who have not seen this. So next, who am I and why should you even be listening to me? I call myself a divergent technology specialist and have a little over 25 years of experience in software, and so have seen a lot of changes. And because I have taken the time and effort to understand the reason of these changes, I believe I have an understanding of this change progression. And do trust me when I say this knowledge is important, as unless you understand this, you are going to use certain technologies not because you need them, but because it's cool. And that too in a wrong way. This might lead to a massive mess up. Also, I work with companies and projects of different sizes, and so have a good understanding of what is possible in, let's say, X amount of time and Y amount of money. Let me start with the context. To build any non-trivial software, you would need a portable and efficient mechanism for storing as well as exchanging data. Now, this is understood. But please understand, in any data transmission, there are two, rather three aspects to data formats. The first would be if it's human readable. Second would be its size, as smaller in size would send the data package faster. Yeah, it would send the data package faster. Now that's understood. The third would be data serialization and deserialization, which means converting, or rather transforming, your data structures or objects in your app code to the data structure format which travels over the wire. And then this gets reversed with deserialization, mapping back into its original structure. This talk is meant to provide with some ideas as to some formats which exist. Please do test out different formats in different scenarios in your project before you decide which one is right for you. And they would differ by case to case. These are the formats I am going to be speaking on. Some I am just going to touch base and move on, whereas with some I will go a little deeper. Of course, there are a lot more formats which I am not going to be speaking on, such as RSS, Rebol, Gelish, Bencode. The last one is used in BitTorrent. Moreover, there are proprietary formats like Iprosima fast buffers and many more. Now, first database came sometime in 60s. Yeah. That too early 60s. And with it, in a short time, came the necessity to transfer data between databases. And so, data exchange format in the shape of comma-separated values file format was born. The next change comes with the internet and its data exchange layer called application programming interface, or APIs. And here, necessity changed from entire table being moved to just a few rows or even a few columns in a few rows to be moved. Enter extensible markup language, or rather XML, and JavaScript serialized object notation, or JSON. The need for speed brings in new formats such as protobuf, thrift, message pack, and more. The big data ecosystem, or Hadoop, brought more formats such as Avro, Parquet, Feather, etc. Finally, I am going to speak on CBOR, which is going to be huge in future, at least in my opinion, especially for IoT scenarios or constrained environments, as we call them. A CSV file is a delimited text file that uses a comma to separate values, which allows data to be saved in a table structured format. You could use either separators such as tab or pipe, or rather other separators such as tab. Each line of the file is a data record. Parsing is simplified when it's guaranteed that the separator or delimiter is not part of the data. But as every row is supposed to have some structure, it cannot represent hierarchical data. XML is a markup language and file format designed for serialization. I spoke about this earlier, but let me explain once again. What this means is, if you have two disparate systems and you wish to send a data structure or an object state from one system to another, you translate this structure into a format that can be either stored or transmitted. And most important, reconstructed later into an identical clone of the original structure or object. XML was designed for simplicity, generality, and usability across the internet. This was also used for the representation of data structures like SOAP or Simple Object Access Protocol, which is used in web services, basically RPC calls. Almost all programming languages have APIs for processing XML, and there is also XML schema or XSD for interpreting and validating XML. There are also other concepts such as XPath, XQuery, XSLT, namespaces, etc., which makes this whole ecosystem comprehensive. Finally, there is an atom syndication format which uses XML and is used for web feeds and is a competitor to RSS feeds. The primary challenge for XML usage was and is verbosity. XML, lots and lots of it with namespaces. In SOAP, this made communication slow. And even though, in my opinion, SOAP provides best data control, in my opinion, it went out of favor. I would call JSON as a simpler alternative to XML. It's a human readable, less verbose, and is syntactically like the code for creating JavaScript objects. But today, most programming languages has code to generate and parse JSON. JSON today is the primary way for APIs to communicate. There is also JSON schema based on the concepts from XML schema. XML has a concept of metadata using elements and attributes, while JSON does not have this concept. Also, XML has comments, JSON doesn't have it. Finally, there is YAML, another human readable format, even less verbose than JSON. Any JSON document is also a valid YAML document. But it is not so vice versa. Means YAML documents may not, all YAML documents rather, may not be valid JSON. I'll be speaking next on binary formats, but in certain scenarios, it's cheaper to not worry about the tight bit packing protocols and just zlib stream your data. That's why JSON is the primary format today, especially for public APIs. XML and JSON are human readable and expressive, but they are big and so slow. And to do something at scale, speed and size makes a lot of difference. I have already spoken of SOAP for RPC calls and use of XML in them. So there, what used to happen is to send a simple call of mathematic function of, let's say, something like 1 plus 1. Yeah, it would take 1 KB to server and the same amount back. So it was understood that something better was needed, which would move fast as well as understandable by machines faster. Around this time, Google won the search wars and moved to SaaS apps, and they faced the same challenges. So they created their own RPC mechanism and created protobuf, which was a binary format. Then this RPC protocol stack was recreated on HTTP2 and called gRPC, and it still used protobuf, and so protobuf is today used heavily in modern RPC applications and microservices as well. Again, as it's a binary format, the structured data is represented by a stream of bytes. But unlike XML or JSON, it's not possible to tell names and data types of fields for this format without additional files. So protobuf also has an interface description language in gRPC. This describes the structure of data. What I mean is, data structures in gRPC called messages and services are described in a .proto definition file. This acts as a contract between both ends. This gives the developer a way to validate the message. Only values in this case are serialized, which means that you have to declare the data structure before passing any data. This data structure rather does not exist in the binary data that is communicated between applications or servers, however you look at it. So if you lose the schema, you lose data. The .proto file, when compiled, allows invoking by sender or recipient of these data structures. And so that's how the gRPC works. Another plus of having a schema is data projections. This basically means the ability to read individual fields out of each record. Remember, in this case, the data structure is not moving, only the values is moving. Despite that, the ability to get individual data is important. And it's a different ball game than JSON or XML. Before I move on, if you use protobuf or intend to try out and like protobuf, check out Capen Proto to see if the language you develop in is supported. It's supposed to be developed by the same developer who developed protobuf and is really fast. Thrift was developed by Facebook, initially by some ex-Googlers, but is now an Apache project. Very similar at high level to the previous format I spoke of, and supports scalable cross-language services development similar to protobuf. But unlike the previous format where you have two different names, protobuf and gRPC, which means protobuf was designed to be layered over an existing RPC mechanism. Here, Thrift makes RPC a first-class citizen and is both an interface definition language as well as a binary communication protocol. Here, there is a Thrift definition file similar to .proto file in protobuf. Here you have multiple transport layer and protocol layer supported. Protocol layer sits on the transport layer, if you understand that. The protocol can be binary as well as JSON. There is a T-binary protocol which gives you excellent performance but bigger packet size, whereas T-compact protocol will give you good compression but needs more processing power. Now these layers can be changed without recompiling. And in transport layer, one of the support is a tzlib transport, where compression happens using zlib or zlib. There is also a concept of server infrastructure to tie protocols and transports together, like blocking, non-blocking, multi-threaded servers, etc. Thrift, unlike protobuf, supports rich data structures and, more important, handling exceptions. Please note that in case of both protobuf as well as Thrift and even message pack that I am going to speak next, the language in which you are developing might be responsible for good or bad performance, as well as feature sets available, as implementations matter. And so, check benchmarks for whatever language you're using or going to use, and then do the tests yourselves. Message pack is effectively JSON, but with efficient binary encoding. But here, unlike protobuf or Thrift, you don't have to specify the data structure schema beforehand, which in turn means that there is no type checking or schema validation, and any message can be serialized, which, depending on your application, can be either a pro or a con. My experience with message pack is very good, especially when the data message size is big. Though protobuf creates a smaller packet size, the time taken to serialize and deserialize is more, which becomes a lot when data message size is big. This is because message pack uses a concept called zero copy, where data is not needed to be copied between kernel space and user space. Another reason for message pack being great with large data is stream processing, or rather the stream deserializer, where deserialization starts even before the whole data is received. Message pack natively supports encoding binary data. Message pack has type extensions, making it trivial to represent common types in an efficient way. Example, IPv4 address, timestamps. You can use RPC with message pack as well. Zero RPC builds on zero MQ and message pack. Message pack is also used in Redis, Fluentd, SignalR, and many other base technologies. Avro is row-oriented RPC and data serialization framework developed by Apache for its Hadoop project. But this format is used for persisting data as well. It is also used for communication between Hadoop nodes. It is also used by Spark, Kafka, and other big data processing solutions. In protocol buffers and thrift, we have a separate contract for schema, whereas for message pack, there is no schema. Here, though data is again compact binary format, schema is embedded directly in the header of the messages. And this is just JSON. This basically means your application code that receives data does not need to be changed whenever your message schema changes. Or this application code does not need to be provided with a separate schema, and since the schema is JSON, you do not need any special or specific parser. This does not mean that you cannot do code generation. Rather, it's optional. This is because Avro is designed for dynamic languages, or rather scripting systems like Hive and Pig, and this allows you to browse any data set without first locating data schemas and then generate and load code for each data set. Now, Avro also provides support for RPC. Avro protocols described RPC interfaces. These are defined with JSON similar to schemas. Yeah. The exchange of schemas happen in the connection handshake. So it is possible to optimize this such that for most calls, no schemas are transmitted. Parkway was designed primarily as a data persistence format rather than data exchange format. This is a columnar storage file format used in for Apache Hadoop ecosystem, similar to like Avro. This is not the format is not like Avro. This is column oriented. Avro is row oriented, but both were developed for the Hadoop ecosystem. Unlike Avro, this saves values in each column in a contiguous memory locations. If all value in a column is kept together, as all of these values are of the same type, efficient compression techniques can be used, and this saves storage space. Also, if you run a query for a few columns, it does not need to read the entire row. Parkway implements compression techniques such as dictionary encoding, delta encoding for timestamps, bit packing for integers, and run length encoding. The run length encoding is basically means if some value occurs multiple times, a single value is stored once along with the number of occurrences. Here, metadata including schema and structure is embedded within the file. And so, it is a self-describing format. Finally, I come to CBOR. At first, I had thought of doing a session only on CBOR and CBOR's ecosystems, projects. CBOR object signing and encryption, CBOR web token, concise data definition language happens to be the ecosystem projects that I was thinking of. There is also other ecosystem projects like CBOR representation for distributed identification document, which comes from W3C. But then I decided to do this first. Maybe sometime in future, I'll do one only on CBOR. Concise binary object representation is a binary data serialization format. This is loosely based on JSON and inspired by message pack. Actually, when it started, it extended message pack, providing certain additional features. But unlike message pack, this is not developed by just a group of developers, but is an IETF standard. Rather, RFC 8949 to be precise. Not only this, it also has other side projects for this, like date and arrays. And because it's so well-defined and stable, languages are adding this to their framework. For example, .NET Core has a CBOR support built in, similar to JSON. It's recommended that you use this as a data serialization layer for constrained applications, which now constrained application protocol is a protocol which is defined as a specialized web transfer protocol for use with constrained nodes and constrained networks in the Internet of Things. This is for machine-to-machine applications like building automation, smart energy, and so on. Similar to message pack, this is also designed to be able to be created in a streaming way, as well as start parsing before all the data is available. Again, it does not have contracts, so you can add or remove data elements from your data structure as and when you need to. Despite all this, every element is strongly typed. It has additional data types available over the types available in JSON. Also, it's designed to be extendable. It has a concept of tags, which prefix a specific item to specify it further. So you can add let's say something like a tag to a string, and it will be understood as something else. Say date. This allows CBOR encoded byte stream to be converted to human readable JSON on the fly, unlike anyone else. So we have seen quite a few data interchange formats. Please test out different formats in different scenarios in your project and take an informed decision as to what to use. Thank you. If you have any questions, there is a separate question and answer hour. I'll be there to answer it. You can also send me an email or connect with me over Twitter if you wish to. Thank you, and hopefully this was a good investment of your time. And
okay, thanks to Arnab. Great talk. It was amazing to see all those popular formats and compare to each other. Great explanation. By the way, I'm in the team Protobuf. Please state in comment what team you are in. Everyone has his favor, I guess. Please prepare some questions for Arnab. In few talks later, we'll have a Q&A section where we can try to answer some of those. But now it's time for another talk. So let me introduce our next speaker, Melinda. And Melinda is a security consultant working at Oracle, focusing on identity and access management solutions. And I guess it's much easier to use someone else's AIM system like G Suite or AWS IAM. Someone else, dictates protocols, APIs, security concerns, flows. But when you are responsible for this piece, the world is totally different. And there are really key concepts on every product. So let's learn what Melissa prepared about security from her talk called Tick Off Core Concepts on Your Security Checklist. Let me bring her in.
Hello, Bartek. I'm not sure if my window is showing.
It was. Now, oh yeah,
What?
now we have.
Now it is. Okay. Hello, everyone. Thank you for joining this session. I'd like to kick it off actually with a quote and friendly reminder on how there is no gain without the pain, right? So as Mr. Einstein said, you better take your time, take like 55 minutes, think about the problem before you solve it in like 5 minutes. And I'm aware I only have 30 minutes here, and I'll try to walk you through high level on security concepts, hoping to give you some visual starting points for your future designs. Let's jump in, start at the problem. So assuming you're developing, you're extending your application that holds information or retrieves it from integrated sources, you might discover that there's some sensitive data like personal identifiable information, such as a social security number or an address. This is when you really need to make sure you know about the users accessing this data, right? So you start asking questions like, are you able to identify the user? Are you able to scope the access that the user is entitled to? Are you aware who has granted the access to the user in the first place? Do you know whom you need to contact in case you need to revoke that access? And are you able to monitor when the user accessed what? So these questions represent the 4 A's in identity management. They are authentication, authorization, administration, and audit. And they sort of set the framework on how a user can securely access this data. Now, you need to start by giving this user an identity. At the core, you'd have this unique identifier that never changes, right? And then you attach the access that the user needs for his work environment, password being one of those attributes I'd recommend for you to regularly change. And then there's, of course, a set of attributes. Some of them may be applicable to changes. And finally, you'd have job-related roles, access rights, application-specific data that is transient. So another definition of identity management could be that it needs to deal with all the processes in managing your digital identities. Let's talk about the importance of these processes now by going through practical experience. Like you have an organization, usually your target systems where a user needs to log in, like your email, human capital management, enterprise resource planning, down to operating systems, and even maybe some hardware devices the user needs to access. Now, on the user layer, you could distinguish between externals like partners, customers, and internals. And on the process layer, usually you'd have different admins involved, HR, help desk, procurement, etc. Now, to be able to track the processes, you'd need to really go from perspective of each of these users to check how they're gaining either indirectly or directly access to your systems. And even the admins might have different requirements to get their duties done and accessing the system. Not to forget, you might even have forgotten that you have former employees still being able to access your system. So looking at this picture, it's really hard to answer questions like who has access versus who should have access, and what are the assets these users are using, what are the risks, and what does it all cost me? And this is the time when you introduce your identity management system, which is basically a tool, and you'd redirect all your eligible users there to manage your requests. And you can even introduce like management approval or even the distribution of hardware devices through procurement. That identity management system would then centralize your account management, ideally on each of those systems, and give you a centralized view of your users' access. That would, of course, also reduce the risk of any former employees still having access and help automizing operations in a more efficient way. Beyond that, the purpose of an identity management system is to help discover accounts. So for that, it needs to be able to list the accounts there are on each of your systems. For example, your Windows server, cloud accounts, and somewhere you might have an HR system where your users are onboarded with all their attributes. And that would probably serve as a source for your initial identity. Based on those user attributes, you'd usually go and define your rule set, and that will help you discover the accounts on all the remaining systems. So you've listed the accounts. Now you could link them to the identity, possibly also create accounts where necessary. But what about all the accounts that you can't connect to any user? There's a term, it's called like orphaned accounts, and it's really highly recommended to act upon those to not have the risk of data theft or data abuse via these. So an action could be to either temporarily disable those users, or if you're sure that there is no ownership there, you could permanently also delete them. So identity management actually has to cover the whole life cycle of a user, right? From joiner, mover to leaver, capturing all the status that a user has, all the changes between those status, including enabling, disabling the access. And there are multiple identity management systems by established vendors, Oracle just being one of them. I've even seen customers build their own, but as you can see, it can become quite a task. So having established identity, I'd like to move on now to standards for authentication and authorization. So back in 1960, computer scientist Fernando Corbato first introduced the idea of a password, using that to securely access files on a computer system. Fast forward 2002, passwords are still very much around, but Oasis has published a token-based standard called SAML. Now that will allow a user to log in to an application via a session in another context. Famous use case, single sign-on. And in 2012, the IETF brought out a matured version of OAuth that would allow a website or an application to access resources hosted on another web application on behalf of another user. On top of that, in 2014, OIDF published a mature generation of OpenID Connect, which would help identify the user, the end user. But let us go into the detailed flows of each of these now. Starting with SAML, Security Assertion Markup Language, you have three key roles. So you have your user trying to access a protected resource hosted on a service provider, and you have your identity provider maintaining your user identities. Now, these two share a trust relationship, each of them having a user store in the back, either directory or database. And the user would now initiate the flow either by trying to log into the application, then being redirected to the identity provider, or he could directly send his authentication request towards identity provider. In the identity provider, the so-called SAML assertion, the security token, gets generated. Now that is XML based and it contains so-called claims, meaning user attributes, and is shared back to the service provider. User gets a response and can then initiate a session with the service provider. Service provider, of course, would evaluate the token and, when verified, would establish a security context via, for example, session cookies. Let's compare to OAuth. In OAuth, you have 4 roles. So you have a client again trying to access resource on a resource server, but this time you have a resource owner who's capable of granting the access, and he's delegating the authorization to an authorization server. So when the client now requests, there is a concept in OAuth called authorization grant, which is basically representing the resource owner's authorization he has on the resource server. And that is necessary because the client needs that to trigger the authorization server in issuing an access token, also called as bearer, that would be in JSON Web format. And with that access token being sent back to the resource server and evaluated successfully, the client gains access to the resource. Again, there are flavors in this flow. There's a so-called two-legged, which is actually specified as client credentials flow. And in that scenario, the client would become the resource owner. But more common is the three-legged authorization code flow. And let's look into the detailed flow here. Again, you have your user, you have your application A with a link to application B. And that application B consists of an authorization page, an authorization server, and a resource server. So when the request gets in, it is picked up by the authorization endpoint, and the user gets redirected first off to the authorization page, where he's asked to enter his credentials and a consent to access. So mind you, these credentials are not shared with application A, only inside application B. Redirected to authorization endpoint, the so-called authorization code is issued first. That is sent back to token endpoint, who then generates the access token finally. With that access token, you can request resource server, and the resource server will, of course, also verify the access token before returning the resource to the user. Now, in this flow, there's a risk that the authorization code gets intercepted. And how could that happen? So you'd have a malicious app, and the first request that happens is browser-based. You're requesting for authorization. That malicious app could gain access to your HTTP request response logs, or could pose as a custom URI schema matching the response of this authorization request. Could steal, therefore, the authorization code and trigger the generation of access token, gaining access without anybody knowing. Solution there is another specification called PKC, or Proof Key of Code Exchange. And that introduces additional elements. So when you generate your authorization request, at the same time, a code verifier is generated, and also a code challenge. You decide on a code challenge method that is applied on the code verifier to calculate the code challenge. So first off, the application A sends the request, but only together with code challenge and code challenge method. That gets saved by authorization endpoint in the database. And then again, authorization code is issued. This time, application A would send back that authorization code together only with code verifier. The token endpoint has a task now to verify, to apply the challenge method on the code verifier, comparing it to code challenge. When that is successful, and only then, the access token is issued and the flow continues. Okay, last one is OpenID Connect, which is on top of OAuth, right? And here you'd have your user sending requests again against application, also termed as relying party, relying on the so-called OpenID Connect provider in this case, who offers, for example, social login via Google or LinkedIn, and would then challenge the user to enter his authentication request. The user again would enter the same credentials and give his consent so that OIDC provider can issue the so-called ID token, again JSON web-based, that's shared with the application for further processing. So here's a quick overview over the three again, comparing features and purposes. And so SAML basically takes care of your authentication, authorization, OAuth only of authorization. OpenID is on top doing authentication. And you really need to check what you want to achieve there. When you want to initiate a user login session, obviously only SAML can do, or OpenID. The user consent is out of the box with OAuth and OpenID. High security identity tokens only retrieved by SAML and OpenID. And then there are features such as OpenID provides, like you can usually only get claims managed locally, but OpenID offers to have distributed and aggregated claims as well from external providers. It can also do dynamic client registration, meaning that you can have an OAuth client register via API to an OAuth server. Okay. Now for stronger authentication, multi-factor could be an option if you want to distinguish from which location, at what time a user logged in. Meaning then for multi-factor authentication, you're combining something that you know, such as a password, with something that you have. For example, retrieving a one-time PIN from your device or providing your fingerprint, something as you are. And you could even combine that with something called adaptive authentication, where you would rate your application, for example, in terms of data sensitivity or in terms of trust level in combination with that. For example, if your application is high risk, it's definitely a candidate for multi-factor authentication, versus when it's low risk, it's probably sufficient to simply ask for password. So it doesn't stop there. The FIDO Alliance, for example, is promoting authentication standards to reduce the use of passwords and is supporting a range of technologies from biometrics to user-registered devices where it's sufficient to just press a button. So my next topic would be, how can you achieve authorization by modeling your access into roles? And there's a standard RBAC model which defines that the technical representation of an access privilege is a combination of an object in relationship to operations. So, for example, your network drive and read and write. So that gets bundled into a permission. And the permission actually describes part of your work task, whereas the role should describe a complete work task which can be assigned to a user. So the goal is to achieve that only roles, mainly roles, are assigned to user versus directly some system privileges. And to model business roles, it's a good practice to distinguish between an organizational and a technical level there. So you'd have system roles which would represent your technical capabilities, business roles with business function, each of those having policies for the purpose of aggregating roles and to scope the complexity. And why does that make sense? Best to look again into a use case there. So assuming you'd have system roles with one-on-one assignments to your access privileges in your systems. For example, the developer would be contributor on content management, be relayed as domain user in your identity store, and have write access in your network drive. You'd have to do that for each of your business roles, right? You'd have to pick the exact representation, which can become quite complex. Whereas you could compare that now to an aggregated view, where you combine from different systems your rights, and you can see that the assignments are much more easier to handle. This brings us to one of the quality criteria of role modeling, and that is the art of abstracting building blocks. A building block being consistent and easy to combine with others. You don't want at any level a one-on-one assignment. That is not a concept. You should aim for a structure that is more balanced always. An important aspect of the policy is also the segregation of duties, meaning that you want to separate duties that are not compatible. For example, approving the access and assigning the same access. So you're forcing more than one person to complete that process. And to help here, you have this construction again of the system role being at smallest level of access control. The business role, of course, grouping all the duties, but the policy describing exactly one duty, and that is the level where you can define like preventive or detective rules to exclude rights and subsequently also define your violations. So for example, you would define here that this role cannot include a right to approve and a right to assign in the same system. Now, on discovering roles, there are, of course, different approaches. There are role mining approaches, a top-down, where you could break down the organizational level into departments and then into teams, from the teams taking into job titles, and then assign the job titles the system accesses that it needs. Vice versa, bottom-up, you would first start assigning the entitlements to the systems, and then finding your roles. In the end, of course, you need to assign the users to that roles again. So best approach is sort of hybrid and even combined with a lot of processes there. I'd like to give you a recommended step-to-step approach. So first, collect your data from all the systems that have relevant access information. Take time to clean up. You don't want any non-personalized accounts there. Remember the orphaned accounts. And then go for the approach of both top-down and bottom-up, trying to match and find your role candidates. Those role candidates should ideally first be certified, verified by an appropriate business owner, for example, a manager, or even on a technical level by a system owner, before they're taken live. And taken live means that they could maybe be even self-serviced by a user. You would then introduce, of course, the logging when the role was assigned, when the role was approved, to achieve that audit trail and achieve that role-driven security, which brings me to regulations and standards. So all the discussed security concepts actually are required, such as identities, access, processes. Companies that have a responsibility for financial transactions need to secure segregation of duties. And penalty for non-compliance can not only cost reputation, it can lead to imprisonment of executives. right? So I'm just picking here like 3 regulatory compliance and standards, SOX being US federal for financials, ISO, information security standards with more than 100 controls to manage your security risks. GDPR, of course, based on passed by European Parliament, and especially enforcing data protection. For all of these, there are sustainable solutions with identity and access management. And once established, you can always build upon those concepts you're auditing and reporting to check who has access to what and who authorized it. So another categorization for securities and risk is confidentiality, bringing along the risk of data theft, integrity, bringing data abuse possibly, and availability, holding up against data corruption and destruction. Again, all the security concepts are addressing these 3 categories. For example, you could answer all the questions here like, do you have non-personalized accounts? By linking the users, right? And how is the access to sensitive data protected? Strong authentication, for example. For integrity, are you applying segregation of duties? Are you applying least privilege principle? Have your role model set up? And for availability, how long does your onboarding, your offboarding take? There's a need of lifecycle management processes. And for example, does your user get access as per his role description, per his job description, of course, if you would have the roles in place, right? This is where I like to wrap up with this business objective quadrant. So for any organization that is envisioning zero trust security, you can arrange those security concepts again, because you need them as building blocks, right? From operational, you would start with identity and access discovery, along with all the lifecycle management processes. Secure for your applications, authentication, authorization. On a strategic level, role model as per your organization business needs, along with the controls it takes to be compliant, and even for future planning as in predictability. Okay, that's it. I hope to have given you a big picture on security concepts. Feel free to reach out. I'll try to answer any questions in the chat or in the QA session later.
Thank you, Melinda. Amazing talk. Thank you so much. I especially love the explanation of the popular authentication and authorization protocols, which were kind of tricky, and especially those delegation diagrams where you delegate the permission to do something. Because we used to in our past job like talk about, hey, write this code that does this OAuth dance. And like no one actually knew what this dance means. We knew it's like very complex. But it looks like a dance from those diagrams, but it has its purpose. So we have lots of questions, but let's reserve them in an hour. So looking forward to discuss those with you. Thank you.
Okay, thank you. Bye.
Okay, and let's move out to our next speaker. Our next speaker is Nilesh, joining us from Sri Lanka. The weather must be amazing there now. I just checked. It's 30 Celsius degree whole week. I'm kind of jealous. And Nilesh is an experienced architect and community lead. And his talk title is Architecting Multi-Tenant Platform on Kubernetes. Multi-tenancy is a big thing, definitely. We all want to reuse the same software and hardware for multiple different users that might belong to different teams. It promises reduced cost, of course, and some uniform traffic, but there are many challenges. So I'm looking forward to your talk, Nilesh. So let me bring you in. Hello.
Hey, thank you. So yes, weather is good in Sri Lanka, but we have some power issues. So if I suddenly go dark, that means the power is out in Sri Lanka. So getting to the topic of architecting a multi-tenant platform on Kubernetes. So as introduced, I'm Nilesh, who's an architect at a company called WSO2. We are building an iPaaS called Choreo, which allows users to write integration solutions on top of Choreo and then run them on Kubernetes clusters using our cloud native language Ballerina. So in this talk, what I'm going to talk is how and what we did to improve security of our system. What are the best practices that we followed? I'm going to take this as a case study and sort of like a scenario based situation. And we are not I'm not going to I'm not going to expose everything that we do, but I'm going to give you the best practices and everything, the recommendations that we have. So as a case study in this scenario, what we are looking at is, you know, in a platform, multiple tenants can deploy their applications in a shared Kubernetes cluster. They have ability to create deployments, jobs, cron jobs, of course, daemon sets, stateful sets, of course, you can do that. But currently we are focusing on these three only. And users should be able to write their own code, build the image, and deploy them to this shared cluster. They have the ability to change the Kubernetes YAMLs on the applications as and when needed. So sometimes you must be thinking that this is not your use case, but if you imagine in your enterprise, every enterprise or organization has some level of multi-tenancy. You might be running outsourced software applications on your Kubernetes stack. You might be running third-party tooling on your Kubernetes stack. So all of these sort of account into multi-tenancy. So just follow along and we can see how things work out. So if you look at the area of attack in a Kubernetes cluster, there are 4 C's, we call it. The first level is the cloud level, where the infrastructure level, where you can attack it at the data center level, the network using network servers, etc. You can easily fix this by adding proper SSH configurations, adding bastion host, setting up your VNets properly, setting up all of those things. And the next level is the cluster area, where once you have access to your infrastructure, then you can attack your clusters. And once you have gained access to your clusters, you can sort of like go in and attack your containers. And then you, of course, at the code level also, within like a Trojan horse, like inside the cluster, you can attack your containers and wreak havoc on the system. So let's take the first scenario. Attacker has access to your infrastructure. How would you stop this? So if an attacker has access to infrastructure, now the next thing the attacker would try to do is try to access your Kubernetes cluster. So the first and foremost, what you need to do is you have to set proper RBAC policies in your cluster, like create accounts, create certificate signings and role bindings. And I've seen in many enterprises, what they do is if they have custom Kubernetes clusters that are not running in cloud but private Kubernetes clusters on their data centers, most of them sort of like share their own keys, share a set of keys, key value pairs, and then they configs, and then they share it among the employees. That shouldn't be there. So each and every employee should be able to connect to the cluster with their own credentials. And in managed clouds, in managed Kubernetes, this is not the case. So all the major providers, cloud providers, have proper RBAC policies set for the Kubernetes clusters, and you don't have to worry about it if you are using a managed cloud. Enabling audit logging. So this is also another thing. Again, in clouds, I think some clouds you have to enable audit logging in Kubernetes, and some have this enabled by default. So if you have not enabled, you gotta enable that, because that gives you an insight on who has access to your cluster and what they have done in it. The next one is running a CIS benchmark to harden your cluster and do the recommended fixes. So if you look at most of the managed Kubernetes clusters in the cloud, they have the CIS benchmark report on their Kubernetes control plane and what they have done. So if you are running your own Kubernetes cluster, a tool called KubeBench, I find it extremely useful. So running that actually helps you identify what are the gaps you have in your security issues that you have in your cluster that you might need to fix. Another thing is that using a CIS hardened node image. So we all know that even in managed clouds, you have the option to specify uh, a node image. So originally in Google, it has a container hardened image. Azure and AWS also has those, but in Azure Marketplace, there's a special one called the CIS hardened node image, which has additional security policies added to the node image itself, and you can use that to further protect your Kubernetes cluster. Encrypting etcd, again, this is not relevant to the managed Kubernetes clusters on your cloud, but rather for the custom private Kubernetes clusters that you maintain on your data center. So if someone has access to your infrastructure, the first thing they would go and try to do is look at the etcd, try to read from etcd. So if you have encrypted etcd, this will not be the case. When you're using your running applications on Kubernetes, mounting secrets as files and not as environment variables will not expose your sensitive information like database credentials and whatnot to an attacker who has access to your nodes or infrastructure in Kubernetes. Another thing is like always setting CPU and memory limits. This is actually a runtime thing, which I'll get back to in a later slide. The next thing you gotta do is you gotta isolate your tenants on the network. The first thing you would do is you would use namespaces. So for each tenant, you would create a namespace on your Kubernetes cluster, and then you would use something called network policies. So in network policies, this is actually the Kubernetes equivalent for firewalls. So the best practice is basically do a deny all network policy for ingress and egress, only allowing access to the Kubernetes DNS server, which is co-DNS, and then selectively allow ingress and ingress rules when needed for your tenants, if they want to speak to each other, or if they want to speak between namespaces, or if they want to even go outside of your cluster and talk. So selectively allowing these is the best practice, but sometimes on egresses this doesn't make sense, because like when you're running a multi-tenant platform, sometimes it's hard. So maybe you can use a wildcard on egress and selectively deny certain things that you think that should not be accessed via the cluster. So it's completely up to you. And the last thing is, I'm talking about network policies, but you got to make sure that your Kubernetes cluster has the Kubernetes cluster CNI has the network policy support. Because if you're spinning up Kubernetes clusters on your own with something like Flannel or whatnot, they do not support network policies, and you gotta make sure that you use a CNI plugin that supports network policies. Of course, this is not an issue for managed cloud Kubernetes. Another thing that we personally do is we make the inter-service communications also go through an API gateway. By doing so, it allows us to make sure that we can add rate limiting and all of these things, and make the API gateway sort of like the hub to manage our API request and do all of the things we need from one place. So that's something that I would recommend to have, rather than make services communicate to each other, make them go through the API gateway. And another thing is encrypting your network. So if someone has access to your cluster or your network, can easily listen in and look what the payloads are running and all of those things. So if you use MTLS, this will not be the case. You can enable MTLS at a code level. You have to do some coding for that. Or if the applications are already running, you can easily enable MTLS with the support of Service Mesh or something like Calico, which has eBPF enabled. So these are your options to isolate your tenants on the network. The next scenario is the attacker has access to your code base. So what would you do then? The first thing is the only thing you gotta do is you have to secure your pipeline. So when you secure your pipeline, the first thing is you have to enable static scanning. So in your pipeline, you should always have static scanning, and it has sort of like three sections. The first one is code vulnerability scanning. So you are scanning for dependencies like Log4j, etc., which has vulnerabilities, and you get a report and you stop the pipeline then and then. You do not allow it to proceed. Also, it allows you to scan your code and make sure that you have not hard coded any sensitive information into the code. Then comes image vulnerability scanning. So after you scan your code, then you build your code and then you bundle it up into an image. The next thing you do is using tools like Clear, Trivi, or any image vulnerability scanning tool. It would allow you to scan your image and all the dependencies that your Docker image might have, and then look at the vulnerabilities there and look at the criticalities. Some images, of course, uh, you cannot really avoid certain vulnerabilities. There are warning levels for vulnerabilities, critical and major. So it's up to you to figure out which level of vulnerabilities you would allow in your cluster. But if you have a zero vulnerability policy, then you might have to consider building your own images from scratch using Alpine, and that always works out for the best. And finally, configuration scanning. So configurations, as in the YAMLs, you have the Terraform files, the Kubernetes YAMLs, and all of these things. So you got to scan these and check them against a set of policies that would say, all right, so your pods should always have a limit, and a CPU limit and a memory limit. So stuff like that, you can set policies up in this scenario, and this will allow you to enforce security standards in your YAML. Of course, these tools like Chekhov, kubesec, etc. would scan your files and give you recommendations on what are your missing pieces are with your configurations. The next level is attacker has access to your container. So once your attacker has access to your container, there are a few things we can do. The first thing is we got to harden our containers. So first we got to make sure that our containers are immutable, which means at the Docker building stage itself, we can remove the bash, we can make the file system read-only, we can make the entry point user a non-root user. You can do all of these things. But if you are running a third-party image from a vendor or somebody else, which you do not have control of the Docker file, you can still enforce these within Kubernetes. So Kubernetes has this thing called startup probe. Using that startup probe, you can run any command, shell command. If the image has a shell, bash binary. So when you do that, you can easily remove bash and whatever the things you want to remove on your image at runtime before it starts. Also, Kubernetes has this thing called security contexts. So using security contexts, you can easily set run as group, run as user, run as non-root, and all of these things you can set on your before your container runs at a Kubernetes level. And you can also enforce these rules with in Kubernetes. We have this thing called pod security policies, and if this pod security policies, what we do is we give a set of rules, and if these rules are not matched, we do not allow that pod to get deployed or container to run. But this is actually getting deprecated in Kubernetes 1.22, and there are alternatives like open policy agent and gatekeeper, which allows us to do the same thing but with more control. The next one is container runtime security. So here, when you look at how containers are running, you see you have the physical hardware and then you have the Linux kernel. So we all know that how containers are running using C groups and namespaces. So So these containers, when you run processes in these containers, it always sends these calls to the kernel, and that's how it works out. So the containers can easily exploit a vulnerability on the kernel and then gain access to other containers or attack containers. So there are a few ways for us to stop this. The first and the foremost, is disabling escalation, privileged containers and privilege escalation in Kubernetes uh, containers. So we can do this via the Kubernetes YAML. It's very easy to set up, just a true false binary that you had to set up in the Kubernetes YAML spec. The next one is you got to drop all the capabilities and add only the capabilities that are needed. So if you are using service mesh, you got to add the netraw capability. But other than that, if you're not using anything kernel based that requires special access, you can just drop all the capabilities you want. Another thing you can do is you can use either AppArmor or seccomp policies or profiles to restrict processes running in containers. So you can, like using AppArmor, you can run Nginx and you can get the list of syscalls that it does. And then you can enforce that so that if the container tries to do some other syscall that a normal Nginx wouldn't do, it would pick up and it would deny it or alert you if something is going wrong. So that's what AppArmor and seccomps allows us to do. Then there's container sandboxing. So the popular one is Google gvisor. So what container sandboxing allows us to do is it adds something called a space kernel between the container and the Linux kernel, and you have to go through the space kernel to send syscalls out to the Linux kernel. But there are like lot of the calls are there, but still it's improving, and there are a lot of missing syscalls as well. But if you're just running normal containers and if you're not doing anything really kernel based or anything, it wouldn't be much of an issue. Finally, there's tools like sysdig Falco or the entire Sysdig Enterprise Edition, which allows you to monitor each and every syscall and look for abnormalities, and then uh, see what things are going on and what issues you have, and then you get alerts and you can configure all of these things at a single place. So that's container runtime security. Then the next one is concealing information. So as I said earlier, you shouldn't use environment variables to inject sensitive information to your containers. So you should use something like a secret manager, like for example HashiCorp Vault, Azure KV, AWS Secret Manager, Google Secret Manager, etc. So using these, you can directly inject secrets into your container runtime uh, without just directly that's like the best security version you have. Other one is like you can mount these as mount secrets as files, but don't ever inject environment variables into your container, because any intruder can easily list the environment variables then and there on your system, and they can find things out. But if you have mounted it as a file on your Kubernetes cluster, if someone has access to your infrastructure, they cannot view it. But if they access to your container, still they need to find out where the file is in order to view it. But if it's just an environment variable, it's very easy to read that environment variable. And another thing is make your container root file system read only. So with this, what allows you to do is like an intruder who has access to your container cannot easily access they cannot very easily access your application work, or write stuff into your container, or like download additional packages from apt-get or something and then run additional binaries and exploit your container. Cannot do that. And also they cannot download files and utilize all the storage you have on your node. They cannot do that. So there are a lot of good things that you can do with enabling root file system read only. And on top of that, what you can do is, like for example, let's say that you need to write certain things in your container. Your code requires you to do it. You can easily use empty dirs or volume mounts to do that, and it would just override the root file system read-only flag to the specified path in your container that you specify. Then finally, this is just a developer discipline. I've seen many developers do this. Do not log sensitive information. Like sometimes you don't purposely do it, but you do it anyway. Like for example, if there's an error with an API call, you just log the error object itself, and the error object contains all the tokens and everything that you have sent, and that's just bad. So you shouldn't do that. So you should really have some developer discipline there and look at that from an overall perspective. So finally, what the few words would like to say is, like, taking my own experience also into play, is, Kubernetes security is still new, and vulnerabilities get patched frequently, and there are a lot of vulnerabilities that gets found out every day, and you should always keep your Kubernetes cluster up to date. And also, when you are running your Kubernetes cluster, especially as a multi tenant platform, you gotta keep the CPU limits and memory limits in check, because anyone can, like for example, there was a in a previous company that I worked, where we were doing a similar thing. We had this situation where we allow users to run cron jobs, and a single pod of a cron job, I think we had a memory limit of 500 megabytes and a CPU limit of 300 milli-CPU, I think. So users were able to run cron jobs with their own code. So what we didn't think was the timeouts for cron jobs. Like, one user went ahead and created a while loop, which never ends, and then added a plus one, like n equals 1 plus 1, n plus 1. So just added one simple struct like that, and then what happened was, he made that cron job to run every minute. So now our cluster is getting bombarded with new pods that never exit, and every minute there's a new pod that's running and just bombing the CPU and memory of the entire cluster. So stuff like that you got to keep in mind, and you got to set up proper policies and see how people can attack your cluster, how things are working, and all of those things, and you should be able to do well. And as I said earlier, many organizations do need some level of multi-tenancy with their applications in Kubernetes. Let this be your personal applications. Your teams are running multiple containers and all of those things, or you're running external outsourced ones, open source ones, and stuff like that. So it's very easy for you to somebody to exploit your cluster and screw things up for you, and it's going to be very bad. And one last thing is that you got to set up observability. So you got to know when your system is failing. You got to know when someone is some anomaly is happening in your cluster. So you got to know all of those things before going into production with a system like this. So finally, like, if with proper standards and best practices followed, you can actually keep up, and if you keep up to date with your latest releases and patches, I think your cluster, you should be all right. Thanks, and I want you to try out Choreo, the next gen cloud native engineering platform for API developers that WSO2, myself, and few others we are building. It's currently in beta. So this allows you to this is a low code solution and an iPaaS solution, which allows you to run your integrations, run your APIs, run your logic on a shared Kubernetes cluster. Try it out and expose it to your API consumers. It's very easy to use, and I hope you'd like it. And I hope this talk was informational for you. Thank you.
Thank you, Nilesh. Great talk. Thank you for that. I like how you started to talk about multi-tenancy with kind of talking about malicious tenant and those scenarios, security scenarios, which is kind of a brutal truth. Don't trust your tenants, right? And I hope you can stay with me for like 8 minutes, 10 minutes until the next speaker will come up, and maybe we can chat about some of the questions. And I would love to get the first kind of controversial question in, which is like, let me put it here. So essentially, did I miss change about the topic? And this is exactly what I said. Like when someone talk about multi-tenancy, the first thing that comes to their mind is probably not security. It's about maybe functionality, reusing resources, and like cool stuff. But it was like a good, reminder that, hey, you should probably think about security. So what do you think about that? Is it really your first thing that comes to our mind when it comes to multi-tenancy, security, or what was your
Yes. So correct. So when I actually talked about multi-tenancy, the security was the first and foremost thing that I was looking at, because you're running multiple tenants on a Kubernetes cluster, and that's the most critical point where people can exploit your cluster and then screw things up for you. So even that's where I was planning to do my talk on and share my knowledge on. So how Kubernetes security would help you prevent uh, the issues that would come up with multi-tenancy and allow you to architect your multi-tenant system with a security first approach, so that your application and your clusters will be secure and you wouldn't run into any issues. So this was, as you said, this is really was a security based webinar that I did just now, which supports the multi-tenancy situation, multi-tenancy scenario, because you need security for multi-tenancy, and with this only you can achieve multi-tenancy.
Yeah, great point. Great point. It's good to remind everyone. Wow, there was like lots of conversation during your talk, and one of the main conversations were about environment variables, and if you use secrets, should you use environment variables or actually put it in the file, and why something is more secure than the other. And you explain a lot, but maybe we can reiterate on some of those. So we have, what would you propose here?
Yeah, so environment variables, I think the best thing, mounting sensitive information, injecting sensitive information into your containers. The first and foremost thing you need to do is you need to use something like HashiCorp Vault. There are the other solutions as well, which would directly inject the secrets into your sensitive information into your containers at runtime. But other than that, using environment variables, the problem with environment variables is you can YouTube this at any given point. If you have access to your nodes, which the containers are running, if you have access to the VM, it's very easy for you to go into the proc folder and then list down the environment variables that you have injected. So that means people don't even need to access the Kubernetes cluster. You may have your database information and etc. as a secret and mounted into your pod as as an environment variable. Anyone who has access to your node VM can look at it if you haven't set proper things up in the VM. So that's the major thing why you gotta mount these as files into your container. So if you mount secrets as files into your container, then an attacker who has access to your VM will not be able to read these things from the VM itself. They have to access Kubernetes API to actually read these secrets, or read the etcd and then get the secrets out. So that's what I have to say about that.
Makes sense. Thank you. Okay, we have time for more questions, if you don't mind.
Yeah, sure.
There is cool one around internet or like connection service policy, right? So why not using service mesh for that?
The approach is definitely for northwest traffic use an API gateway, and east-west traffic use a service mesh. You can definitely use that, but sometimes service meshes are sometimes a bit expensive, which means like if you're using Istio, for example, seems to have a lot of CPU and memory utilized for Istio compared to meshes like Linkerd, which is more resource efficient. It's completely up to you. Yes, so you can use a service mesh and use service mesh to handle all your routing rate limits and all of those things within the service mesh itself. And there are new technologies coming out, like with eBPF. You can, like, service mesh is having the sidecar pattern, whereas eBPF etc. you have node agents, which makes the resource footprint more smaller. So yeah, I think it's not a problem. You can go ahead and use a service mesh as well. Yeah.
Yeah, great answer. And I guess the other problem is you need to make sure the service mesh is secure in itself as well.
Yeah.
So that's like another complexity in the system. Yeah, great talk. And I like everyone was super surprised at multi-tenancy and why he's talking about security and whatever. But like that's really what matters a lot. So thank you for reminding this. And yeah, we are ready for the next speaker. So thank you, Nilesh, and see you in half an hour. Thank you.
Thanks.
And let's go to our last speaker for this section. And we have Neal, who is director and software architect. Apparently, on his business card, his official title is Meme Wrangler. Yeah, that's what you heard, Meme Wrangler. I love it. I hope this promises, accurate memes in his talk, which is titled Software Architecture, the Hard Parts. And yeah, there are lots of hard parts. So looking forward to your talk, Neal. And let me get you to the stream.
All right. Thank you, Bartek. Can you hear me okay?
Yes, all good.
All right. You are exactly correct. That's mostly what I'm going to be talking about today are the hard parts of software architecture. In fact, my co-author, Mark Richards, is also speaking at this event, and he is going to do more of a deep dive on a few specific subject areas, but I'm going to do a much broader overview of software architecture and what makes software architecture so difficult and so challenging. Mark and I wrote this book, Fundamentals of Software Architecture, and it was published back in February of 2020. And as we were writing this book, we kept bumping into these problems in software architecture, and we would start diving into that problem and realize that this is just too complicated for a fundamentals book. And so we set all those problems aside until we finished this book. And we finished this book and published it and then said, okay, well, what are we going to do with this giant pile of difficult problems that we have? And what we did was apply the two laws that we coined about software architecture in our book and realize, first of all, that it's really about trade-offs. You'll notice the subtitle of our new book is Modern Trade-Off Analyses for Distributed Architectures. And this is a realization that there really is no good generic advice in software architecture, because if you Google something for a software architecture problem, should I use orchestrational choreography for my accounting workflow? Google can't answer that question. And in fact, there's no generic advice possible in software architecture because there are no generic software architectures. Think about the software architecture where you are. It's this combination of good things and bad things and things we like and things we don't like and things we're stuck with and things that are brand new and shiny. But nobody else in the world has exactly that combination in architecture. So the really important thing is to learn how to do trade-off analysis in architecture. And we asked this question at the beginning of our book, what happens when there are no best practices? So when you Google for a problem in software architecture, my co-author, Mark, has a great phrase that software architecture is the stuff you can't Google. Because when you try to Google for something in software architecture, first of all, what are the chances that someone else has got the exact same architecture you have and has the same problem that you had and has figured out a solution to that problem and then has written a blog entry about that solution for you? I mean, the Venn diagram circles are getting really small here. And so the real trick is to learn how to do your own trade-off analysis. because nobody else has the exact architecture you have. So nobody can give you advice about your architecture, but you can learn how to do trade-offs. So this is our example. Should I use orchestration or choreography for my accounting workflow? And Google is going to come back and say, well, always it depends, because that's the answer to everything in software architecture. And this is exactly what we realized, is this is really about trade-offs more than anything else. And one of the things we wanted to do in our book is make these things less abstract and more concrete. And so one of the ways that we made things more concrete in our book was a mythical company called the SysOps Squad. Every chapter starts and ends with the SysOps Squad, and they have a very specific problem in architecture, so that we can talk about a specific architecture and its solution. Because I'll tell you now, as kind of a teaser, we don't really give you any answers in our Software Architecture, the Hard Parts book, but we teach you how to ask better questions about your own architecture and all these architectures. And we do that by looking at all these really difficult things in software architecture and show you how to do trade-off analysis for these things. And the first thing we realized that was common to all of our problems in software architecture is coupling in software architecture, particularly distributed architectures like microservices. And we started doing a deep dive into coupling in architecture. And in fact, this is the quote that starts our chapter from a famous Swedish philosopher that, because you hear this advice all the time in architecture, oh, you should try to make things as decoupled as possible. But coupling is not bad. All things are poison, and nothing is without poison. The dosage is what makes it so a thing is not a poison. So finding the right amount of coupling is really the key here. And one of the tools that we use to think about this is this idea of an architecture quantum. We developed this as originally in the Building Evolutionary Architectures book, which we wrote back in 2017, as a way of thinking about our general architecture styles are some more evolvable than others. And that really came down to coupling, how things are coupled together, because that helps determine in many ways its evolvability. But we did a much deeper dive on this subject in the Hard Parts book and realized, and really re-realized, because this was something that had been talked about way back in the early 90s in some other works, that there are really two kinds of coupling that we need to think about. Static coupling, which is the way things are wired together, all the dependencies between things, and then dynamic coupling, which is how do things call one another within an architecture. And this was a great insight for us, because we ended up splitting our book into two parts. The first part really focused on static coupling, and the second part really focused on dynamic coupling. And we did that very early on, and we didn't really think too much about that split until when we were doing the final copy edit of the book. Out of 450 pages, the split between part 1 and part 2 was about page 220 something. So it was almost exactly in the middle. So that shows that we have about equal information about both of these aspects of coupling. And so let's talk about, and these are the two parts: pulling things apart, which is a static coupling, putting things back together, which is dynamic coupling. And a lot of this has to do with understanding the relationship between the building blocks in your architecture. So in our chapter 4, we talk about a number of these decomposition patterns. And in fact, go through a flow chart to talk about, can you identify modularity in your architecture? We provide you a few tools or a few metrics, like distance from the main sequence, that allows you to see how well structured your code base is at a macro level. If your code base is decomposable, which in other words, can you identify clean components in it, then you can do component-based decomposition. And in fact, we have a number of patterns in our book that show you how to do a component-based decomposition, these decomposition patterns. But you may also find that you really have a big ball of mud, but you still need to do an architecture restructuring. That's where tactical forking comes in. If you don't have good component boundaries, it is still possible. This is our component-based decomposition. I got my slide out of order there. This is the number of patterns that we talk about in component-based decomposition, and each of these has a number of practices. So there is a a process that you can go through to take a monolith and piecewise break it down into smaller components. Those are the patterns I was talking about. This is tactical forking, which I was talking about, which is where you don't have a discernible internal structure. What you really have is a big ball of mud. But what tactical forking says is, instead of trying to extract something cleanly from a code base, if you have too much stuff, what tactical forking says is what you do is just clone the code base and just delete all the stuff you don't want. So it's a way of being able to tackle this restructuring problem really aggressively, getting to work right away, even if you don't have good component boundaries. One of Mark and my insights when we were doing the fundamentals book, and even more so, we started thinking about the difficult parts of software architecture, is how important data has become in architecture. Mark and I both spent a lot of time 15 and 20 years ago working in distributed architectures that are just like the event-driven architectures that we deal with now. But when we got to microservices, we realized that a lot of the decisions were much more difficult and nuanced in microservices. And it's because in those distributed architectures in the past, we mostly still talked to a single big relational database and dealt with data as an isolated thing. But part of the philosophy of microservices is this idea of a bounded context, that every service has data fidelity. But what that does is make data issues like transactionality and consistency architecture problems. And so we did a deep dive on the relationship of architecture and data, which is why we added the two co-authors, Pramod Sadalgay, who is the author of the Refactoring Databases book and well-known expert in operational data and relational and all kinds of databases, and Zhamakda Haghani, who's an expert on analytical data and this modern approach called a data mesh, which I'll talk about briefly at the very end today. But chapter 6 in our book is about how do you pull apart operational data, because if you're doing an architectural decomposition, you also have to be able to decompose the data as well. And often that's more complex than just pulling apart your code. You certainly have better tools for it with refactoring tools, but even dependencies and things can become troublesome. So what we do in both of our granularity chapters, both for data and services, we talk about these tools you can use. And so some of these tools you can think about, when should I consider breaking apart my data? Part of this is that quantum measure. Do you need, because one of the side effects of this quantum thing is it's a scope for architecture characteristics. And so do you need one scope or do you need multiples? For example, you may need different levels of performance or scalability in one part of your application to the other, which may drive you to separate your data because of those concerns. But change control is another one of these drivers that will force you to break apart your data, because if you have a single relational data, then one change can ripple out across a lot of your ecosystem. Number of database connections can also become a problem, a technical problem in distributed architectures that operate at high scale. Scalability can also be a problem if you have too many requests coming in a given time. And things like fault tolerance. If you only have one database and it goes down, then you have problems. Whereas if you have a distributed architecture, you have some options around that. These are all what we call disintegrators, things that encourage you to break things apart into smaller pieces. But we also, when we talk about services, have integrators. And this is actually one of the most difficult problems people deal with in modern distributed architectures, is what granularity should my services be? And we identified two different forces, disintegrators and integrators. Disintegrators are forces and tools that help encourage you to break your services down to smaller pieces. Service functionality is the obvious one here. The problem, though, is if you only use service functionality, you can often get to things that are too small, and then you end up with workflow and transactional issues and a bunch of other problems that I'll address as we talk about communication. This is a common problem in a lot of distributed architectures, is they end up getting too small. with their service granularity. But code volatility may be another one of these drivers. If some of your code changes a lot and some of it changes very slowly, that's a really good way to model things, because the things that change really slowly are better reuse candidates than the things that change quite often. All these operational concerns like scalability, throughput, elasticity, reliability may be something that encourage you to break things apart into smaller pieces. Fault tolerance is another special case for both in terms of data integrity, but also reliability and availability. And then finally, security is always a concern. If you have one part of the system that needs a higher level of security than another, then that may encourage you to break things apart into smaller pieces. But there are also integrators, which are forces that encourage architects to bundle things back together into bigger pieces. And database transactions is a great example of one of those. A common problem if you take your first shot at a microservice architecture is you end up with services that are way too small, and then you start trying to do distributed transactions across them, and you realize that's a really bad idea, because you want to try to avoid that as much as possible, because it's really, really hard to get correct. And so this is a common force that would say, well, why are you artificially breaking things apart and then creating a new problem for yourself? Create a single service and encapsulate the transaction within that service. Data dependencies is another one of these. It's easy to pull apart code, but if that code also has data dependencies across tables and even things like referential integrity, it's really hard to pull those things apart. And then finally, workflow and choreography. If you end up with too fine-grained services, you end up with a lot of interaction, which drives up your latency and kills your performance. And so too much workflow and choreography may encourage you to bundle things back together. What we're giving you here as an architect are tools that allow you to iterate on your design. That's really important in modern architectures, because no one is so good at architecture that they can just look at a problem and the complete solution just falls out of their head. What you need to do is start with a candidate case in lines and boxes, and then to start applying these disintegrators, but then integrators as well, and iterate on the design while it's still in the lines and boxes phase, and figure out what the best candidate solutions for these problems are for one case versus another. We also did a deep dive into reuse patterns. And this is a really common problem that we see in a lot of organizations. So let's say you're a big insurance organization and you realize at some point that, hey, every one of these divisions has this concept of a customer inside it. So what I should do is abstract all those customers into a single customer service, and then allow all of these other services just connect to my single canonical customer service. This, it turns out, is a really, really bad anti-pattern for two reasons. The first of which is everything you know about customers in this one place, which means this is going to be a very complex service because everything you need to know is there, which means that every time you change that, every one of these things that touches it also has to change. And that's because there are two aspects of reuse that we identified. And everybody gets the first one right and misses the second one. The first one is abstraction, and this is a case of good abstraction. But the second one is low volatility. Because if I create this pattern, but then I constantly change customer, every division in my company has to slow down and coordinate on that change. And so if you really want decoupling and good reuse, you need both abstraction and low volatility. Otherwise, it drives up the brittleness of your architecture, because every time that changes, everything has to stop and coordinate around that change. Of course, once you start talking about data, you also have to start talking about data ownership and distributed transactions. And this is starting to get into the communication part of this coupling. And one of the primal forces that we identified here is atomic versus eventual consistency. So in a distributed architecture like microservices, you cannot have true ACID transactions because you can't have the I part, which is isolation. But you can create the model of an atomic transaction, which means that everything within the workflow completes or none of it completes. So it's never in an inconsistent state. But then you have a wide variety of eventual consistency, which says that these will eventually come together. And we'll see how these play out when we talk about communication patterns in a second. The last item in the first part is about distributed data access, which is who can see what. And there are a bunch of different options here. None of them are always true. And this, of course, gets to the heart of what we're talking about in this book. No one can give you generic advice because there are some situations where all of these may be not maybe the best solution, but the least worst solution to your problem. Inter-service communication, data schema replication, caching, or bundling them all together into shared domains. We talk about each of those patterns in turn. And of course, each of these has their sweet spot. If you have large data volumes and low responsiveness, then inter-service communication works better. Or if you have multiple owners that need to write things in high responsiveness and data domains. And so this is what we're talking about, is this kind of trade-off analysis between these different approaches and what the sweet spots are. So putting them back together really talks about communication between services in a microservices architecture. And one of our insights in this book is that when you think about communication, you can't think about any of these things in isolation. And this is part of what was making those problems so hard, because you look at these problems in communication distributed architectures and you change it from synchronous to asynchronous. You're not just changing one thing, because as soon as you do that, that changes your trade-offs between atomic and eventual and whether you're using orchestration or choreography. And so what we realized is this is really a three-dimensional conjoined space, and you have to treat this as 3 dimensions rather than 3 single dimensions. And that's exactly what we did. We did a deep dive into managing distributed workflows and talked about orchestration versus choreography, what the trade-offs are on either side of this difficult decision. That culminates into transactional sagas, where all 3 of these forces that we talk about individually, synchronous versus asynchronous, choreographed versus orchestrated, and eventual versus atomic, go into this idea of transactional sagas. And these are the 3 forces. And if you know something about statistics, then if you treat these as binaries on either side, we have 2 things taken 3 ways. That gives us 8 possible combinations. And that's exactly what we did, was modeled every possible combination of these 3 primal forces. And when we started doing that, we thought, well, some of these will be obvious boundary cases and you could just throw them away as being ridiculous. But none of them were. Some of them are anti-patterns. One of them has to be the worst, right? And it's the horror story saga that makes it the worst of these patterns. But every single one of these is legitimate, either as an anti-pattern that teams fall into, or a different way of managing trade-offs between within a distributed architecture. And this is a really interesting exercise for us, because it showed us the benefit of identifying these things that are tangled up together. And they're tangled because every time I change one of them, the others might also have to change. That is, by the way, our definition of coupling in our book, is that entanglement. And by modeling that entanglement rather than the individual forces, it gave us some insight as to when would one of these be better than the other. So, for example, the horror story. That's called a horror story because the box on the outside is the atomic scope of the workflow. So we're trying to get a choreographed workflow that's using asynchronous communication to have atomic behavior across the workflow, which means that if an error occurs, all of these services have to coordinate with each other because there's no orchestrator. So it's really, really complicated to try to solve. But yet, within a couple of weeks of codifying these things, the project that I was working on, the architects brought me their plan, and it turned out it was the horror story saga. So these things do exist in the real world. One of the things that most architects underappreciate are contracts and the way things join together. So one of our goals in this book is try to treat things as simply as we could. Because, for example, coupling, you could easily write an entire book, and people have, just on the definition of coupling. But we tried the simplest definition we could. Two things are coupled if changing one might cause the other to change. The same is true for contracts. Contracts are how any two pieces of software join together. So that could be a method call, but it could also be a protocol and distributed architecture. And it turns out that whether you use strict versus loose contracts has a big impact on a lot of other things in architecture. Really strict contracts give you good contract fidelity, and you always have certainty about what's being passed. But it also requires versioning, and you may have to have a deprecation strategy, and it may make your architecture more brittle, because now every time you change something, everybody has to stop and coordinate around that change. Really loose contracts allow you to build really highly decoupled architectures, but then you may miss having schema validation, but you can add things like fitness functions to replace that. And so there are a bunch of different trade-offs. The main point of this contracts chapter is it shouldn't be something you always just default to a particular style, but it's something that should be thought about, and the trade-off should be analyzed within architecture as you make those decisions. Chapter 14, most of our book deals with operational data, pulling apart operational data and relationships, etc. But we also wanted to address analytical data, and particularly this idea of data mesh that my colleague Zhamak Dehogani has been working on, and in fact about to release an entire book about herself. The reason we wanted to talk about data mesh is not get into data mesh itself, which is big enough for an entire book, but rather to talk about the architectural designs in data mesh using our terminology. And so if you have a service in a microservice architecture, for example, you may also want it to be able to publish analytical data, but you also need to have domain knowledge about what data needs to be sent, PII, personalized identifiable information. You want to make sure you filter that appropriately, and only domain experts can do that. And so data mesh defines this concept of what we call a cooperative quantum. So for a service alpha, you will have the alpha data product quantum, which is a separate bit of code that runs in its own scope with its own set of architecture characteristics, but has a really tight contract with this alpha service, and it cooperates with other data aggregators and other parts of your analytical ecosystem. This is an example of how you would put together the data mesh concept, where I have several services here, alpha and beta, and each of them have a data product quantum that's attached to it. Notice there's a tight contract between each one of the services and that data product quantum. It is a separate quantum because it has its own scope. It may have its own data storage, depending on what kind of analytical data you're trying to pull and access out of that alpha service. And you don't want queries against that service database for analytics purpose to impact things like performance and scalability. And so that's why there's a tight contract and maybe its own data store, that data product quantum. It collaborates via loose contracts with an analytics quantum. And this is a separate static coupling set of services that act as the analytics product within your organization. And so each of these services publish information to their data product quanta, and then those publish information to the analytics. This is a great example of how to achieve decoupling at the architectural level, but also create this cross-cutting coupling, which is analytical data. And using contracts both tight and loose contracts. They have to be tight between the data product quantum and the service, because there's a tight fidelity between data there. But you want much looser contracts the further away your collaborators are, so that you have less brittleness within your architecture and you can make implementation changes without breaking things. And so it's a way of cross-cutting analytical data across the operational data within your ecosystem without having negative impacts on things like operational data. So the data mesh is a fascinating subject unto itself. What we wanted to do in this book is use the language that we had defined around service granularity, contracts, etc., to illustrate what we're talking about in the data mesh world. And so this is an example from the SysOps squad. As I mentioned before, each chapter has a concrete example from our made-up company SysOps squad. And so this is like a maintenance crew for electronics, for example. And we may have ticket maintenance and ticket assignment, each of which are their own independent services, but I may need to have a ticket management analytics. I need to know how many tickets are completed versus assigned. I need to know geographical information about them so I can see how well my scheduling algorithm is going. These are all parts of business intelligence that should not be part of the individual domains, but are part of analytics. This is how you would set up that kind of analytical data in a microservices architecture, where each of these services have a data product quantum that publishes the kind of information that needs to be consumed by this ticket, a data product quantum, to gather up analytical data for our architecture. So here is, if I want experts demand forecasting or expert skill set trend analysis, notice that's a great example of the kind of analytics data, because I have experts, I have tickets, and I have surveys. I need to be able to match in the future my skill sets toward what kind of products that people are buying. Well, that's business intelligence. That cuts across the individual services, but you can build an ecosystem like this that leaves you the high decoupled nature of microservices, but still allows you to do business intelligence. That's the idea of a data mesh. So the very last chapter of our book, the first 14 chapters, in fact, in our book, are basically taking these difficult problems in software architecture and showing you how we are doing trade-off analysis. We're showing our tools like integrators and disintegrators. We're showing you some metrics, etc. But at the end of the day, all of our work doesn't help you so much as being able to build your own trade-off analysis. So the last chapter of our book, we turn around and show you all of the tools that we use to do trade-off analysis throughout the entire book. And I'll show you an example of one of those. Here's a great example of a kind of difficult problem you face. I can't decide whether to use a shared service or a shared library for all the common functionality in the system. So should I use a shared service and have all three of these other services call it, or should I make it a dependency on each of those services? And so what you do is you do a trade-off analysis, and you look at all the different factors. Heterogeneous code doesn't work well in a custom shared library, but does in a shared service. And you go through and build an entire trade-off matrix like this. And this is great. This is the first stab you would take at something like this, and then say, hey, well, if I count up the check marks, then a custom shared library is definitely the better one. But this is why we call this the out of context trap, because you cannot assume that all the things on the left have equal weighting. Because what if I'm in an ecosystem where we are leverage polyglot programming and have services written in 4 different languages? Oh, well, then a lot of these things are not even options anymore. And we have to go with a shared service versus a custom shared library. So this is the out of context trap. Don't get caught up in the comprehensiveness of your analysis. Be careful to weight things that invalidate other things and drive you more strongly toward one solution versus some other solution. So the point of this is, of course, is that there are no silver bullets in software architecture, and you should stop trying to find them. Your best job as a software architect is not to try to go find silver bullets, but instead Learn how to do good trade-off analysis within your unique ecosystem, because the better you can hone that skill and the better you can get at it, the more value you add to your organization. And so generic advice you can't push very far. Be careful to always take that generic advice and start customizing it as quickly as you can towards your own unique set of problems, because you're the only ones who have those that unique set of problems. So that is a very quick overview of a long book, Software Architecture, the Hard Parts. That should, though, give you a flavor of some of these difficult issues in software architecture. Like I say, we don't have any answers. All we have are better ways to ask questions. As I said, my colleague Mark will also be doing a talk, and he goes and takes 2 or 3 of these issues and does a really deep dive and shows you many more of the solutions rather than the overviews. So that's the end of my talk, and I'm happy to do questions. Or do we do that here, or is that another link?
No, let's do it here. But
All
yeah,
right.
just wanted to thank you first for your talk. Amazing. It's good to see some material that finally looks, looks on software architecture from high level view, try to aggregate those in the patterns and name them and compare them. So lots of opening eyes idea, to be honest. I love this granularity of separator and then integrator, because usually we talk about microservices as one-way road. We never even reiterate and say, oh, maybe I will pull this microservice back to the monolith. So it's amazing to even consider all of this. So lots of amazing knowledge.
And a piece I didn't even get into it are this idea of data domains. One of the biggest problems people have in microservices, I can't get all the data stuff to work out. Well, if you just bundle a few of them together and make a data domain, then that solves many of those problems. So to your point, it's one of those things you may not think of, but it's like, oh, well, yeah, that solves a lot of problems, and we should just do that.
All right, so let's start discussion. I will close your screen, and I will invite other speakers that spoke in this section. We are waiting for more speakers if they will join us. Let's see. But so far we have Nilesh, Arnab, Bojan is joining us, and Melinda. Oh, amazing! We have everyone. How are you feeling? How is everyone? Good? Stressed? No?
Doing well. I hope everyone can hear me. I did the recording. Yes. Yeah, good. Thank you.
You sound amazing.
Okay, so we have full half an hour to discuss things. So feel free to ask each other questions, and we'll look on the comments, and I will try to find try to do round robin of questions to each of the presenters. So let's start with Bojan, and I think you discussed the infrastructure as a code. So I think the first question is what IAC stands for, infrastructure of the code, but there's also IaaS. Can you kind of clarify the difference between IAC and IaaS? Two kind of questions together.
Oh, yes. Infrastructure as a code basically means you write your infrastructure in a configuration file, usually YAML, and you apply that and you get it all done. The second one is basically you say, I'm going to handle all the software, but infrastructure is going to be handled by a provider. Usually it's cloud. So they provide you with EC2 instances and all that stuff, and you don't have to worry about provisioning, managing all that stuff, networking, setting up all that. You just worry about your program. So that's one is the configurational stuff of setting up, and the other one is basically separation of responsibilities. Amazon is responsible for your stuff, and they're in charge if something gets broken, not you, and that's always good. You want Amazon to be in charge of more stuff than you.
Yeah, makes sense. Makes sense. Thank you. Okay, let's switch to Arnab now. Hopefully, we'll be not jumping to topics, to different topics too much, but let's try to do this round robin. So you discuss about plenty of amazing data formats in a very detail. But from your perspective, what do you prefer in those various cases?
I spoke about this a bit. It depends on use case to use case. So in certain cases, I would be, if I'm using gRPC, it would be protobuffer. If I'm using REST, it would be JSON. It would, if I'm using, let's say something like sending data from Debezium chain sets to Kafka, it would be Avro. If I'm, let's say something like uh, uh, data means from how do you call it, Snowflow to something S3, then maybe something else. Depends on case to case. These all the intention to do this talk was there are so many options, and all these options are necessary based on where to use them. Also, it depends on what language are you using, because there would be certain features in certain technologies not available in a certain language. So that is also something you have to take care of. So I use everything depending on the circumstances.
Makes sense. Makes sense. Okay, let's move now to some security questions and identity management. So, Melinda, do you mind recommending us some tools that maybe your favorite tools or some good advices there?
Okay, I was saying apart from Oracle, of course, SailPoint, ForgeRock, and One Identity maybe. Those are the competitors that I meet most of the times, at least.
And would you recommend using each of those, or would you say that it's okay to start your own tooling in your organization, or would you recommend to just always never start your own from scratch and always use something else, even if it's like expensive?
Well, the times, the times that I've seen a customer actually build their own is when they run into problems very easily. Following up with the standards, following up and updating, patching their infrastructure. So yeah, you need to kind of decide what's your trade-off. You want your in-house development that you can somehow maintain versus something that is established and might be, more looking towards the future. And I can definitely only say that it's up to the customer to check with his use cases what makes sense.
Right. And following on the kind of security subject. So
yeah,
I saw you are comparing different protocols, and looks like OIDC is very shiny and newest protocol. And while we talk about different trade-offs and context, I wonder, it sounds like OIDC is a winner. So do we need those other protocols, or should we deprecate those?
That wasn't really my intention when I was bringing up that slide. It was just actually to bring out the comparison about the purposes that you need to think about before. And I see SAML very much still part of the game, and wouldn't really say any of those are deprecated.
Yeah, great. Thank you. Okay, let's move to Nilesh, multi-tenancy. There was a question around internal traffic growth, go through gateway or like separation of the traffic. And I guess the question is like, how much of the kind of overhead you are willing to pay for security really? And is there any problem with that?
Yeah, the overhead you got to pay for security. I think can take a leaf out of Neal's what Neal did on the trade-off analysis, and then you can figure out which you want more and figure out what you need. But on adding the API gateway, yes, it adds one additional hop, maybe a couple of hops if the API gateways are separated in a different node than your original service is. But again, it's just a couple of hops that would contribute towards your improved security of your application. And if you're going to go with service meshes which add sidecars, it's going to be a same hop, and it's going to be it's still going to use more resources for your applications when you're running that security. So I think, yeah, that answers the question.
Yes, thank you. Okay, and time for Neal. And yeah, sorry for being egoistic, but I'm so curious how you managed to write 2 books. Like, I'm writing book right now with Rayleigh and about Golang and performance and efficiency, and like it takes so much effort. And you wrote 2. How do you accomplish that?
Well, that was actually number 8 and number 9. So I'm working on number 10 right now. So, but it's actually one of those things that well, one thing, I have a really great co-author, Mark Richards, and having somebody that's really active collaborator is means the world, because we spur each other on, and he's a great collaborator as well, so that helps a lot. But it's one of those things. Regularity really matters. A long time ago, I tried to figure out, how do you write books? And the 2 things I found in my life that benefit the most from regularity are coding and writing. And so I tried to just do a little bit every day of writing. And, if you can do a little bit every day, then, before long, you have a book's worth of stuff, and you can start. But I'm a software architect by trade, so I try to meta analyze everything. So I've been meta analyzing the book writing process, and so Mark and I actually have a process where, and the hard parts is a great exemplar of that, where we took this tiny seed of an idea, but we've realized that when you talk about it at conference talks, you learn more about it as you talk about it, and that allows you to grow a little bit more, which gives you more to talk about, and before long you have enough to write it down. So we very much did that in the fundamentals book, and we also did that for the hard parts book, because it allows you to refine the material and find out what things are actually people are interested in, the actual problems people are having, what resonates with them. So it's no revelation. It's the exact same lesson we get from software, is that a quick feedback loop is the best way to adjust your course when you're going somewhere you've never been before. Writing a book is somewhere you've never been before, so having a fast feedback loop to help you course adjust as you go is it's the whole ball game, just like it is with the software that you haven't built before.
Great, thank you. So let's take one more question from the audience as well about your presentation. So how do you see software architecture emerging in the context of emerging this from cloud provider services?
So I'm happy to start this, because I get this question a lot, is because we don't specifically talk about serverless as an architectural style in our fundamentals book, because if you look at, so we distinguish between architecture styles versus patterns. A style is a named topology like microservices or microkernel, whereas a pattern is something like CQRS that you can apply in a lot of different architecture styles. And if you look at almost all of the architecture styles that we talk about, those can be deployed on cloud and serverless infrastructure. So it's not a unique architecture, it's a unique deployment topology that, like every deployment topology, comes with its own set of benefits and constraints and trade-offs. And so we don't look at it as this brand new thing. It's really just a next adjustment of something that we've dealt with before. And so there are certainly a lot of trade-offs that you have to take into account, and certainly those things are maturing at a breakneck pace, because this idea of I think that Amazon and Google, their greatest dream is to charge you a microtransaction every time you call a method. I mean, that's got to be their ultimate goal, right? And so they're going to keep making these ecosystems better and better and more enticing, but it's not. We don't see it as a fundamental shift. It's more of an evolutionary shift, and just the way we're changing the way we deploy things.
Yeah, but definitely we see that they are shaping the world a little bit, right?
But the internet shaped the world when it came out, because we went from client server to internet, but a lot of the same patterns still survive. But and new patterns will emerge. This is always what happens when you have this dynamic ecosystem like software architecture, because we keep inventing new building materials. When it's almost like building, but they keep inventing new stuff, like transparent aluminum. I mean, what would builders do with something like that if they invented that next week? Or things can float now. Okay, architects, you can float things now. What are you going to build with that? So, our ecosystem changes so fast, and our capabilities arrive at such a breakneck speed that it keeps us in this constant state of adjusting.
Yeah. Thank you. All right, let's do another round. Start from first speaker again. So, Bojan, question to you. We discussed like infrastructure as a code, like a good solid pattern, but there are essentially multi-cloud, multi-clusters, multi-vendor kind of discussions, like how this helps in this effort. Does it help infrastructure as a code? Does that help in this effort?
It does help, but you need to have a very good reason when choosing to go multi-cloud. Usually what I see people choosing, we're going to go multi-cloud, it's because we don't want to get vendor locked in. And that's never a good reason, because you do want to get vendor locked in. You want to make full usage of the services that provider is using instead of using generic stuff. I mean, you can always run everything in Kubernetes on every platform, but it's going to be much more expensive. You're not utilizing that cloud provider as you should. The good way for solving stuff is, for example, AWS. This is just an example, very artificial, but no same person is going to use AWS for documentation, Chime, and their email. You're going to use Google for that. It's not a cloud service, but you should take a look at the service and see what is the best fit for that, and then do some calculation. Is the transfer of data going to be the best solution for that? Also, if you are developing new product and your team is skilled in Google Cloud, you're not going to use AWS because engineering time is super expensive. And you should not be afraid of, we're going to rely on AWS, so we should use Azure and Google Cloud at the same time. No, you want to rely on your cloud provider. They're there for you. But if you're going multi-cloud, you need to have very good justification of the price increase, because it's going to cost you more. So yeah,
well said.
Not
Thank you.
Multi-cloud unless there is a good case for that.
Yeah, good point. Be pragmatic. Okay, Arnab. It's kind of question from me, I guess. So we mentioned like lots of those protocols were zero copy. What that means in practice, like, is it useful? It's just another allocation, which quickly in garbage collected language will be cleaned up. Like, do we care about this functionality a lot, or because there are trade-offs if we choose that?
Theoretically, according to the people who have written it, zero copy, what it does is it's supposed to not have to copy when you send it from kernel space to user space. Now, do I know anything about it? I don't. It's supposed to be fast because of that. Okay. Now, what I can say really happens is yes, because when the data size is big, even before complete data comes to the system, it starts doing the deserialization. That I know for sure because I have used enormous amount of data. I can say for that. Now, as far as zero copy, that's something, well, the people who have written it, they say we use zero copy, so I say zero copy. That's the problem.
I mean, that's a great response to that, because it means that it's not often very useful to have that feature, because
it might be very useful. I am not aware. It might be an extremely useful thing because from kernel space to user space, if it doesn't have to get, the speed is going to go up significantly up. But do I know whether it really does that or not? I don't know. It says it does. Fair enough. I say it does.
Great. Thank you. Okay. Time for Melinda. Question to you. Any opinion on passwordless sign-in and towards cookie-less thing? Lots of things-less kind of approaches. Is it really something considered?
I've seen that one in the chat. I tried to answer it, but I was anonymous. But yeah, I was mentioning FIDO, right? I mentioned FIDO 2 there as something that we see coming into demand. And whereas it's related to the browser, you really need to check whether this technology is supported or not, I guess. So yeah, it's coming.
Yes, nice. Thank you. Okay, let me skip to the Neal, because I think Neal, you have to go to the airport, so some questions to you. You mentioned about the sagas lots of different things. What would be your top favorite one? And like let's say the most used.
Well, there's no possible way to say that. I mean, that's the entire premise of my talk, is that generic advice in software architecture is useless. So there cannot be a favorite one of these, because by definition, different circumstances are going to cause you to do different things. Now, I can say that the two you should probably try to avoid are the horror story, because it takes the most difficult topology and tries to do the hardest thing with it, and the epic saga, which is trying to do orchestrated atomic transactions across a whole workflow just because it's so difficult to get right. And it's a common anti-pattern, because users say, oh, the whole workflow should be transactional, without realizing how difficult that is to try to implement that workflow. But none of them can be your favorite, because every single one of them is an it's depends scenario. And that's why software architecture is difficult, because you can't just rubber stamp decisions, say all of these shall be this way. You've got to do the analysis for every one of them, which I guess is good, because it's good job security for software architects.
Yeah, but people want shortcuts, I guess, and maybe what I should look first. But I understand there's no maybe.
It depends. That's the best. That's the most I can narrow it down, is it depends.
Yeah.
And I do have to run. So thanks very much for having me.
Thank you.
Have a great conference. It's great seeing you all.
Bye-bye. Okay, but we have still lots of questions and at least 10 minutes, and let's go for that. And I think, Nilesh, I need to find something for you, and there were plenty of those. Oh no, and we are going into environment variables again, but let's eat it. So there are cases where environment variables are not preferred in containers. What if you use AWS Secret Manager? You still need secret key to use it.
Right.
And then there is a second part, sorry, and mostly that key is stored in environment. If someone gets it, they can read everything. How should we store that access key for secret even, right, in a secure way?
Yeah. So personally, I haven't used AWS Secret Manager, but the general concept around this is there's a thing called pod identity. So with pod identity, what you can do is within this workload identity in Google, they have it. I think Azure has it. Probably AWS has it too. So with pod identity, you can basically say this pod running in my EKS cluster, you can access to this secret manager with a private endpoint or whatever, right? And then you give that access via your RBAC within the cloud, your AWS cloud itself with IAM policies, and then your application, your pod running in that will be able to access AWS secret manager, rather than you injecting a secret token or whatever that allows you to access parameters. So that should be the way.
Thank you. Yeah, hopefully that clears today discussions about environment variables. But yeah, it's tricky. It's tricky. Many options here. Okay, so back to Bojan. I had something for you, and it's about. I think you mentioned something about cloud formation and some issues about rollbacks. Can you elaborate? Is it true statement?
Well, just say that I worked a bit with cloud formation, and when things go messy there, they go quite messy. I do prefer Terraform. Personal experience, no research data, just my opinion. In Terraform, when I make a mistake, it's much easier to go to state where there is no mistake and to clean up everything. AWS, they are making really good progress with cloud formation, but I think it still needs some work. It's very good tool, to be fair, but I do like Terraform more. Again, personal experience, in my opinion, not backed by any data at all. So don't trust me.
Okay, so if you like Terraform, can you mention how to create database initialization script?
Well, I don't use Terraform for that, because when I have to initialize database, I have to worry about database schema, database migration, all that stuff, and that's completely separate topic. For example, in my projects, I work a lot with Fast API, and I use Alembic for that because I'm going to assume that database structure that I create, that's going to change, and that's going to change quite a lot in the first 3 or 4 weeks. So I use basically a tool that is just dedicated to that. It's very hard because people love using one tool for everything, and usually you want to use specialized tools for specialized thing. For me, database is more applicational logic, and I put that together with APIs.
Makes sense.
Not sure if
Thank
I
you.
answered correctly the answer.
Yeah, I think you did well. Okay, I have some questions to Melinda. So very interesting one, and GDPR is always like very tricky to implement, and there are like regulation changes as well. So do you have any opinions on database level design and what matters within GDPR?
Of course, you can do a lot based on database security there. You could like anonymize the data and always use encryption, of course, there. So the thing is that you would really need to analyze first what is the data that needs protection before you take action steps. And that is the hard part, I think. The tooling around it can be easily found. But actually to just check what's the personal identifiable data in that database, that's the most important thing to start with, I guess.
Okay, great. I think we discussed some of those different types of tools that you recommended, but there is a specific questions around different, what is recommended from the list, essentially. Do you have any, I don't know, anything that speaks to you?
All of them would work, I guess. Always depends on your use case. So again, I'm not specializing here on any technologies when I say find your solution. I really say that you need to listen to your customer, listen to what he needs, and then find the best tool.
Great. And let's add another question to you around protocols. Are they your single point of failure, since one account being compromised would mean the attacker gets access to everything else from that user?
Oh, good question. I'd have to pass on this one, honestly. I'm not into much detail with the specifics here. But what I can offer, because I've seen that some people been questioning about how the token is built up, maybe I'd share a link where you can read all about some specifications that you might be interested in there.
Yeah. I mean, it's tough questions about different like attack vendors. I guess there is some expiry date to all tokens. So technically, if you have to ask again for this permission in most of those protocols. So I guess that's some solution to this problem. Okay, thank you.
Thank you.
Let's see, Nilesh. What do you think about sidecar pattern in the Kubernetes world with microservices? Does it worth to effort to implement it?
Right. So it's a very broad question. I think when you're asking about sidecar, probably you're mentioning service mesh here. But other than that, if you need sidecars, and there's so many reasons we would need sidecars and different requirements, and I can't really go into details. But so I'll take the context of side service meshes here. So as you would probably know, running a sidecar pattern service mesh, which is the default pattern as of now, it consumes a lot of resources. Like if you compare Istio, like Istio, I know a client who had 1,000 requests per second coming, and then their application itself was consuming about 1 CPU and about 700 megabytes. But Istio sidecar went up to about 5 CPU and about 3 GB of megabyte consumption. So there are situations where this could be problematic, and then you first need to do the trade-off analysis that Neal was earlier talking about. Like, why would you need a service mesh? And if you are gonna use a service mesh, what are your requirements for it? Are you just going to use it for MTLS? Are you going to do header-based routing? Are you going to do A/B testing? Like what? And then you have to decide which service mesh you're going to do. Are you going to, like, if your only requirement is MTLS, maybe service mesh is not your choice. Maybe you can go with something like Calico CNI or something, which does encryption at a CNI level. So using eBPF. So then your resources are more efficiently used and you don't overpay. So I think these are the things you need to consider. And I believe moving forward, the whole sidecar pattern for service mesh might die down with a lot of people working and doing great things with eBPF and running node level agents instead of sidecars for each of your pods. I think it's got a great future. And as for startups, you really got to think what you're trying to achieve with service meshes. And if it makes sense, if you're going to do circuit breaking and doing all of these things, yes, go with service meshes. If not, if it's just simple MTLS you want, go with something like a node based agent like Calico or something else. That's
Yeah, great points. There are voices that, you know, the sidecar space is essentially overcrowded. Like you need like 5 sidecars to run pod these days. So it's great to see different alternatives to this problem. Cool, thank you. I think we kind of ran out of questions. Maybe I have like one more question. So if you have in the comment or each of you speaker maybe have some questions, please feel free to go. But in meantime, yeah, go on.
There was a question from a gentleman called Christian Picona. Hopefully I'm pronouncing it right. He wanted to know about Arrow. Just let me speak about that a bit. Now, Arrow was created for a specific reason. Say you have an X format and you want to send the data to another format. So that would require serialization, deserialization, and it's a pretty time-consuming and resource-consuming process. So what Arrow does is it's an in-memory data format. What it allows you is it has multiple connectors. It allows you to create connectors for multiple systems. So what would happen is if you have X format, you want to send it to Y format, you put Arrow in between, and on the fly, it would get converted. Because it's an in-memory thing, things would happen fast. That's what Arrow is for, was developed, designed for. And since that in-memory format, it's being also used as a format per se by different in-memory analytics solutions as well. Thank you.
Yeah, great. And maybe one question to Bojan. How would you say we can integrate Terraform, to automatic tooling for integration, continuous integration and continuous deployment? What are the best practices there?
Well, I'm gonna be honest. I need a bit more experience in that area because for me, I usually do those stuff manually because I'm always scared I'm gonna accidentally get some resources and services I don't want and get a huge bill. So
that's, I guess, is a disadvantage of infrastructure as a code, right? In some way.
Yeah, I mean, it's alchemy. I'm taking this YAML file, I'm transforming it to metal. It's not made out of gold, but based on how much GPU costs per hour, it might as well be. So I'm very careful when it comes to dark arts like that. So I still have to learn a lot.
Okay, thank you. And maybe a question to Melinda. Hopefully I don't press you too much on this, but I have this question as well. Like, there are different flows for auth code and PKCE, and essentially where we store JWT token. What would be preferable here?
So yes, you can either manage them locally, or you can, like OpenID does, fetch them from external providers. Like you would use then again your bearer token to fetch the same. And I think depending on the sensitivity here, you would decide which one you go best for. Possibly this would be for OpenID scenario, right?
Makes sense. Thank you. Okay, time is up. Thank you, everyone, for this Q&A session. Thanks to audience for asking those questions. And I guess it's time for some break. And after the break, we have three other sections today, and there will be other hosts to host it. So thank you, everyone, and have a nice break.
Thank you.
Welcome back, everyone. And now we want to say thank you to our sponsor, Site-24/7 by Zoho. Site-24/7 is a full-stack performance monitoring tool, and it will help DevOps engineers and IT operators to monitor websites, apps, services, cloud, and network. And this is a part of Zoho Corporation. And today, if you follow the link that we will post in the chat, you will receive access to $250 value of services at Site-24/7. It will be added to your account, and you will be able to use it around 6 months. That's what it's worth to do the monitoring of websites, synthetic web transactions, and lots of great stuff. You can read more in the description, in the chat, and also you can click this link and you will receive this credit to your 24/7 site account. Thank you, Zoho, once again.
Hey everyone, this is Nick. So yeah, we have a pretty long break ahead of us. So I hope you all take a chance to go like stretch your backs and take something to eat, to drink, or maybe even read some news. I don't know, but not too much, of course. We'll be waiting for you in 20 minutes from now, I guess. We'll continue. We have 3 more blocks ahead, and 3 of the topics we have next you see in front of you. So we'll be waiting for you. Okay, we're back. We still have some time before the next session, but I thought I should say hi everyone to you again. We still have 3 more blocks ahead. We have our next moderator already here, Hugo. So Hugo, do you want to say hi to everyone to join? Hey, I see you, yeah, Hugo here. I'm heading to the stage. Hi.
Yeah, hey, hi Nick, hi everybody. Nice to be here. I hope we are going to enjoy everything. We already enjoyed a lot of nice and interesting talks. So
where are you watching? Where are you watching the previous presentations?
All of them.
Awesome, good to hear. Yeah, like so you know the topics ahead of us, and I guess you have some introductions. So I'm gonna leave the stage to you, Will, and then for you to present the first speaker for this block.
All right. Okay. Thank you very much, Nick. Again, everybody, thank you for keep being in this amazing event. You know that, that there's we are facing very difficult times, especially people that are in the middle of this war. I think being able to keep going with this is also a message that nothing is going to stop what we are trying to do. So I also very thankful for that with all the people that is behind the scenes and doing all this amazing work. Let me start just introducing me. I'm Hugo Loza. I'm a system engineer with around 25 years of professional experience. Right now I'm director of engineering in Mojix, and my day-to-day work is basically working around architecture. So you understand why I'm so excited to be here, because this is specifically for that, not to understand and to have enough information so you can do the better decisions, when you are an architect. So one of the important topics that I personally follow is that we should be in continuous learning always. So we are basically in our field, that's not an option. No? So if you don't keep learning, yeah, for sure you are going to get outdated very fast. No? So keep learning helps, and in terms of architecture, keep learning helps us doing what we heard in the previous talk with Neal, that to be able to decide to refine our decisions and do the trade-off with more information. When we don't know many things, it's hard to decide. So these kind of events are excellent for that. So I really encourage everybody to register to any of the events, keep for the next days, keep attending the next days, because it will help you do a better decision. It will help everybody that is around here learning, because the questions that everybody asks helps a lot, because that's where we challenge everybody. We try to think around the solutions. So it's part of our job. So that's great. There is, let me just show you before we start. This is exactly what we're talking about. This is software architecture are those decisions that are hard to change, and we know that. I know we know that. I hope I'm quoting the right person. I read this from Martin Fowler. I assume that that's the right person to quote. But the important thing is software architecture are those decisions that are hard to change, and to be able to do the best decision possible, we need to know. We need to learn. We need to read, even test and try. And so, with all the knowledge that we are gathering today, I think that's going to be really helpful. There's another quote that I want to take the opportunity to show. Is I don't know who is the one that said it, but it's weeks of coding can save hours of planning. Probably you're a little bit confused right now about what it's saying, but if you read who said this is sarcastic. So I think you're going to understand what I'm trying to say. So planning, architecting, we know that it's not really straightforward or easy or fast if you want, but the time that we spend thinking about that is really going to improve the result. No, otherwise we can keep coding and trashing code and trying again a lot, and but without a good architecture is hard. No? So just wanted to share that with you guys, and let me now try to go towards the presentations. First, this block, we have three talks. All of them are around or are addressing very interesting topics that will help us to think about the contrast between the theory and the practice, not the real life. What happens when you need to talk with stakeholders, or what happens when you need to actually put in place your architecture and maybe it fails, maybe it's not the correct one, which happens. So let's try to do that. And of course, the first talk that we have, that is functional programming, is very interesting topic. Is something that we are listening and hearing a lot nowadays. Is not new, but you will see that it has a lot of use, in our scope of work. So we have three speakers. Or three topics, as I said. First of all, the functional programming paradigm. The next one is the software architecture in a non-enterprise world. It's a practical approach. And then the tips for the stakeholder management in the enterprise architecture. So with these three topics, I think we are going to have a lot to discuss. And part of this, most of you are here in the talks. You know already what is the dynamic, but just bear with me if I repeat. You have while you're listening the talks, please send the questions to the channels that you have for that, and we are going to start reviewing them and then making them ready for the Q&A session. So don't forget to send your question, because I said before, I was listening since the beginning, since the first talk, and I keep writing. So while I'm hearing, I write the questions so I can send them afterwards. Just a suggestion. I know that most of you are doing that, so maybe I'm just repeating something that is very obvious. And that's it. So I think, let me see if we are ready for our first, and if we are on time. I think we are, right? So
yeah, just tell us a little more about the first speaker and we'll start his pre-recorded session.
All right, okay. So first, we have our first speaker is Moses Gitola. As all of you, I hope I pronounced his name correctly. And he has 4 years of professional experience in the tech industry, building and designing developers. He is software engineer at Microsoft. And the topic that he's going to talk is about functional programming paradigm. So let's go and start that, please.
Yes, hello everyone. My name is Moses Gitola. I'm a software engineer at Microsoft. I hope you're all doing good and enjoying all the presentations. So today we'll be discussing the functional programming paradigm, and I'll be taking you through that. I hope you're all excited as I am. So let's dive in. Okay, so what is function? So today we'll be learning what functional programming is, the advantages of functional programming, the contrast between functional programming and object-oriented programming. I'm going to demo an example of functional programming. We're going to also discuss higher order functions and recursion. Okay, so we start with the basics. What is functional programming? I would say functional programming is a declarative programming style. By declarative, we mean it focuses on what to solve and not how to solve it. And it's based on the idea of functions with no side effects. It's based on mathematical functions, and having no side effects means not modifying input or any external properties of the program. Generally, they are called pure functions. So a pure function is a function that does not modify any external properties and is basically independent. So there are many examples of functional programming languages. I'm just going to mention a few. One of them is Lisp, Clojure, Erlang, and Haskell. But you'll find that most of the programming languages, such as JavaScript and Java, have adopted some functional programming styles. And in this particular session, I'll be using JavaScript or TypeScript. So TypeScript is an extension of JavaScript that allows us to add typing into JavaScript. So I'll be using TypeScript to demo some of the functional programming concepts. And we will start with the concept. So functional programming has concepts as well, the same as object-oriented programming has its own concepts. So the first concept is pure function, as I mentioned in the definition of functional programming. So pure functions are functions that do not have side effects. They produce the same output for the same argument. So there is no point of pure function should provide different output for a different or for the same input. Next is immutable data. So before we actually go to the next concept, I'll be showing you an example of what a pure function is. So let's say we have an array of numbers here. So a pure function that is supposed to return whether an array is empty will have the input of an array and return the length of the array. So in this case, since this is a pure function, just a moment. So in this case, since this is a pure function, we give it an input of numbers, it returns false. So an impure function, in this example, is modifying this external argument. So basically what happens is when the function is called, it has modified this external state and returned the length of this array. So in this example, when we call this impure function and give it the list of numbers, it returns that it's not empty. But now when we call a different function, or rather, even if we call the same function again, now when you call it the same function, it returns a different output. So this is an impure function because it has given us different output for the same arguments. The reason is because we modified the external state in this case. Now, the next concept is immutable data. So when data is created, it's never mutated. So what this means is that we should always create new variables whenever we need new data, and we should not modify existing variables. So let me show you an example of that. So this is immutability. Variables are not modified, but new ones are created. So let's take an example of the list of numbers we have here. We have 5 numbers. So we create a variable to get the first 2 numbers. So we call the splice function in JavaScript. We give it the start index and the number of items we want. We want the first 2 items. So once we log this variable, we realize that it has given us two items in the array. That is the first one, the second one. But now once we print the value of numbers, it has been changed. It's no longer 1, 2, 3, 4, 5. In this case, it's 3, 4, 5. So in order to fix that, what we can do in JavaScript is to use freeze function. So we give it Just a moment. Okay, let's create a new variable. Immutable numbers. So now let's console log. Let's get the first two numbers from this. Immutable numbers dot plus 0 2. So you can see now we are not able to perform this operation because this operation is going to modify this list of numbers. So what you're supposed to do in this case is to now create a new array and get the first two numbers from that array. So one of the methods you can do is just use immutable numbers, get the first one. So passing functions as arguments to other functions, and this leads to the concept of higher order functions. Higher order functions can be also considered when functions are returning values. So no, functions are return values. So in functional programming, we can also return functions as values. So let's dive into that. We define the numbers array again, and the first example is passing functions as arguments. So in this case, we create a function. This is our first order function. It's called square. It gets a number and returns the square of the number. Now, a higher order function that is inbuilt in JavaScript is the map function. It's a property of the array object. So numbers, we call numbers.map, and the argument we give it is another function. So in this case, what this function does is gets every item of the array is passed into it and returns a square. So we have a list of numbers here, 1, 2, 3, 5. And once we perform this operation on it, we map it to a different output where each value is a square of the respective item in the initial array. So in this case, you can see what happened here. We have an array of squares. Next is functions as return values. So we can return functions in functional programming. So let's create a function. We call it makePower, and it receives an exponent. So what makePower does is once it receives an exponent, it returns a function which takes an array as argument and performs this exponent function on every item of that array. So this is a function that has been returned. So makePower returns function. So let's look at the square function. So we create a square function and we call makePower2. So this means that we have created a function that this function that is returned from makePower2, once we provide an array to it, it gives us the square of every item of that array. Let's create another one. So in this case, we are going to call a cube function, makePower3. So the exponent in this case is 3. So let's print out a cube function with numbers. So as you can see now, we are able to create functions dynamically using the makePower, and the exponent is 3. So once we call with the same argument numbers, we get a cube of every item in the array. So that is the concept of higher order functions. So JavaScript has many higher order functions that are inbuilt. An example is map, there is filter, there is for each, and so forth. So these are the examples of higher order functions. So the next concept is recursion. So in functional programming, recursion is preferred as a method of iteration as compared to non-functional programming where loops are used. So let's look at an example of recursion or iteration in functional programming. So we're going to use an example of the Fibonacci sequence. So the Fibonacci sequence returns is of this form. So the previous number, so the current number is a sum of the last two numbers. So in this case, we add 1 and 2, we get 3. We add 3 and 2, we get 5. We add 5 and 3, get 8, 13, 21, and so forth. So that is the Fibonacci sequence. So using a loop, what we can do is to define the first two numbers and create a while loop. Then in each case, we calculate the next Fibonacci number and finally return the nth. So this is n, so we return the nth Fibonacci number. So in this case, if you look at the seventh number is 13, so we get 13. So this is an example using a loop. But in functional programming, recursion is preferred. So in recursion, we do not store a state. Basically, we define a base case that defines when the recursion is supposed to end. So in this case, if the number is less than 2, so if we are below the first two Fibonacci numbers, we return 1. So in this case, you can see the first two Fibonacci numbers are 1 and 1, so we return 1. But in the other cases, we call a recursive function, and eventually we are going to get the nth Fibonacci number. So calling the recursive function here in this case, passing n, we get the same value. So even though the code in here returns the same value, you can see the first one defines how we are going to achieve something, and here we define what we want. So we want to just get the nth Fibonacci number, and the code does not tell us how we are doing that. So that is an example of recursion in functional programming. So let's continue to the pros and cons of functional programming. So one of the pros is it's easy to debug as there is explicit flow of data. So as you can see, there is explicit flow of data because we do not modify external state. Then concurrency safety, again, because pure functions are very predictable. They do not need any data from the outside world, or rather, they do not modify data from the outside world. So in the case where we are running multiple functions concurrently, they do not try to modify external state, so there is no issue of deadlocks and so forth. Then it's very predictable, meaning that we can able to define what a function returns given a particular input. The output does not change for the same input. The next thing is that it's easy to implement concurrency, as I said here, concurrency safety due to the nature of pure functions. Also, it's easy to understand as pure functions do not modify external state. So the cons of functional programming is that higher order functions and composition can get complicated and compromise readability. So as you can see, we are composing functions. We have higher order functions, we have first order, second order, and so forth. So as we are composing functions, it can get quite complicated and compromise readability. So this is just in very few of the cases, but it's up to the developer to make sure that readability is not compromised. Then recursion can be a daunting task. So understanding recursion and understanding where the base case applies is also a challenge. So because in functional programming or in recursion, we do not define how we do not define how we are trying to achieve something. Instead, we achieve it directly. So let's go on to the next section. Now we're going to look at the difference between object-oriented programming and functional programming, because this is a question that mostly arises when developers need to start using functional programming and they come from an OOP background. So you'd like to know what are the differences and whether there is a superior paradigm over the other. So my opinion is that it mostly depends on the use case, because you if you choose functional programming, you're going to get different uses, and in OOP you're going to get different uses. So functional programming is based on functions, and object-oriented programming is based on classes and objects. So that is generally from the name of the paradigm. Functional programming is declarative. As I mentioned, it does not define how to achieve something as you're writing the code. But object-oriented programming is imperative. So when you're writing object-oriented code, you define how to achieve a particular operation. Then functional programming uses recursion for iteration, while OOP uses loops for iteration. The concept behind code reuse and functional programming is composition, and in object-oriented programming is inheritance. So let's dive into a demo. In this demo, we are going to look at how we can make use of functional programming and how we can look at it. So let's take an example of writing a program to print the number of matching characters in a string. So what this program is supposed to do, given an input string, for example, Apple, we need to return an object with all the characters. So we define how many so given an input Apple, we need to define how many characters of appear. So A appears one time, P appears 2 times, L appears 1 time, and E appears 1 time. So we are going to define a function that does this. And the first way to do it for contrast, we're going to start with a non-functional procedure. So in this example, we create an object map. The map is going to show the result outside the function. Then, or rather in the global scope. Then we create inside the function. We make sure that we initialize the map to an empty array, an empty object. Sorry. Then we start looping through the characters in the string. So in this particular case, loop from I is equals to 0 to the length of the string and get the character at that particular position. Then if the character exists in the map, or rather in the result, we increment the count, else we initialize the count to 1 and finally return the map. So looking at this example, if you pass the word procedure, P is 1, R is 2, and so forth. And using this example I mentioned above for Apple, we can get the same result. So you can see this procedure we are able to achieve that goal. Now let's look at the functional procedure. So the functional procedure does not define how we are going to achieve that. Instead, we use higher order functions. So let me remove that. Let's just write it again. So we are going to get an array of characters from the string. So we do not modify this input variable. Instead, we create a new one. So we call it characters. We split the array into characters. So this one now is an array of characters. Yes, it's an array of characters. The next thing we need to do is to define a function that is going to perform this for us. So in JavaScript, you can use the reduce function. So the reduce function is a higher order function, and it receives another function. So we're going to define the function that we're going to pass to the reduce function. So we're going to call it matching. So matching receives the first argument is the map. So the map is just the return value. There is return value. The second argument is the current character. We're going to call it a character. And what you're supposed to return here is a new one. As I mentioned, in functional programming, we do not modify variables. So we are going to return a new object which contains all the values of map. Then we create a new entry in the map, rather in the object, and what this entry should contain is the number of characters in the string. So the first thing we can do is check, did the map that was passed contain that character? If it did, we add 1. If it didn't, we use 1. So what we're doing is checking whether there was a current count. If there was, we increment it, otherwise we use 1. So this is our function that is going to perform the procedure for us. And now finally we return characters dot reduce, and now pass our function to it. So just a moment. Yes. So we pass our function to it. So the next argument of the reduce function is the initial value. So the initial value is just an empty object. This empty object is the one that we are now modifying, or rather it's not been modified, but it's done that it's been copied here, and a new value is created. So this is the new value that is created. Actually, we can do this initial value is equals to object.freeze. We create an empty object and pass it here. So as you can see from the result here, we still get the same value because object.freeze prevents this value from being mutated. So you cannot do something like initial value. So you're not supposed to do that. You're not supposed to modify this value. So what you're supposed to do is to create a new object. So as you can see from this function example, we have defined a function and passed this function as a value, or rather as an argument in the reduce function. And finally, you have also passed an initial value. And this initial value is being modified to return this composed value. So if you can check something like hello world, so you can see it's also the initial value is being used, and it's the first result here. Cool. So yeah, so we can actually just confirm if this one is the same. Find the matching function. Yeah, so we have the same result. So that is just an example. So functional programming is quite broad. You can use it for different functions, and you can also use it for different requirements. But it provides all those advantages I've mentioned. So as we wind up, let's keep in touch. You can find me on any of the shown social media platforms. let's continue this conversation. You can ask me questions on functional programming, and I'll be glad to help. So thank you, and enjoy the.
Okay, that was great. A great presentation. Really interesting topic about functional programming. We all know that this, as I said before, no, this is a topic that that was great. A great presentation. That we know since well, it has a lot of years of happening, and it's very important not to understand how it works. The sample that we just saw is interesting. I really hope we all understood the concept, and well, we need to see where it applies. I know that most of the best use cases are for machine learning and AI, but I'm pretty much sure that there are some other applications for that. Okay, so now we should go to our next speaker, next talk. The next speaker is Pavel Zinovkin. His talk is about software architecture in a non-enterprise world. It's a practical approach. Pavel is a software engineer, CTO, engineering manager with over 16 years of professional experience. Over the years, he helped build products used by millions of users of startups and big technology companies. He's Chief Information Services at BK, and I think we are ready to start listening to him. Let's go ahead.
Hello everyone, my name is Pavel Zinovkin. I work at VK, which is a pretty large internet company. Today I want to talk to you about software architecture in non-enterprise companies, startups or fast-paced tech companies, and this talk is based on my experience working in such companies. This talk is not about which type of architecture is better, for example, clean hexagonal or onion. It's more about building complex software system and what guidelines to consider while doing so. So let's start. When asked to describe the architecture of some systems I worked on or even built myself, this picture usually comes to my mind. Well, don't get me wrong, it doesn't mean it's all that bad. If the business makes money of it and if the team can keep everything running, it's totally fine for the software system to be that way. Well, as you know, perfect is the enemy of good. But it doesn't mean we should stop trying to make it better either. Interestingly enough, many people I know who work in different companies have the same opinion on this topic. So let's try to understand why. Well, here is my list of attributes or symptoms that I've noticed in fast-paced companies. Well, usually there is no person with an architect title. Instead, everyone is an architect of sort. There's no descriptions or diagrams of the architecture. Well, if they even exist, they're usually obsolete. And the best way to onboard a new team member is when some of the senior developers on the team talk to a new person and just describe the state of things. A company is usually focused on fast delivery of features to users, and a lot of effort put into providing fast delivery. This also leads to very short feedback cycle, and often it's all about online or real time. Well, this also makes changing things a bit difficult. And this list continues. So the bigger the company, the more usually cost of an error, and your type can be in the news. Well, it definitely guarantees some bragging rights. Often you can hear the phrase, we went too fast, let's think about architecture later. Well, business often is not concerned about the cost of fast decisions, and later in this case may never come. When finally trying to make things work, you may hear, we can just stop pushing features and re-architect the whole system. What have you guys been doing and how did it come to this? So yeah, nuances. Also, sometimes there's a legacy systems and code and usually no resources to fix them properly. Well, I think most of the problems with this architecture of such systems is not because of the bullet points above. Of course, they also contribute significantly to the state of the system. Most problem, in my opinion, are from the approach to architecture. Here's a few of different approaches to architect systems that I think I have encountered the most often. First one I call zero architecture. Well, yeah, that's right. It sounds very familiar to zero code or no code approach. And well, the result is quite opposite, and there's a lot of messy code in the system usually. Nobody wants to touch another person's code, and eventually nobody knows how it works. Usually there's terrific bus factor, but well, this approach was very good to job security. I've seen it a lot in startups, but it usually fails quickly on business scales. Well, I've seen it a couple times even in big companies. And it actually can be beneficial if you need to do something fast, like deliver some feature fast, well, at the cost. Another approach is rebuild from the scratch by the book. This approach is a typical outcome of many failed attempts to change a tightly coupled or spaghetti system. Business usually suffered long enough and finally gave its okay, and well, here we are rebuilding the system from scratch. Often it ends up, well, you will end up having old and new version of the system running in production at the same time. Well, even funnier that you can even see version 3, which promises to solve the shortcomings of all versions before before that. Well, and sometimes rewrite from the scratch is actually the only choice. And well, most important here is to complete the transition to a new system and not to get stuck with two barely functioning systems instead. Well, another approach is an architecture. With this approach, everyone is an architect. People actually try to do something good here, but there's no guidelines or best practices which everyone follows. Often new technology is added without considering its downsides, but because it's new and promises to solve some problems that might not even exist in particular system. The software system soon becomes too complex and filled with components that nobody understands. Well, complexity is a real problem. I think when bringing new technology to the system, you must consider if it added complexity is worth it. With this approach to architecture, reliability is also a massive issue. Well, the only good thing here is openness to new things, new technology, new systems. That's all I think is good here. What is good here? Well, last one approach, I think it's problem-driven architecture. Well, here is almost everything good. No chaos, guidelines and best practices are in place. But the problem here is with the driver of change. If you react too late to new realities, not trying to predict where a software system should evolve means you will constantly try to catch up with yesterday. The bigger the software system, the more problems you will eventually have. It might be really painful for slow systems like file storage, for example, or when you have to deal with scalability issues. Funny story that this approach works pretty well in early stage startups, just because startups usually don't have petabytes of data, and scalability can be relatively easily solved using some cloud-based infrastructure. Well, modern clouds are amazing. Well, yeah, that's it. So, familiar with some of the architecture styles I just described. I don't think that the problem here is somebody's malicious intent or bad will. I don't know. In my opinion, most of the issues with software architecture come from the lack of guidelines and principles. And principles like do not harm that doctors have. Ones that do not hinder you, but rather help you to make better decisions. So here is my set of principles that I think are most helpful in current state of things. Well, first one is not about which technology or methodology to use. Instead, it's about what should guide your decision. For me, it's these 4 bullet points. Well, first one is about perfection. I'm a perfectionist, and it's always a struggle with me with this bullet point. Well, over time, I kind of learned to control it, and well, love the Pareto principle. But well, of course, I still think that setting a high bar is important, but it's also good to know when you are just treading the water and not doing any good to the project, to the system. Next one is about complexity. Well, the way I see it, technologies evolve way faster than we learn not to overcomplicate things. The higher the complexity, the more difficult it is to maintain the system. It also increases the chances of errors and outages. That's it. Next one is about decision process. I think it's vital to align your technical decisions with the business goals. When deciding about some technology, first you must consider how it will help the company, and only then if it will be fun to work with. And last one here is about quality and reliability. I think everyone agrees that these 2 properties are essential for any modern online system. What's the point of all features if bugs or outages stop users from using them? Yes. So, second principle, design for observability. Observability is important for software system, and in a fast-paced environment, I think it's vital. With fast features delivery and feedback cycle, you need to locate problems even faster. And most of the time, you want to understand the situation in real time. I have never encountered a situation when an application logged too much. So, but not having enough information in logs is often a problem. With modern solid-state drives, writing too much is not a big deal, and well, you also can always implement level logging, so you can just reduce login system output if you need to. Well, but the problem with logs, if they are just some logs on some servers without the means to access them fast enough, they are almost useless. Invest from the start into the tools to collect and process logs, so the data is available when you actually need it. Next one is collecting and monitoring errors. I think it's a huge help when some bug occurs. You don't need to dig through a bunch of logs or try to understand what happened from the description of the problem. We all know that users are terrible at describing what went wrong. So you will immediately be notified about the problem when the correct tools in place, and there is no bug, or if nobody noticed it, just fix it fast enough. So design and build monitoring and observation tools before problem happens. Third one is focus on zero trust security practices. Well, I can't stress it enough. Security is a fundamental requirement for any modern system. If it's online system, real-time system, well, exposed to internet, it must be secure by default. In this new reality, a lot of people work remotely, so as a result, there's no safe perimeter for most systems anymore. Even if you think you are secure in your private network on dedicated hardware, there's no such thing as secure network. There's a lot of components in any modern systems, and any of them can be vulnerable. We just don't know it yet. Same is correct for cloud infrastructure, actually. Cloud is essentially virtualization over some hardware. So hardware that somebody else owns and has access to, physical access, but it's not you, and you can control it. So it's vital to incorporate zero trust security principles in any system from the start. Okay, use cloud native technologies. Cloud native is a really huge thing. This screenshot shows just a fraction of the tools available under this umbrella. Some of them may be already known to you. Well, you should check it out. Cloud native, in the essence, it's an ecosystem and a paradigm that fosters building loosely coupled systems that are resilient, manageable, and observable. It's incredibly beneficial in building and running scalable applications in modern environments such as public, private, or hybrid clouds. Cloud Native Computing Foundation serves as a steward and helps with the growth and evolution of this ecosystem. There is a site, Landscape CNCF.io, which provides a vast collection of proven and tested technologies that follow the cloud native paradigm. Next one, prefer existing standards for API. Well, what can I say? I've seen a lot of APIs that don't stick to any standards and common sense. Working with them is constant pain, and please don't do that. Building distributed system using inconsistent API guarantees you only one thing: you will need to replace it sooner or later, and it will require twice more effort. You will need to design it first properly, and then migrate the whole system without breaking anything. So in real-time system, it's gonna be funny. API development is actually a well-established field with many standards, guidelines, and approaches already available. So as a result, there are plenty of choices. Following existing standard help with API adoption even inside the system, inside your company, between parts of your system. That's it. For public API, I think following the standards, it's a requirement. Next one. Choose efficient technology. Well, yeah, that's important. I think wrong technology can be a serious roadblock. Unfortunately, sometimes technology choice is based on convenience and not efficiency. I think some of you may have heard something like we are Java or PHP shop, and that's the only language we will use for any any stuff we build. In my opinion, it's a wrong approach, and it may limit your options in the long run. Of course, there's a lot of old, proven, and reliable tech around. Just keep an eye on it when it starts to slow you down. Now, depending on the size of the system and the state of things, switching technology, database, programming language, or API may be painful when the system is monolithic. It's too tightly coupled. It may be good to start changing architecture in the direction of microservices. Decoupling the system first is important if you change some of its components. I think microservices truly shine when you need to mix different technologies and programming languages. Although I'm not a fan of applying this architecture in early stage startups, it requires too much effort, I think. Automate and experiment. Well, modern systems go nowhere without automation. It's crucial in improving time to market, significantly reduces the burden of supporting systems, and of course, it's an integral part of quality assurance processes. And the last moment that I consider important is to continue studying new technologies and experimenting with them. It's more of a personal note, I think. For example, in a startup, you don't have the luxury to waste the company's time on experiments. Well, basically, startup is all about the survival of the idea and not about checking new tech. That's it. But the bigger the business grows, the more important new and prospective technology become to its success. So keep an eye on new tech and, well, check it out and learn something new. That's important. So here's a quick summary of the principles. Use your best judgment. Well, because obviously we build in complex systems and we need to think clearly and understand requirements of the business before making any decisions. Design for observability. What can I say? If you don't see the problem and you don't know about it, users may be suffering. Focus on zero trust security practices. Use cloud native technologies. They are really helpful, and a lot of new stuff that can really help. Prefer existing standards for API. Choose efficient technologies. Automate and experiment. That's all, I think. Well, yeah. That's it. Thank you for listening. Bye.
Okay, great, great list of tips and guidelines, no, for how the software architecture is applied in the real world. Of course, there's a lot to discuss, a lot to understand, no, all the concepts that were listed, and I think most of us have some questions around that. I hope we will get some of them. So now let's go to the next topic and the next speaker. The next speaker is Pranjal Bathia. I really hope I pronounced it well. The talk title is Tips for the Stakeholder Management in the Enterprise Architecture. She's principal architect within the PNT operation and infrastructure team in Red Hat. She has 12 years of experience in designing and developing solutions and products for different business problems, not challenging business problems. In her current role, she has architected a master data management solution. That's a really interesting topic, I think. Before this, she has developed enterprise middleware solutions that handle millions of events on a daily basis. Yeah, so I'm assuming if we are talking about millions of events, we're talking about also scalability and resilience. So it's another interesting topic. And Pranjal holds a master's degree in information security from one of India's premier engineering institute. She's a mom and two beautiful daughters, and is usually busy balancing that. And I understand that. I totally understand that. So let me bring you to the stage, Pranjal, and tell me if I pronounced your name correctly. Otherwise,
yeah, you were right. And thanks
very
for the
well.
warm introduction.
No. Thank you for presenting. So the stage is yours. See.
Okay, cool. Thank you. Okay, let me know if you all can see correctly. Yeah, I believe so. Okay, cool. First of all, I would really like to give big kudos to the organizing committee because they're organizing this event irrespective of what's happening in the Ukraine. So with that, let's get started. My name is Pranjal Bathia. I'm Principal Architect for PNT Operations and Infrastructure team at Red Hat. So my primary responsibilities right now are architecting a solution at enterprise scale level. And I nearly have decade plus experience working in IT industry. So as a part of architect, I had a chance to solution at Red Hat for the master data management. And while working with that initiative, I learned certain tips very hard way. So with this talk, I would like to really share my thoughts and tips, whatever I had learned as a part of one of the initiative I led at Red Hat. So high level agenda for my for my talk is really, let's talk a little bit about what is enterprise architecture, revise that concept, and talk about why we really have importance of stakeholder management in enterprise architecture, and then followed by the tips I learned throughout my journey, and then followed by questions. So let's see what Wikipedia says about enterprise architecture. So Wikipedia says that it's a discipline that allows you to define, organize, standardize, and document organizational structure and interrelationships. So it could be for different business domains like physical, organizational, or technical. So like EA is a discipline, and in order to have that discipline, why we really need stakeholder management? Because normally when EAs are involved, it's a big initiative, and many of the product managers and program managers will be there to handle the stakeholder management. Why do we really need to concern as a EA for stakeholder management? So, first of all, if stakeholders can either make it or break the success of any of the project. So irrespective of whether you deliver the objective, irrespective of you made the deadlines, if stakeholders feel that they are not happy, your project is not really successful. So that story even is true for the enterprise architect, because for like when I started with my journey, I had a similar thought in my mind, and I started taking things casually with respect to stakeholder management, and I used to focus only on solutions and architecting the things. But soon I realized if I continue to do in this way, probably I will not be successful in my job, rather I will not be successful to get the initiative done, which for which I'm responsible for. So why do we really need to concern about it? So stakeholders really provide critical inputs for enterprise architect. And as an enterprise architect, we really have responsibility to capture things accurately for the current state as well as solution you are going to propose. And as you really get more engaged with the stakeholders, you will have more opportunities to anticipate their needs in the starting stage. So often, an early communication definitely will help you to get the architecture better and get the accurate models represented. Again, as enterprise initiatives are always big and they are generally led at organization level, they tend to be complex. Now, when we have conflicting and complex situation, if we have better engagement with stakeholders, it definitely help us to change our strategy by considering the concerns from stakeholders. So with all this, definitely there is a real need why as a EA we would need to consider stakeholder management. So let's start with some of the things. So like I mentioned, generally enterprise initiatives have 100 plus stakeholders. So if you start having conversation with each one of them in a random fashion, you are probably gonna miss out whom you contacted, for which context, and so on. So how will you really tackle that kind of situation? So in my opinion, and that is pretty even concept available at many of the different places. So first, I felt we would really need to work on identifying the list of stakeholders, then classify those stakeholders as per your different characteristics, and then determine where you are really gonna spend your time wisely. Because spending your time wisely is really important. As an enterprise architect, if you are going to talk to 100 plus stakeholders, you only have 24 hours a day, and out of those 24 hours probably you can spend 8 to 10 hours for your work. So with that 8 to 10 hours job, you cannot just simply coordinate with stakeholder, you would need to get your job done also. So identifying, classifying, and determining is really a crucial step for having any engaged stakeholders for your initiative. So here I listed some of the questions which will help you to understand how do you really classify or how do you get really the list of stakeholders. So you can think in a way, who really gonna gain and lose from this change, who is really in charge of the change management, who owns those systems, who is responsible for making the decisions, who owns the resources, who is really sponsoring the project, what are the skills we need for this project, and so on. All of these questions will probably help you to get the list of stakeholders, and I'm sure that is going to be the huge list. So next job for you will be try to classify that list in different characteristics. So you could think in a way like you can probably classify based on their power, their level of interest, their expertise, their skills, and so on. Here one of the example I gave is like classified based on the power and level of interest. And with that you can really determine where you have to spend your time the most. Like for example, in this quadrant, we have key players as quadrant D, which are really having high power and high level of interest. So these are the stakeholders probably you don't want to miss at any cost. So these are the stakeholders you would need to really keep engaged throughout the process. And then quadrant B, if we talk about, this is really the level of interest is high and the power is low. But still you would need to get these folks engaged because they will be your big supporters. As their level of interest is high, you can always use them for taking their opinion to know whether things are going in the right direction or not. For quadrant C, you would probably spend time little wisely, considering their power is high, but you don't want to over communicate with them as their level of interest is less. And with low power and low interest, probably you really don't need to spend hell lot of time. Just by sending some communication to that group of folks will be suffice the need for your project. So now you have the list, you classified that list, you also determine whom you are gonna continue engage throughout the initiative. So what next you are gonna do? Probably start having interactions with these folks. So for my initiative, I really use these two tools, Lucidchart and Miro. Both are proprietary tools, and both comes with free as well as licensed version. So Lucidchart primarily I used for mind maps, because when you start having conversation with stakeholders, you would need to make sure whatever they are talking about, you should have some visuals which will help you both parties to understand you both are on the same page. And I can give you some of the examples which I had as of the one of the initiative in Red Hat. And I this is very basic examples I'm sharing over here. Let's consider as we have an initiative to have master data management system in place at an enterprise level. So that master data could be for customers information, could be for product information, could be for accounts information. I'm not really concentrating at this point of time what it is. But probably to start with, what we are going to think in a way, what are the benefits we are going to get from the master data? So we will definitely have the clear origin. With master data, we will have a complete information. It will have reliable and secure data. It will have more clarity into the data, how the data is structured, organized. These are some of the obvious benefits we will get with master data. but depicting in certain visuals really helps you to understand those things pretty clearly. Another example I can give you is like, let's say you want to have an implementation for master data management. Obvious things you will think in a way is like, as an architect, probably it is a pub sub model. So who is going to be the publisher, who is going to be the consumer? Now for a publisher, you can think in a way, who is really the actor, who are really going to be responsible for publishing that data into the master data management system. What is the process it involved? What is the governance we are going to have for getting that data into the system? What are the systems involved? Is there any automation which will take place for validation, enrichment, etc.? And on the same line, for consumer, you will probably think like, what are the different methods through which that data will be accessible to the end users, whether it is API, whether it's over message bus, or some other ways. And again, what are the crucial systems who will need that data? Because based on their needs, you would probably need to add or update certain characteristics into the data structure. So these are a couple of mind map examples. This really helps you to get visualized at very high level, because this is the stage where you just started having interaction with stakeholder, and you just have high level goal shared by very high level management team. Now another tool we used is Miro. Miro is again collaboration tool, especially used for like collaboration, and it helps you to bring different stickies. So this particular tool you can really use when you have large group of people in one meeting. Examples are workshops where you want to hear different perspectives, because if you are dealing with huge number of stakeholders, you are not going to have enough time to have one-on-one conversation with each of those. So you are probably going to have certain conversation where you will call multiple stakeholders and would like to hear multiple perspectives at the same time. But again, considering time limit, you cannot just have everyone will not get chance to talk in 2 to 3 hours. So Miro really provides a very effective solution over there, which allows you to collaborate at the same time. Multiple folks can really collaborate. They can put stickies as per their perspective. And what we really did for this kind of workshops by using Miro is, we categorized, compartmentalized things based on certain logical grouping. And then we allowed stakeholders to write their feedback in different compartments. So these compartments are based on like, horizontal row is really the logical compartment, and verticals are like what really worked best, what did not work, what is the improvement you would like to see. So this Miro tool really allowed us to grab that different perspective in one board, and then we went back and then analyze the feedback over here. But again, all of this exercise really helped us to have the effective architecture built in the start, because that architecture already had different perspectives heard from different stakeholders. Now you already have some thought in your mind how it's going to look like, what are the different perspectives from different stakeholders. Now next step as an enterprise architect for you will be start modeling those and start having architecture diagrams in place for those thoughts. So here, one of my suggestion or recommendation will be, have different models for different group of stakeholders. So here I used Archi. Archi is a tool, open source tool, which allows Archimet modeling language. And it is a standard language for architecture models. And I used Archi tool especially because it was giving me flexibility to connect process diagram with the system flows. So I can give you some examples with Archi, and those examples are again pulled based on whatever we had mind maps. So let's again take the example of master data management. So as a master data management, one of the course of action we were having is create a single source of truth. Okay. Now, when we say this is a course of action, the outcome for that will be master data for product, master data for accounts, or whichever object. Now, it will come up with definite separate goals, like it will have modular representation, because we would like that accounts, customers, or products to be organized pretty structurally. Now it will have accurate data. It will, because MDM is really the discipline, so it will have governance in place. It will avoid data duplication, and it will allow integration with other systems. So these could be some goals we can depict. Now, a couple of goals will directly the impact or realization from the MDM data principles. So this kind of view can be beneficial to consider as a motivation. So Archimate allows you to have different conventions. So it allows different color convention. So here light orange is really talking about the strategy, and then this purplish shade is really talking about motivation. What is going to be your motivation? What is going to be your goal, and so on. And another examples I had over here were like really the business processes and blue boxes. Blue boxes are nothing but application systems. So here yellow boxes are really the business components, and then blue boxes are application components, and then green boxes are really talking about infrastructure. So let's assume again example of the master data management. And here I try to drill down a little bit considering master data management for products. So let's assume we have a product and we are going to have the centralized repository for all the product information as a part of MDM initiative. Now, typical actions from customer for any product will look like they will probably go to some website, your company website, I would say, and they will evaluate different products with all the information available on that. They will try to purchase one of the products which they are interested in. Then they will download the product, because here I'm really talking about software products. So they will download it, they will install it on their box, and if they are facing any issues, they will raise a support request with the company. Now, all of this is like simple processes customer will follow as a part of any engagement with the software subscription, or this is example for the product subscription. Now, on the back side, evaluate will use the website, purchase will use order management system, download, because it's going to be the huge files. It will be available through content, some of the content delivery network. Installation is somewhere they are going to use their systems, and it is internal view from company. So customer systems are not depicted over here. And customer support will again have some different application for support management. All of these applications are going to use product as a business object, because product is something they're all concerned about, what it contains, how this is charged under this product, what are the support characteristics are available, and so on. And ultimately, we are thinking on storing all that product information into MDM platform. So this view clearly helps you to understand what is the process involved from the customer end. So business stakeholders who are really very close to customer journey, they will be able to relate, okay, this is customer journey. And for this customer journey, these are the applications supporting on our side. And these applications will need product as a data, and that data we would need to at centralized place. So this view will give them a clear picture, because they will be mostly involved into the process, and they may not have detailed knowledge on how the systems are being behaved, what is the purpose of each of the systems, and so on. This is one view. Another example I was having is like, let's see, if you have certain stakeholders, very high level, they are interested in who are going to be impacted with this master data management initiative. So what one could be like, who are the people involved into this, what kind of information it's going to store, what is the process is going to be affected, and what is the technology it's going to be using. So all these different views can be used or can be easily created in Archi. So one of the beauty of Archi is really you can use similar components to create different views, and you can easily have different labels for different views, different labels for same component, I mean, because many of the times what I observed is, if you are dealing with very large initiative, many times those systems are treated differently in different departments. So when they are treated differently, they are having different naming convention. So if you are having on the back end the same system, and if you could just have different labels posted into Archi for different views, it really gives you direct clarity. Okay, this is the same system, and you don't really need to remember. So Archi gives really lots of benefit to connect the business portion to the technical portion. Now we really have the models in place. We started having engagement for the stakeholder. What next you would like to see from the EA standpoint of view, as well as stakeholders perspective. So one of the thing I felt was like, as an architect, we generally tend to have more technical conversations. And when we are good in technical conversation, we try to avoid certain informal conversation. So what I realized soon is like, just having technical conversation probably not helping me to get the enough rapport with those stakeholders. So I started allowing myself to have certain informal conversations with those stakeholders. And believe me, that really helped me to build the rapport with those stakeholders. And then I was able to get them connected so well, so that I was able to understand their perspective in a better fashion. So my suggestion or recommendation here will be, even though you are technical, sometimes you can allow yourself to have informal conversations, and continue to seek clarification until you and stakeholders are on the same page. And like I mentioned, having visuals. Without visuals, I think none of the conversation with stakeholders were successful for me. So use visuals for every single conversation with the stakeholders. That helps you to bring both the parties on the same page, and you can always correct those as you are going on. So like many times as an architect, we have possessiveness to the solution we are proposing. So I would suggest over here is like, be open for the iterations, because even though that architecture for the given initiative might not be very perfect, but if it is serving the needs for stakeholder, I think that is good enough. So be open for continuous iteration based on stakeholder needs, even though that may not be very perfect architecture. Next is like, once you start having mutual understanding, next thought I was having is like, have the communication plan ready, because as a EA, you are really not just talking to the management stakeholders, but you are mostly involved in even into the technical folks. So even though many big initiatives generally have a team of product manager, project manager who are responsible for stakeholders, stakeholder management, still I would recommend you can have those conversations with your stakeholders as a part of the meetings which you are using for getting their understanding, validating your models, etc. And you can utilize those team of product managers or project manager to have the communication plan. Another suggestion I would have is, many times we tend to have our code into repositories, GitLab repositories or any of the GitHub repository. I would even recommend have your models, architecture models, even into repository. The benefit you will get is, because as a EA, you will never have closer engagement with the delivery. And many times certain things get changed during delivery. So if you are having your architecture model post to repository, it will allow the delivery team to make certain modification, and with that probably your documents are gonna be the real live documents and accurate one with the implementation. And I would, again, another thought is like, keep on sharing the status, and it could be based on emails, bi-weekly emails, or reuse the existing meetings, or make use of project manager. And last but not least is really, try to seek for the help wherever you see the roadblocks. I know as an architect we can really solve any of the problem, but I think reaching out for the roadblocks is really helping to get different perspectives, and sometimes it's really easy to get overcome with those roadblocks. So at the end, I think again I would like to emphasize on stakeholder management is not just important for product managers or project managers or product owners, but even it is very useful for being successful into the enterprise architecture journey. Thank you.
Thank you for really interesting talk also, and a lot of info that you shared with us. I think based on this and we've finalized all the talks, we should go into Q&A, and for that I think let me see if I have the other speaker around. I don't see Pavel. No, I don't. So let's start. Pranjal, there are some questions that I was actually writing, so let me start with those. Okay. Let me find them. Okay. When we talk about stakeholders, I always have the same question and the same thinking. What type of information we should share with them so it's helpful for us as an architect? Because, for example, let's say just an example, deciding what database we're going to use, or the structure of the tables to be more precise. Is that something that is useful to share with them, or until what level we should do that?
Yeah. So one of the thought I had was like, many times stakeholders are not interested into stakeholders are not interested into the systems and how data flows are doing. They are mostly getting connected with the processes because they are on that party, and that's where I started using this process as well as system, like connecting these two pieces. Just one second. I lost you. Yeah. So that was my thought.
Okay. And in terms of the difference, one of the previous speakers, and also you mentioned a type of architect. The previous speaker mentioned the business architect. I usually have in mind what we call software architect, and you call it enterprise architect. So I will ask you to try maybe to explain what we understand by an enterprise architect from your point of view, and maybe we can discuss about the other two together.
Yeah, sure. So in my view, enterprise architects are always dealing with the initiatives which are having impact at enterprise level. What I mean by enterprise level is like the initiative you are going to lead with are going to have minimum 20 plus system impact. So, and those systems will not be belonging to one department, but it will have impact on multiple departments within the organization. So for example, when I spoke about master data management, it's definitely going to have impact on the sales team. It will have impact on the engineering team. It will have impact on the finance team, and it will have even impact on the support tooling side. And I'm talking based on Red Hat experience, because when I mention finance, it's the place where customer information is stored with respect to what they have purchased. So it has impact over there. What we are offering from Red Hat is all engineering products. So this is where engineering team is impacted. So multiple departments within organizations are impacted, and having any solution in between to deal with all of those applications which will have impact across the organization is really the enterprise architecture, in my opinion, in very layman term. And
Okay, so
not just developing the solution or architecture for a particular product, but it's really the designing solution for how the systems are going to integrate with each other, and how the data is going to flow with each other, what are the processes going to change between the different systems and different departments, and so on.
Yeah, got it. So it's very similar of how I concept what I call software architect, or business architect. So enterprise and business, it sounds like similar from that point of view. And I don't know if you agree with me, but software architect, that was is one of the roles. One of the roles that the previous speaker said that is in the don'ts, or that some companies doesn't have or doesn't have that role, and usually a software architect is the senior developer or so on. my opinion is that is a different scope. No, the software architect and the business or enterprise architect really have totally different visions of what they are going to do. No, I don't know if you agree with that.
I think in Red Hat, at least, we have different business architects, different enterprise architects, and different software architects. So primary responsibilities for business architects are really designing the business. So when I mentioned designing a business is like, for example, if we are going to have certain offerings on our Red Hat products, how those offerings should get structured. What are the different characteristics you are going to apply? So the architecturing solutions which will have direct impact on the business, and that is the term we really use for business architects. And for enterprise architects, we generally use the term, like I mentioned, back office application, how those are going to interact with each other. And software architects are the actual architects for the individual products, like for example RHEL or OpenShift or OpenStack and so on. So the folks who are involved into designing the products are called as software architects, at least in Red Hat.
Right.
And those are even called as like distinguished engineer or principal engineers sometimes, not directly, but they do have a role as that.
Okay. Okay, there's another question from the audience. Let me put that in the banner. Do we need to develop a glossary of terms because we have different stakeholders, and most of the times the stakeholders are non-technical people? That's a very good question.
Very good question. Yeah, I think I missed that in my presentation. Probably I should add it. Yeah, definitely have the glossary. Start having those glossary terms approved by different stakeholders. We do follow that practice, especially for the data governance, to make sure everybody is really understanding the same term in the same aspect. Because at least in Red Hat, we were having different meanings for the products. Some folks used to feel that it's an engineering product which we are developing. Some folks used to say that it's a product which we are selling to customer. So like having that glossary is definitely a great question, I would say.
And how that works, how that glossary works in your side, because each team is still using the terms that they understand. So we have like a translation glossary between teams.
Actually, what we did was like we started having data governance team together, and that data governance team was responsible for bringing those stakeholders together, especially for the terminologies and their definitions. So we started deleting the earlier definitions and then revamping the new definitions and making sure everybody is approved with those new definitions. So that was our strategy.
That's right. Okay, thank you. Next question here. At this high level architecture, are you still connected with actual code, or is this not required anymore?
So for my personal experience, it was not very required, but I did drill down into the data model, how the data is going to be structured. Now, when I started looking into data model, I had to look back to the current applications, how their applications are using code. But again, it was not very deep level. I was just connected to code to get the understanding, but not on the front of like developing something. It was pretty high level. Thank you.
Thank you. Okay, let me go with another questions that are that were for Pavel. I will. Let's try to do our best to answer together. Pranjal, I think there are some common knowledge here that we can help. So for this was for Pavel. How to reduce the technical debt once the product starts growing and refactoring, re-architecture need to be done, but there is no time to achieve it. Do you have anything to say about that? Maybe.
So in my earlier role, we just followed the concept of like normal sprints and then hardening sprints. So normal sprints used to be for feature development, whereas short hardening sprints were focused on resolving the technical debt, and that really helped us to close a lot of technical debt.
Yeah, in my experience, yeah, it's really hard. It's true that it's hard because each time we evolve our platforms or our software, yeah, we are not spending any time to try to reduce the technical debt because yeah, the common thing, we don't have time. No, there's something that we need to deliver. But at the same time, we need to really, I think, all together, we need to think that it's not helpful at all because at some point that's going to blow. No? That's going to make us think, okay, let's get rid of that and redo everything again, which is also not a good thing. No? So what we are implementing, at least in the teams that we are that I'm handling, is that we're starting to do by the book, as I think someone said before, is to start following the code reviews and the technical code review and trying to identify always the technical depth and create the tasks. And then with the planning, we try to, of course, we need to analyze if it is a real thing that we need to do for some level of urgency, and then plan it, no, and make it part of the product. No, so not something that is extra, no, but it's hard. It's something that we are not doing yet, but it's because it's very hard.
Yeah, true. And we even started thinking on like if we could have microservices built in smaller chunks that will help you to avoid certain technical debt and have new architecture in place. And I think we will be happy to hear what Pavel wants to say about this because it was questioned to him.
Yeah, Pavel.
Oh.
Thank you for joining. This is a question that the people sent to you.
Okay, well, it's actually a very nice question, and in my experience, the best approach is well, you can just go to both your management, to business people, and tell them, oh, we kind of want to stop producing features and kind of reduce the system. It's it just not going to work. Well, I always try to do something like this. I try to kind of sneak technical improvements in daily tasks, split into small batches and kind of hide it between normal tasks. This way, first, we still continue to produce stable results, visible results to the business, and we also continue to work on constant improvement of our system. It's not like here, this sprint we're only doing product tasks, and this sprint we're only doing internal tasks. It's not like this. Always split amount of time available between tasks and incorporate both kind of tasks into your sprint. That's it.
Yeah, no, agree. Did you have any experience maybe doing what you're saying, that it's not a good thing is to have a specific sprint only to do like a house cleaning of things?
Oh, it's usually in downtime, when there's no significant work to be done. And for example, before in the year of New Year, we have a downtime. We just can't deploy anything, and it's basically a freeze in most big tech companies. So we just do cleanup tasks.
Yeah.
In this time of year. That's it.
Okay, so let's go to the next question, please. Okay, let's try to read this first. Thanks for the presentation. What about frameworks that extend to the think they are good to adopt in small teams?
Well, I have, I think, good experience with different frameworks, and well, I started as PHP developer, and I still remember the time when everyone was kind of developing own framework. So I tried a lot of them, and in PHP, then I moved to Python and Django. I still respect Django. Django is a great web framework. Now I mostly develop something in Golang, and funny thing, Golang is not about frameworks. It's more about libraries, modules, different paradigm. But still, frameworks, it's a good approach, but just to the extent how good framework for particular job, for particular task. That's it. For example, it's very hard to build a real-time system with Django. It's just a different tool. It's a tool for different job. That's it. So to be able to use some frameworks, like to have it in your tool belt, it's always a good thing. But I would not be kind of blocked by particular framework or tool set. That's my idea, I think, about frameworks.
Yeah, thank you. Pranjal, any comments that you have?
Yeah, not particular. So as per situations and the initiative we are dealing with, probably you would need to make that choice which framework suits. So whether it's modeling framework, whether it's technical framework, I think like whatever suits best for that situation. Yeah, and as an architect, you would need to know certain competitive technologies at the same time. So you will be able to make that wise decision which framework works for that time. True.
That's right. Yes. One of the risks that I see usually, and I think it's very common, and it was in one of your slides, Pavel, is that sometimes people or even us as an architect will try to find the best framework. And usually there's someone that if you search which one is the most, I don't know, known right now, which is the most used, and we have like several ones that we need to choose from for a specific task. No, so I think sometimes it's hard to choose, especially for small teams, and the best way we found it is to try to see which one has the highest or the higher community or the most big community. So at least you have some support, no? And then, but it's hard. I think it's not easy, an easy solution. But we need to think that it's a very important question to respond at the beginning, because that's not going to be easy to change afterwards. No?
Yeah, sure.
So very, very true.
Yeah,
and that's a great point. Looking out for the community so that you will get support in between.
Yeah. So let's go to our next question. Let's start now with, do you think that it's sustainable to constantly add new features to a legacy software without dedicating or refactoring?
Oh, well, it's sustainable if you can sustain it. I don't know. It's just amount of effort you need to sustain this way of life. That's it. And the decision to finally refactor, to re-architect, it's usually grows from when developers became unsatisfied with how fast things going, and well, in the business, usually the amount of bugs, downtimes, stuff like this. Ideally, in my understanding, in my how I feel about it, no, it's total nightmare. I worked in such environments, and it just I don't know. You just don't like it. You just don't feel like it's a good idea. And but again, we work not in vacuum. We work for the business, and if we see that business can't afford to refactor it, well, that's the way, I think.
Yeah. Do you have any comments, Marshall? Maybe from the experience?
You covered exactly. It's a nightmare, especially, and still, even though it's a nightmare, you would have to support because business is still running on those. So yeah. So like
Yeah, and
only thing that we can do is like influence the business,
Yep.
and then come up with certain factors, and then facts. I would say if we do this, if we invest this, it's like capital capex and opex, right? So if you invest into this capital investment, you will have overall saving in the opex. I think that is how I started doing it, to convince the stakeholders, because otherwise it's not the motivated team from the development side, because that's so buggy if you continue to add new features and so on. Yeah.
Yeah, no, that's true. That's true. And I think also from my experience, no legacy. Well, and I think to clarify, I saw one of the comments of someone in YouTube is that legacy is whatever we built yesterday.
Yeah, sure.
And it's true, no? But I think for the sake of what we are describing right now, legacy is a little bit more older than just what we created yesterday. It's something that is hard to change, and that we know that we need to change, but it's hard. So it's just I think that's what we are calling legacy right now. I don't. Sorry. Go ahead.
Oh yeah, I have just one good comment about legacy. It's from Kelsey Hightower, and he once said on one of the conferences. It's actually good if your project have legacy. It means this project actually makes money. So if you don't have legacy, it's a kind of strange system. It looks like your business not making any money. It's way to nowhere, I guess.
Yeah, good point. Let's go for our next question for Pranjal specifically. Do you have any tips for managing conflicting opinions from multiple stakeholders?
Yeah, I really had that kind of conflicting opinion multiple times. So one of the tip I followed is like try to come up with the facts. So whenever you are proposing solutions, and that majorly comes when we are trying to propose certain changes to certain stakeholders, they won't agree. So at that time, probably coming up with different options and dealing with those pros and cons, and bring them everywhere, like at least in a common call. And then probably that is where like it's really the crucial conversation you would need to deal with. But providing data, enough facts really helps you to have that conversation little smooth. And sometimes you would need to take big pauses if things are not going into that way. I had experienced that, but eventually I started learning. I used to get very frustrated in the starting stage, but soon like coming up with more data really helps.
Yeah, no, that's true. That's true. Another question, what is the difference between non-enterprise and enterprise world from your point of view, Pavel?
Well, I think in current role, I have I'm touching both of these worlds. First, I have a couple teams actually who work in non-enterprise settings, typical web development and stack of technologies. On the other hand, I have a team which work and support SAP system. It's typical enterprise. Well, the way I see how the things work and what the difference is, first of all, non-enterprise is more about agile and totally different approach to how the task is done. In enterprise settings, it's more waterfall kind of type of workflow. We plan, we architect, we kind of move step by step, and finally we will get our result. With non-enterprise, we can start doing something without even clearly understanding what we're going to have in the end, and eventually we will again reach the goal. Maybe it will be totally different product compared to when we began this kind of work. So more flexibility in non-enterprise, less planning, less architecting, and by feel it's faster. We deliver in small chunks, faster, role changes faster, stuff like this.
Okay, thank you. Pranjal, another question is related to the approval process. So we saw the tools, no, the Miro, Lucid Chart. So those diagrams are presented to the stakeholders. So what is the approval process, no? And at what moment you have the final document? This is what we are going to do.
Okay, so it was really continuously iteration, I would say, even when we were into the sprints of actual development. So I think it was not really the complete waterfall model we were following. It was like getting iterated as we were really coming across certain hurdles and so on. So at the start, like when we started with actual development, we did had version 1.0. This is what we are gonna do. But then we came up like 1.1, 1.2, 1.3, and so on.
Okay. Let's see now again, legacy. It's still on legacy and refactoring. Do you have any compelling tips for moving companies to the cloud? Is there any better option? Pavel? Let's start with you.
Moving to the cloud. Well, I worked in, I think, in both settings, on premise with data centers when we build and own them, and with cloud. Well, personally, the way the things are, cloud is not an option for most of the companies here where I am, and but well, any tips? I think most important here is to actually take an Excel or Google Sheets and kind of do the math, very hard math about what it's going to be about amount of data you going to put into the cloud storages, amount of virtual machines you're going to need, and that it's. I think it's most important before making any decisions, because cloud is totally different compared to traditional data centers or on-premise systems. You have different structure, cost structure of price of I don't differently structured price of ownership, basically. So I think it's most important here. Better option compared to moving to cloud. Well, it's actually depends. It's if let's say small companies, usually it's easier to use cloud because, well, usually don't have big ops team to support a lot of infrastructure to build your own network. It's crazy expensive on the small scale, and cloud here is really helpful. When company gets bigger and bigger and you start to think about what if we gonna put our own hardware, and you can afford it to support it, because at least you need to hardware team in data center to be able to replace hardware when you need it. And math shows that this approach may be better for you, and yeah, maybe it's an option. There's a lot of companies who kind of work in hybrid settings, but it's usually big companies who can afford again use cloud and have own data centers. That's it.
Okay, thank you. Pranjal, any comments, maybe from the point of view of this talk with the stakeholders and the business or enterprise architect?
One of the thought I was like Pavel mentioned, hybrid approach. So if you can start with that hybrid approach where you can start containerized few things, so that eventually if you make that decision, if things work out with the budget, etc., you will have starting point which system you can get it on cloud. It will not be one big bang approach. Rather, you can start in smaller portions, and getting started with containerization really helps there. Yeah.
Yeah, exactly. And from what I can tell you is on the experience, and mostly assuming that legacy is a monolith, and maybe your goal is good to go to a cloud to cloud and stop being a monolith. The way we had to do that kind of thing, it was like following some patterns and known ways to work. No, so putting this what is called the strangling pattern, I think, where you put your monolith and in front of their proxy, and then you start doing the routes and separating. Or I think that's, and it's proven. No, it's something that works. It's probably it helps because it's transparent for the end user, and so you can keep working in behind the scenes, and for the end user everything is still working the same. So that will be my advice on top of what you guys said. I have one question, Pavel. One of your slides, you said that the perfect is the enemy of the good.
Yep.
And yeah, at first sight, I think we all try to do the things the perfect way, but we know that trying to do that, it takes a lot of time, or there's no way we are going to do that. So I trying to understand exactly what you mean by that, because how you define when is enough good.
Well, it's difficult, really. Well, I try to aim as high as I think is good. Kind of raise the bar very high, and then I just try to make it work in timeline, amount of resources, priorities of the business, all the things around, by carefully prioritizing, stripping kind of extra pieces, and eventually I just accept what I have in the end, and it's not perfect, because obviously circumstances, and I always try to analyze, have I done enough to achieve that perfect goal, and what should I do better next time. That's it.
Okay, thank you. Pranjal, here's another question for you. As an enterprise architect, what is the best way to manage context switching? Enterprise architects will have many teams to deal with.
Yeah, that is like tough one, but what I really tried and it worked well is like how much you can really handle as a part of the day. So I tried to say no for certain things if my brain cannot manage those things into that day. So I think that is sometimes good approach, because too much context switching will probably create more time, which you would need to get to a perfect solutions, or solutions, I would say, not the perfect. But if you add more context switching, probably you are going to delay it further. So sometimes, rather than context switching, you can delay that context for next week, for example, or next day. That way you will be able to complete the things which are you are in your plate. And again, you would need to understand a couple of other factors, which are the priority, what are the timelines you're dealing with particular teams, and based on that you can decide the priority which next you are gonna prioritize. So as a EA, at least I had learned you would need to manage not just your days, but even hours. So if you are gonna do the context switching, make sure you have certain gap in between so that you are gonna close the AIs coming from earlier meeting, and then you will have some time, at least 5 minutes break in between to switch that context. And another small tip I started following is like, rather than having full hour meeting, probably you can have it for 50 minutes. So 10 minutes you will have it to capture those AIs and get prepared for the next meeting. It's very small tip, but very useful.
No, that's right. That's right. Okay, dear speakers, thank you very much for your time. I think we are wrapping up because we addressed most of the questions. There are some others, but I think we are going to run out of time if we keep going. I really appreciate all the time. It was very insightful and interesting talks. I think we all appreciate that, and see you in the following sessions and days. And thank you very much for your time.
Bye.
See you.
Yeah, okay. I hope you hear me.
Yes.
Yeah, thank you very much for your moderation, Hugo. And yeah, I just wanted to say to everyone that we will be switching to a different YouTube link, and don't lose us. Like, if you are watching on our platform, continue to stay there. You have a geekle.us/dashboard. You're on stage. We'll continue right there. But if you're watching on YouTube, please, down there you have a link to part 2. It should be also in auto switching. It should be working for you. It's also in the playlist, and you should receive an email in like 10 minutes or something. So yeah, we're gonna have like a 10, 11, 12 minute break, and then we'll have the next block of speakers with a very, very amazing moderator, Adrian Kearns. I'm looking forward to seeing here today with us. But for now, giving you some brief moments to get some rest, to maybe do something, get something to eat. So yeah, see you back in 10 minutes. Oh, no, that's not it.